everyone, I welcome you all to the live session on Python tutorial by Intellipaat. This session is conducted by multiple programmers having more than 15 plus years of industry experience. Now let's see the agenda of the day. Firstly, we will begin with Introduction to Python. In that we will tell you what is Python and what are the new features of Python program. Post that we will be learning about data types in Python. Post that we will be learning about conditional statements and data structure. After that we will be learning about Python threading. Post that we will introduce you to Python Matplotlib along with a hands-on demo to give you a better understanding of the subject. Then after that we have covered Python interview questions and answers as well. So guys, this is the agenda of the video. Now let's begin the session.
What is Python? Well, ladies and gentlemen, you need to understand that Python is a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where we don't use very complex syntax to work with. It is easily understandable and provides very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C#, or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this, and Python is open source if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. We've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. There are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much probably equivalent to putting out an output which gives out hello world. You can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, basically Apple's operating system, and you can use any of your favorite operating systems. In fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the number one language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. And of course, coming to artificial intelligence. Well, ladies and gentlemen, I know you guys might be waiting for this at this point of time. Hey, what about data science? What about artificial intelligence? And much more? Well, here it is. You must learn Python today because Python is one of the most preferred language in today's world to help achieve artificial intelligence. So where is artificial intelligence implemented? Well, look around you, look at your smartphone, everything from Siri, Alexa, all the way to Google Maps, Amazon. I can go on naming thousands of applications of artificial intelligence which has been so subtly integrated into your life. You have to even understand and contemplate to see if something's AI or not anymore. That's how well it's all been implemented. So on that note, there is a 44% enhancement when you put artificial intelligence and help with the current products which are already existing. And AI will of course optimize all of the internal operations in an organization by up to 42%. AI will help make better decisions, and of course AI will help pretty much optimize all of the external operations which take place. And this is a very important point because you can see a 31% increase there. And of course workers will be free enough to make sure that they spend their time, their efficiency, and much more to actually be creative instead of doing some redundant tasks. Well, now where does Python come in? Well, you need to understand that Python gives you a very efficient way to work with data. And when you're working with artificial intelligence, it is of course in no doubt that you'll be working with a lot of data. To ensure that you can handle all of this data with ease, Python has got us covered. And then let's talk about the library ecosystem of Python. Python has an extensively huge library system, and pretty much we're going to discuss about the libraries as well. But then at this point of time, you need to understand that all these libraries which are pretty much given to the developers, the frameworks or whatever it is, all of this is helping us get closer to making artificial intelligence more intelligent, if you know what I mean. And of course, it gives us beautiful visualization tools. And compared to any other programming language, there are languages like R as well, of course, which are on the boom right now. Python is again another standard when it comes to using visualization tools. And again, this in my opinion forms a very important reason for you guys to jump on this, because as a learner, as a developer, as a person solving a problem in your company, you will require an efficient way to process the data, you will require a large ecosystem, you will require very good visualization tools, and at the end of it, there is something even more important, is community support. Since Python is an open source language, it is the number number one programming language. Again, thousands of people pretty much start out with Python and learn Python on a daily basis, help each other solve the problems as well. In fact, we have the Intellipaat community where we actually cover Python as well. We cover all of the IT related concepts in depth in the community section, where we have people from across the world coming in to help each other's problems out. So make sure you check out Intellipaat's community after the session, ladies and gentlemen. And coming to the next point, Python has another strong footing in today's world. As you can see from the title, it is web development. Python provides us with so many nice frameworks to work with. Everything from Django, we have Flasks, we have Pylons, and we have Web2Py. Basically, all of these are tools to ensure that Python as a programming language can help in web development. The introduction I gave you to Python said Python is used for web development and app development. Well, you can see all of the beautiful libraries that Python provides us for web development on your screen right now. Django is amazing to work with. Flask, again, if learned, you can create very beautiful applications using that. Pylons, of course, and at the end of the day, even Web2Py as well. Well, at this point of time, my goal is not to overwhelm you guys telling you all about what Python is and what Python is offering us. Well, I'm trying to tell you the potential of Python, ladies and gentlemen, and I know that it is amazing as well. Coming to big data, of course, the entire world is a big data problem. Look around you. There is terabytes worth of data being generated every single second. We upload a picture to Facebook, we upload a picture to Instagram, we might sing and put something out on SoundCloud or whatever it is. You're putting in a lot of data out there on the internet, and it's just not you, it's the entire world population, a majority of the population who make use of all of these apps. So when you're looking at that, pretty much there is a lot of data being generated. And how does Python help? Well, as I mentioned, Python is amazingly easy to work with. It is all because of the libraries and all the support it gets. See, for example, from Apache Foundation, we have Apache Spark, and we have tools such as Dask and PyDo, which basically help in giving Python the access to basically go on to make use of parallel computing. With parallel computing, you can solve big data problems by breaking down a problem into simple sub pieces, assign it across multiple computers, and have these multiple machines, multiple nodes as we call it, solve the problem for you, and do it in such a way that there is no strain on one single machine doing it, of course. And that's not the only reason. If you're dividing the load among hundreds of computers across a server, 1,000 computers for example, you have that much of power, 1,000 times of power, 100 times of power, whatever it is, to give it to you in the most simple terms, ladies and gentlemen. So handling big data with Python is a breeze, and companies are looking out for all of these, and they want you as a big data expert there. So if you want to become a big data expert, you need to understand all of these concepts, and to understand all of these concepts, you need to first set across a programming language through which you're going to work, and use all of these frameworks that come with it, and go on to make use of it, right? So basically that is exactly what I'm trying to tell you guys here. When you hone in on a particular language such as Python, you have all of these beautiful frameworks to work with at the same time. Then coming to data science, of course, I've put in a fire emoji out there to tell you that data science has been on fire all of 21st century. Data science is pretty much booming right now. And in fact, guys, if you do not know, data science is being actively used right now to fight the outbreak of the coronavirus, which is spread across the world. And we have an entirely in-depth session covering basically on how machine learning and other technologies can actually be used to help fight the coronavirus, or COVID-19 as it's called as well. So make sure you check it out after this session. And of course, coming to why you should learn Python in terms of the data science aspect, well, again, it provides amazing libraries to work with here as well. For numerical computation, we have these two beautiful libraries. It's Pandas and Numpy. Both help in amazing numerical computation. And when you're working with a lot of numbers, when you're working with data frames, data sets, whatever it is, these will ensure that the same level of readability is met, and that of course you can efficiently handle all the data with ease. And then coming to data visualization, ladies and gentlemen, we have Seaborn and Matplotlib. These two are very famous tools which are basically used to perform data visualization when we're talking about data science, when you're talking about Python, and when we're talking about solving most of the data cases of today as well. Well, as I mentioned it before, let me strengthen it again. Python is the number one programming language out there as of now for data science. And if you are capable of handling numerical computation, and if you can understand and produce very good data visualization methodologies, of course you are preferred by all of the top hiring companies out there. And this brings us to all the skills that is actually needed when you're working with Python, when you have to begin working with Python, or even general aspects of a programming language such as Python. So the first skill that you will require is object relational mapping, or ORM as it's called in short. Basically, ORM is used to create virtual databases where there is a data which cannot be converted into another type, or if you want to perform some analysis on a data which is present amongst huge amounts of data, well, ORM is the tool to go to. When you're working with Python, there is SQL Alchemy and there is Django ORM, which will basically help you achieve this goal. And it's as simple as that. Coming to skill number two is basically all the front-end technologies that you might be working on in case if you're looking at the web development aspect of Python. It is a must-have that you understand certain tools like HTML5. It can be, pretty much JavaScript. It can be CSS3, cascading style sheets, of course. And there are many other things which you might have and need in your arsenal to go on to become a very good web developer if you're working with Python as well. But then do understand that it is not always the tools which come into the picture. You, at the end of the day, if you're working with front-end technologies by making use of Python at the same time, you will be creating a very good user experience for the person who's going to be watching your website. And at the end of the day, to keep it very structured, you will have a program manager who will overlook all of these, and it is going to be a very structured process of how you'll be going through the same as well. And of course, you will have a scrum master at the end of the day to bring all of these together to ensure that when you're working with a website or a web application, that everything goes smoothly and as the way that it's initially planned as well. So if you're working with front-end technologies and you want to go on to become a web developer using Python, make sure to keep all of this in mind. And of course, coming to the third skill, it's basically all the Python libraries that you have to know which exist. Everything from requests, beautiful soup, we have Pygame, we have Scrappy. So basically from web scraping all the way till building your own games using Python has it all. But the most important aspect of Python, as we've been talking for a while now, is Python for the use in machine learning, Python for the use in data science, and Python to achieve artificial intelligence at the end of the day. So there are some amazing libraries and frameworks here. There's TensorFlow, Keras, there's Spark, again, NumPy, PyTorch, MXNet, Panda, Scikit-learn, and many other Python libraries which will basically help you to pick up one which you like and what you would work with, and at the end of the day, what problem are you trying to solve. So Python will give you a choice of 250 plus libraries where you can pick up one, become a master in it, and pretty much go on to have a successful career as a Python developer at the end of the day. Because there are experts who are wanted for Keras, there are experts who are wanted for TensorFlow, there are experts who are wanted for as Django developers, Pygame for game developers, and there is much more. So you need to understand that all of this are trending. All of these are among the top libraries for any programming language in the world right now, and that is how much Python's libraries have all blown up. So make sure you jump on this and make the best use out of it. The skill number 4 that you need to understand is basically version control systems. So basically Git is among the world's most famous version control system out there, and pretty much this will help you not just as a Python developer but as a programmer in general, because when you're working with Git, there is a lot of structured process which basically happens. It ensures that there is no confusion when multiple people are working on the file, and for example, a file which is already committed and deployed. So basically when a file has been deployed and committed in a separate branch, well, let's say call it the development branch or call it the branch where the data is actually the data which is live on the website or whatever it is, well, this data you're not messing up for testing purposes, or you're not working on it actively, which might actually cause real-time changes to your website. So making use of Git will not only help you with Python, it will help you with all the other programming languages, by helping you stage your content, by helping you track your commits, and to ensure that if there is modifications needed and modifications done, who has done the modifications to what branch at what point of time, and you can even leave comments to the modifications done as well. So this will keep the entire concept of programming and bring it into a world of structure and give it some foundation where there is no confusions, there is no anomalies, and basically no mix-up when there is more than one developer working on something at the same time. So this brings us to skill number 5. Skill number 5 is very important. It's artificial intelligence and machine learning. Why do we keep mentioning so much? Again, as I mentioned, it is the preferred language for AI and ML. It gives you multiple libraries out there. Everything from working with neural networks, working with machine learning, working with deep learning, and as I've mentioned, all the things that follow in these concepts as well. For example, in neural networks, you have convolutional neural networks, you have recurrent neural networks, you have concepts such as autoencoders, you can perform perform time series analysis. So all these fancy terms and concepts, they might sound fancy and they might sound convoluted at this point of time, but they are the foundation of what makes Python a beautiful language to work with. And basically they're so easy to learn. All you need is a structured process. All you need is the right hands-on, the right instructors, and pretty much the right content to help you master a language such as Python. And of course, this brings us to the sixth skill, which is communication. This is the most important skill if you're looking to build a very serious career in Python. Well, why do I say that? Because, ladies and gentlemen, let us be very honest here. If you're working for an organization as a Python developer, there are chances that you will be working in a team and you will not be doing everything solo. If that is the case, you need to work amongst your team. You need to work among multiple other teams. See, for example, if you're a web developer or a data scientist for that matter, you'll be working with the data ingestion team in the morning. You can be performing analysis, writing neural network models in the afternoon, and at the end of the day, you might be creating very good visualization by using multiple tools out there, Matplotlib or whatever it is, and you can be presenting all this information to a non-technical audience. You as a programmer will understand all of these concepts because probably you've been working on it, you're trained on it, you're certified on it, and whatnot. When you're explaining all of this to a person who might not know it, there lies a small challenge. So communication plays a very important key, not just when you're becoming a developer in Python, but then when you're becoming a developer in general, ladies and gentlemen. So on that note, what are some of the key takeaways that you can pretty much notice at this point of time? The first thing that I can tell you is if you are willing to take up Python seriously, or if you want to understand why you should pick up Python, first check if you have the problem solving skills, if you have an interest towards solving problems, because Python at the end of the day can of course be used for recreational programming. It can be used even for competitive programming as well, and most of the time it is basically used when the problem statement comes up and how you can use a programming language to solve that problem. So make sure you ask yourself if you have the intent, if you have the interest to solve problems. And then programming, of course, since Python is a programming language, one of the top in the world, you need to make sure that your game is up when you're working with programming. And when you're working with a language such as Python, this is very important, ladies and gentlemen. The next point is communication. As I mentioned, communication is very important. It is key. And when you have to check out how much there is to learn, pretty much I hope you guys were not overwhelmed with all that was shown on your screen, because again, 250 plus libraries, as I mentioned, is a lot. And you might be wondering, do I need to learn all the libraries? Well, no, you just need to start by being eager, by being curious, by checking out what Python offers. What do you like with respect to the language? What do you like to do? And how can Python help you get to your goal? It is as simple as this. Ask yourself these 4 questions and pretty much this will help you to the maximum. So on that note, let us quickly check out a demo. I'll be showing you how elegant it is to work with Python by picking up a problem and solving it using machine learning as well. So guys, the point of this demo is to ensure that you guys get to understand how easy it is to work with Python. Of course, we can work on a very complex data set, we can work on a very complex demo basically, and the point is to not overwhelm you. The point here is to ensure that you get a clear understanding with respect to Python, with respect to its usage, and all of us basically like less code to achieve maximum efficiency and to solve the problem, right? So nobody wants to write 10,000 lines of code if it can be done in say 2,000 lines of code, and that exactly is your takeaway after going through the demo session, ladies and gentlemen. So basically we're going to try to predict to see if a person has diabetes or not, or check the onset of diabetes basically by making use of machine learning with Python. Even before we begin, as I mentioned, Python and machine learning has been amazing. You have multiple libraries here. You have one amazing library to work with machine learning, and that's scikit-learn. Scikit-learn is pretty much used 99% of the time when you're working with machine learning, or you have a requirement where there's a problem and you have to solve it. So let's go on to understand and check how we can basically make use of machine learning to solve the problem for us. So basically, let us go on to check what is the accuracy of detecting the presence of diabetes. Diabetes is again a rising concern in my opinion. Be it a country like India, be it a country like USA, or let's say anywhere across the world, diabetes is a very deadly disease, right? Pretty much it is the condition where your body cannot maintain the blood sugar, and this will cause a lot of havoc if you're not diagnosed and if you're not prepared for it, or if you've been ignoring it for a while. So at the end of the day, it is basically your job to ensure to see how you can bring the world of computing and medicine together. See, medicine is a field where it's thriving on its own, and pretty much, it can do really, really well with or without the help of computing. Let's be honest. That is how it was for the last 100 years or so. The field of medicine has been grown exponentially. Coming to today's world, medicine alongside data science, medicine alongside the power of computing, it has stepped up the game of medicines to another level. And I'm sure over 70% of the doctors are going to agree to this, because again, to give you another case, in 2019, pretty much data science helped the doctors figure out the onset of early breast cancer in all the patients, and it sort of gave away a probability of 55 or 56% of detection. Ladies and gentlemen, we're talking about cancer where 1 or 2% can be can add a lot of things to your life, and it can take away your life as well. When you're thinking of numbers at that scale, you need to understand a 55% of probability to a patient saying that, hey, you have malignant cells in your system which might hurt you, or you have benign cells, they are not cancerous, they'll not hurt you, and all of this, giving this hope to a patient and then proving it with respect to validation. That, in my opinion, is very, very important usage of computers with the field of medicine, ladies and gentlemen. So without further ado, let's quickly jump in to understand how we can go on to predict diabetes with the help of machine learning. And the step one of any programming language, the step one of any problem statement is to understand the problem statement. And as the problem statement that I have mentioned, we need to go on to see how we can make the computer understand that, right? That's the point. Well, let's begin. Well, step one is to basically, import all of the libraries that you'll actually be using. So it is a common programming practice to all the beginners who might be watching this session that you import all the packages that you think you will require at the starting part of it, so you don't have to keep doing it at every point of time. So the step one is pretty much very important, where we're importing all the packages such as pandas and numpy for data handling and numerical computation. As I mentioned at the start of the session, we'll be using Seaborn and Matplotlib as well to show you some very good visualizations. Scikit-learn, which is a very important part of machine learning, as it poses to be one of the top libraries, as I mentioned. And of course, there is one single line, since we're using Google Colab out here. Google Colab is basically a Python Jupyter notebook, you basically hosted on the cloud. So we have another thing, we're importing basically files which will help us upload files and help Google Colab talk to our dataset as well. So after importing all of the Python libraries, we need to go on to actually load the dataset. So loading the dataset is basically the operation of inputting our files which we'll be using. In our case, we're going to be using a diabetes prediction dataset. So let me quickly go on to import it. So basically using files.upload, it'll give us a very, very easy way to go on to upload these files. And as you can see, the file has been uploaded, and our dataset is there. So your question will be, what does the dataset look like? Well, can you talk to us a little bit about the dataset? Well, of course, ladies and gentlemen, you have multiple aspects of this dataset. And as I mentioned at the start of this project, basically this dataset is a very simple dataset. It does not require a lot of cleaning. Data cleaning forms a very important aspect of working with machine learning, working with Python, and this dataset is pretty much a simple one. So quickly going through all of the features that we have the pregnancies column, which basically describes if a person has had a pregnancy and if the person has been pregnant before, and the number basically indicates how many times the person actually became pregnant. And glucose will basically give you the glucose level on what was tested at that point of time. Blood pressure, again, as we call it as BP, is basically the diastolic blood pressure which was measured at that point of time. And again, we have the skin thickness, which is very important to understand the levels of fat. Again, the levels of insulin is basically generated by the human body, and it helps regulate sugar levels, and it can be picked up from a serum test as well. Coming to BMI is basically body mass index, and an average of 25 BMI is considered to be a healthy person. Anything less than that, you might be undernourished, and anything above that, you might be considered obese as well. And then we have the diabetes pedigree function, which will basically tell you if there was an onset of diabetes in your family, because diabetes is something which is hereditary, as you might have read on the internet by now. So this basically will give us an understanding to see if it ran in your history, to see if it ran in the family history before. And then coming to age of course gives the age of the person, and the outcome. The outcome is to basically check if the person is basically predicted to either have diabetes or not. 1 indicates the person is predicted to have diabetes, and 0 is the outcome where we detect that the person has not had diabetes in their life before. before. And then of course, coming to description of the data set, let us actually go on to use some concepts of descriptive statistics here. So descriptive statistics is very simple. We're going to be analyzing data using statistics. Everything from the count of occurrence of that, what is the mean of all the values in the columns, what is the standard deviation, what is the minimum value of occurrence, what is the maximum value of occurrence, and of course, you can go on to check the 25%, 50%, and the 75%. It's called as the IQR interquartile ranges of all the data as well. See, some data might not make sense. Let me point out something really quick. Insulin will never be zero in the body. BMI can never be zero in the body, and you can see that there are minimum values here. And as I mentioned, you can go on to perform complex analysis to remove all of these values to pretty much ensure that they won't hurt your data later. Well, why do I say this? Because data cleaning is probably the most vital step for a data scientist out there, and data cleaning is very important when it comes to basically telling your model to give out accurate results, and basically it'll help your model learn better as well.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And this, of course, brings us to step number 3. Step number 3 is where you'll be splitting your dataset into two. We call it the testing dataset and we call it the training dataset. Why do we do this? Well, we need to train the model based on some data and later verify it to see if it has learned something or how accurate that it has learned, right? So basically here, we make sure that, we split the data into a training data set. We basically split the data into a testing data set, and we can go on to perform analysis further. And the most important thing is that you need to go on to distribute it, and not just basically pick up the data. Hey, first 10 columns and the first 10 rows of these columns, let's split it into the training, remaining let's go to the testing data set. Well, no, we can actually go on to randomize all of this and distribute it with respect to the testing data set and the training data set. Well, this is basically done to ensure we can add some sort of randomness to our testing and our training data sets at the end of the day. And ladies and gentlemen, welcome to step number 4. Step number 4 is where all the magic is happening. Here is where machine learning is coming into the picture. So basically, we're using something called as GSCV for performing evaluation to see if a model can learn something and understand something. What is GSCV, you might be asking? GSCV is basically one of the amazing techniques. It's called as grid search cross validation, and this technique is used to understand what parameter can be used best, and how you can go on to evaluate what parameter will give you the best results at the end of the day. So you might be wondering, can I use just body mass index to check if a person is diabetic? Can I just check out using blood pressure to see if this person has diabetes or not? Well, with respect to grid search cross validation, your data, since it's being split into the test case and the training case, you can basically go on to tell your model to effectively use this validation case, which is basically the test case, against your training case to make sure that your model has learned well. You can go on to use multiple other things as well. There's something called as k-fold validation as well. With respect to k-fold, your testing data set is broken down into small chunks, and basically it is n folds times which is run across the training data set. What I mean by that, k is the number of times you want to run your testing data sets across the training data set. Well, again, not getting into all the details to basically overwhelm you again. To keep it simple here, we'll be using cross validation, and by making use of the gradient boosting classifier, we can ensure to find and evaluate what are the best parameters and how we can go on to use them to accurately detect the onset of diabetes. So let me quickly run this, and ladies and gentlemen, as you might know, this is the process where the machine is actually learning, and it's performing analysis by going through all of the data. And this is very important to know that this might take a small amount of time. I am thinking in my case this might take about 2 or 3 minutes, so we'll be back as soon as we get the results. So as you can see, that took about 3 to 5 minutes, I would say, and pretty much you can see by making use of grid search, we can get to a number where we can understand the accuracy of learning. But then we can go on to improve all of these. There are concepts such as hyperparameter tuning and everything, which I will not explain in detail. Again, we have in-depth videos just to understand hyperparameter tuning. We have in-depth blogs as well. So pretty much, you can go on to learn. And if most of you are beginners, or if you're looking as enthusiasts or learners of an intermediate level, you might not go on to understand it completely as well. So at the end of the day, we have a prediction here, and the first step you need to do when you have a prediction is basically store the prediction. We can put it in a variable and store it, and after pretty much storing the prediction, what you have to do is you need to see it. Just seeing it as numbers will not make sense, so let's go on to use graphs, and let's pretty much plot the frequencies against the predicted probabilities. And pretty much, as you can see on the screen, the predicted probabilities versus the direct frequency of occurrence, and pretty much can help you with the presence of diabetes or not easily as well. And hey guys, there's a quick fact pretty much that says that the human brain can comprehend images 3000 times faster than numbers. And pretty much I do believe in that concept as well, because when I see graphs, basically I understand it better. And coming to step number 6, is basically now using different variety of classifiers to understand what gives you the best result, what gives you the most accurate results as well. So by making use of gradient boosting classifier, we've got an 85.2% accuracy. What about the concepts such as a random forest classifier? Again, these are different methodologies which again come from scikit-learn, and pretty much which will help you understand it. Well, as you can see on your screen, with respect to random forest classification, we have a 78% of accuracy in detection. What about XGBoost? With respect to XGBoost, whoa, we have almost 80%, 79.6% of accuracy in detection. This might put up a thought in your mind saying, hey, why are we looking at multiple classifiers? Why can't we use the best one to be done with it? Well, ladies and gentlemen, with respect to machine learning, that is not the case. One classifier might not be the best for all the use cases out there. So what we try to do is we put in the other classifiers out there. We make use of 5 or 6, in fact more than that, 7 or 8, to basically understand what will give out the best results and what will basically help the machine understand the concept better and give out more accurate results. Because at the end of the day, we're looking out for the most accurate results we can get our hands on, and that is one of the reasons why we go on to use multiple classifiers as well. So you might be wondering, what can we do any further with this project? Can it be built better? Well, of course, you can perform a lot of data cleaning for that matter, and pretty much you can go on to use many other classifiers as well. You can use k-nearest neighbors algorithm, which is basically KNN. You can use concepts of perceptron. You can make use of the concepts of decision trees and many other methodologies to check their performances, see what gives you the better performance. And in my opinion, gradient boosting, random forest, and XGBoost pretty much gave us high numbers of accuracy for this particular case, and I thought it was fitting enough to show you guys this. Well, as you can see, it is pretty much very easy to go on to work with machine learning with respect to Python.
Now let's take a look at the features that will be available in 2021 in Python. Python is very frequently updated, so new features are going to be available with every new version, and old features are going to be deprecated in every new version. So we recommend you take a look at the new feature list in Python whenever new version releases. So Python will have several features added to it in 2021. So one of those features is bit count, then there's strict zipping, and then there's the read-only proxy of dictionaries. Firstly, it's bit count. So as we know that computers don't really understand the source code that we write. To it, it's just a large blob of text. It's the job of the interpreter or the compiler to convert the code that we write into machine code. Machine instructions are at their very basic level written in binary. Binary is a number system which works with either 0 or 1, and it has a binary digit system. Binary digits in short are called bit. So if you ever hear 1 bit or 2 bit information, you mean there are 2 binary digits that represent the information. Both of them could either be 0 or 1. Now the bit count function is there so that you can count the number of ones in a binary format of a number or a string or whatever. So once that code is getting compiled and the value that you have is compiled, what will be the number of bits or ones in the entire string? Don't worry if you don't understand it. We'll take a look at that in the hands-on section as well, so that you can get a better understanding. Then comes strict zipping. in case you have not heard of the zipping before, you might not have used Python that much because zipping is by far one of the most common things that has happened. So zipping basically allows you to create a tuple out of two lists. If you have two lists with different values and you want to create tuples of the same indexes, you use the zip function. Strict zipping basically means that if the lists that you are providing to zip are of different lengths, you will get an error. Before this, what you would have to do is you would have to check them manually and say, okay, this is not working. You have given us different length of lists to zip, and we can't process this list. And then you move ahead. But this was a check that you have to do on your own, and sometimes you'd forget. So in Python, they have added this new feature in which when you create a dictionary, when you create a zipped version of two lists, you will have to provide lists of same length. If not, then you will run into an error, and we'll take a look at that as well. Finally, there are the read-only proxies of dictionaries. So in dictionaries, many times we want to create a read-only version of the dictionary. Now there are ways you can do that, but it's difficult to create a read-only version of a dictionary right at the beginning. So in order to use it correctly, we will have to use the newer versions of Python because they come with a feature set that allows us to do that, and we'll take a look at that as well. So let's get started right from the beginning, and let's have a hands-on in which we understand all of this. So let's get started. Now for the hands-on, you would have to install Python. So let me just show you. You have to go to this programming python.org website. Here you can download the newest version of Python, and if you want to follow along, you can do that here. The code you write here is going to be interpreted in Python 3.9, and we want to use the latest pre-release version. So go to the download section, click on the operating system that you want to use it for. I will be using Windows. If you're on Mac, you can use it here. If you have some other platform like Linux, you can click here. So I go to Windows, it opens it up, and it shows us look into this section which is on the right hand side. It's called the pre-release section. The stable releases are the versions that have been checked and all the bugs have been removed that were reported while the software was being developed. On the other hand, in the pre-release section, we might have some bugs, but you can try out the new features as well. So you can go here in Python 3.10.0. Before that, you would get Python 3.8.7 release candidate 1. But we want this to be the one. It was released on 7th of December 2020, so not too long ago, and you can download the installer here. If you want the help file, it's available. If you want the embeddable package, it's available as well. Choose the architecture correctly, install it, and you will be good to go. I have it installed and running, so I'll just show you what it allows us to do, right? So the first thing that we have to take a look at is something that we refer to as a bit count. So let me just show you. So I will create a number and I will save it inside X. Let's call it 108. Take a look at 108, and we have the value embedded in a variable X. Now, if I want to take a look at its binary representation, I have to use the function bin. This has been available for a long time. This is not Python's current version. As you can see, we have 1, 2, 3, 4 bits. So if I want to check how many ones are there, all I have to do is type bit count, press enter, and I get 4. If you are using some other version, as you can see, this is Python 3.10.0 A3. A3 is the third alpha version. If you're using older versions of Python such as 3.9, you might run into an error saying numbers don't have a property or a method named x.bitCount. So in that case, you would have to upgrade. So this is how it happens. Now, if I were to change x to be equal to -108. Now, if I were to go back, take a look at the binary representation. It's the same thing, but I have a negative symbol added at the beginning to show me that it's a negative number. If I take a look at the bit count again, I get 4. So the number of binary numbers that are 1 here is the same. There's 3 zeros and there's 4 ones. So that's one way you can do it. So how does it work? Well, in a very basic sense, the way it works is what you do is you calculate the binary number, it returns a string, and here what you can do is you can just count the occurrence of 1. This should return the same thing, which is 4. So in case you're using older versions of Python, you can just create a function on your own, call it bit count, so just call it def bit count get a number, and here all you have to do is return the binary representation of x and then count 1 in it, right? So if I go bit count 108, you get the same thing. So if you're using older versions of Python and you want to use this feature, this is available for you to use it this way. All right, now let's take a look at zipping. Again, for those of you who are unaware of how zips work, let me just show you. I'll just scroll down a bit. Create a zipped version. I need to create two lists. I'll call them A. A is going to contain, I'm going to call it small a. Now I'm going to create few things here. I'll call them names. So John, Jane, Jenny, and Johnny. So we have a list. I'll create another list. This will be called three things. We'll call it the number of the percentage that they acquired. So let's say 88, 44, and 98. So I will only keep three here as of now. Let me just add one another to show you how this works. And 77. So I have two lists, A and B. I want to create a tuple of these two values, these two values, these two values, and these two values. The code I would have to write for this is going to be a little cumbersome, but since Python provides me with the zipping feature, all I have to do is pass in A and B, and it returns a zip object. If I want to create a list of the tuples, I can do so as well. It's going to be list. There you are. John has 88 percentages, Jane has 44%, Jenny has 98%, and Johnny has 77. As you can see, the corresponding values are being used. But suppose instead of B being this, I change the size. Now it's the length of A is 4, length of B 3, and length of B is equals to length of A. We are going to get false. But if I try to create a new list of zip and A, then I get only three values. So that's the thing that you have to understand when you're trying to use zipping. One of the values get removed from this. So this is how it works. But if I want to be a little strict here, I can pass in a parameter in the zipping function, and I'll call strict is equals to true. Now I have passed in. So argument 2 is shorter than argument 1. So I have both the features. Earlier this feature was not available, and passing strict is equals to 2 was going to raise an error that it doesn't understand what strict means. But now since I have two lists that are of different lengths, if I want to opt in for stricter versions of zipping, then I can do so. The reason why this was added, strict true, was because to make it backwards compatible, so that other code that used the older syntax in which different lengths would be accommodated for, in cases like this, they would not want to break the older code but just want to add a new feature, and that's the way they chose to go with it. In case we were doing this, then we would have to just create another function, call it strict underscore zip, passing A and B, def stri strict zip A and B, and then I have to just check if length of A is not equal to length of B, then I have to raise an error or something like that. So I could do it like this, or I can, here I have to use the word except and throw a new exception. Now that's possible, but I won't be doing that. So that's how you can do the new zipping feature. Finally, the third thing that we have to do is take a look at the dictionary. So let me just show you how that works. First things first, I have to create a dictionary. Now again, the same way I did earlier, I had two lists. I'll create a dictionary out of those. So if I pass in dict with A and B, I think yeah, so because they are of different lengths, it's not going to work. So let me just take a look at it. I'll just create a dictionary easily. Jane had 88%, John had 44%, Jenny had 87%, and Johnny had 98%. So let me just store it inside this is a dictionary that I have, but right now I can change the values if I want to, whether knowingly or unknowingly. So for instance, instead of John having 44, I can just make it up to be 77, and it works the same. Now the dictionary has been updated, and it could be a problem if you are someone who doesn't want to change that. So that's the way you can do that. But if you want to extract these things, let's take a look at that first. So first of all, let's take a look at how you can extract the keys. So d.keep, and this is how you get. For values, you just have to type in d.values, and you get the values. So these are two different types, dict keys and dict values. So after getting these things, if I want to create a read-only proxy of the original dictionary, all I can do is just create a new dictionary. I'll call it d.mappings. And it's getting me an error because I have to do it on values. So let me just do it here. VALUES and then do it. Oh, and it's mapping, not mappings. Sorry about that. If I press enter, this is a mapping proxy. So if I want, I can just take a look at how much did Jane get, it's 88. How much did John get, it's 77. If I want to delete, I can't do it because mapping proxy does not support item deletion. So I can't delete the items out of it. So that's the way this works. Again, these are not fit for being used in production. So we recommend that you don't use them in production, just use them where you can. Just try them out and see if this works.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So, coming to the important aspect of this particular video, what are the steps that will help you land a job as a Python developer, guys? So, I've broken it down to a couple of simple steps, and I believe the first important step here is to master the basics of Python. Because I've seen a lot of Python developers in my time pretty much aiming for jobs at Fortune 500 companies, and they have a very strong foundation of Python. And I asked around a couple of guys just before I came up with this video, and everyone suggests that you need to be really strong with all of the basics of Python. Probably with respect to intermediate components and advanced concepts, you can pretty much learn it from a certified organization and get certified with respect to the same. But having and mastering the basics is a very important first step, which will pretty much help you land the developer job, guys. And coming to the second most important step here, which I believe is knowing all your data structures, guys. Because if you've ever interviewed for an IT job or a job which requires a developer role, then pretty much you already realize that everyone emphasizes a lot on data structures, right? So data structures, people believe it is a very alluring concept. It just goes around people's head and people think it's very tough. Well, guys, it actually isn't. You just need to understand. If your foundation isn't really good, you will find a lot of difficulty with respect to data structures. And hey, it's always good to go back to your roots, right? So if you're not strong in data structures, just head back to your basics, learn everything again. I mean, there's no harm in learning it again, learning it right. So you need to have the data structures knowledge, and then you need to know that a couple of data structures in Python. We have lists, dictionaries, and so much more. So you need to know how all of these works, and just not just knowing how they work, but then knowing how you can make use of them efficiently is again the second most important thing with respect to making use of data structures using Python, in my opinion, guys. So you need to know how you can turn a pseudocode into an algorithm into flowchart, probably a flowchart into your Python code directly, and work with your other teams on this as well. And step number 3, this is one of the directions that you can head to, is by learning Django and Flask. Well, these are very well reputed frameworks for web development which support Python, guys. So Django and Flask are pretty much again being used everywhere. It's so subtly integrated that we would actually not know. Let's say as consumers or non-technical people, it is not
not known of what's being used to develop a website or what's going on in the back end, right? So Django and Flask are very important modules, and I believe they're extremely vital frameworks for a Python developer to at least know. I would recommend you just learn the basics of what's going on with respect to Django, what's going on with respect to Flask, and see if you can exploit something out of it, make a mini project of sorts which you can add to your resume and which will eventually give it a lot of weightage as well, right? So this is step number 3, guys. Step number 4. So step number 4 pretty much involves all the majority concepts that you've pretty much learned in step number 3 with respect to Django and Flask, and actually using all of the skills that you mastered from it to perform a couple of web scraping activities from a couple of sites, guys. Well, web scraping, again, there is a lot of jobs with respect to web scraping, which again, which is an amusing fact for me, because I just thought, this was a couple of years ago, so I thought web scraping was a small thing in this world, but no, web scraping has its foot really strong. It has a very good hold in the world of IT, and then making sure that you guys can get to this step, guys, you will need a good web development framework and knowledge in this framework, right? Hence step 3 was an important one. Well, in my personal opinion, step 5 has to be the reason why most of you guys are here, or your goal would be something this, right? To achieve artificial intelligence with respect to machine learning by making use of Python, right? Guys, there are many frameworks and many libraries out here for Python. Again, Python is scikit-learn, TensorFlow, PyTorch for neural networks, deep learning, and machine learning as well. I mean, there are so many frameworks for Python, it will take you a really long time to learn all of these. I mean, my intention here is to not overwhelm you with all of the concepts that are present here, but I do want to inform you that there are opportunities present there and you can exploit it to land a very good job, guys. So step 5 would be to pretty much familiarize yourself with respect to machine learning using Python, because probably from 2017 onwards, this was the most, and this is the most trending thing when someone talks about Python. It's either deep learning or it's machine learning, guys, and we already know the end goal of machine learning and deep learning is just to achieve artificial intelligence, right? So step 5 again is very important, and if you have a certificate that you've worked in machine learning using Python, that's a biggest bonus, let's say, or an upgrade you can give to your resume, and this will help you on your path to become a Python developer, guys. And step 6 is the next important thing after you work on your machine learning projects, is to know that you have to have a couple of projects. Let's say it can be beginner projects, intermediate projects, and advanced projects, right? So you can pretty much go on to build a calculator as your beginner project, have an intermediate project where you just make a game, and then have an advanced project where, let's say, you're doing some binary classification using machine learning, or let's say you're probably making use of recurrent neural networks and so much more. So you need to have some sort of projects, you need some sort of validation, because at the end of it, in an interview, you're just trying to sell yourself, right? Let's say your resume is just 2 pages, so you need to put everything that you've done in these 2 pages and sell yourself to the interviewer to convince him that you deserve the Python job, right? I mean, Python jobs pay a lot, actually, in fact, to be honest, compared to other programming jobs. I am not biased, but I just these are just the facts that are present, guys. And guys, stick to the end of the video where we'll be talking about salaries and so much more, and you'll get to know the figures of what a Python developer earns as well. So this important step here is to tell you that you need to work on some projects, you need to get your hands dirty with respect to code, and then work with it and go with it to pretty much land a good Python developer's job, guys. So after all of these, there are still some skills this is my personal set of skills that I would push for you guys. And the first most important thing is effective verbal and visual communication skills, guys. Because when you're working a technical job, I've been in situations where, people are trying to explain concepts to a non-technical person, let's say in a business meeting or a business review, and those people are not understanding what the developer is trying to tell us. So basically what happens is you need to dumb down your concepts from the world of IT, and probably you need to have that verbal skill to explain your code to a developer and to explain your code and concept to a non-technical person as well. So in my opinion, a good verbal skill is always not just a Python developer job, it's just great to have for any job, guys. And then the second thing is good team working ability, because if you are a hardcore Python developer, then you'll be writing hundreds or thousands of lines of code every day, right? Pretty much you will not be the only one working on an entire project in a Fortune 500 company. You will have a team, you will have a team lead, you will be working alongside your peers. So you need to coordinate with everyone. Then you need to have that ability where you can work together as a team and then just push all your skills together, bring everything into one umbrella and then work with it, right? So good team working ability is what I push for, guys. So, and then the third most important thing is you need to have this interest in collecting and analyzing a lot of data, because with respect to Python, most of the applications are either big data, machine learning, or neural networks. So you need to have this thriving desire to delve into data and understand data better, guys. So that I think is a good skill to have. And then lastly, it has to be good problem solving skills, because if you're taking the machine learning or the neural network path, it's a lot of mathematics and computer science, right? So you need to be very good at calculus as well. So I mean, not just calculus, you won't be using calculus all the time, but then hey guys, you will require that particular skill. And not just calculus, not just mathematics, good problem solving skills in general, guys. And then most of the Python developers have an educational background which is pretty much from computer science, information technologies, or they have a major in mathematics, statistics, and so much more. Well, this is again the requirement from all of the companies hiring a Python developer. Well, if you are not from a computer science background or an IT background and you still learned how to become a Python developer, let's say you just picked up our Intellipaat's certification and you got certified, well, you still apply for a very good job, and then you just need the skills. Well, people these days are not checking a lot of education, guys. They just need the skills that you have and pretty much a good couple of abilities like team working abilities, communication skills, and problem solving skills. And if you're good at this and Python, well, you're just into the organization, right? So on that note, let us quickly check out what a Python developer's resume looks like. Here is a very small sample resume that I picked up. So this person has pretty much worked as a junior Python developer at this company called as NRG from 1 year. She worked as a Python developer at this company called Morningstar in San Francisco. The description pretty much says delivering projects with 1 or 2 days turnaround time or even within hours. So you need to have the ability to sit and code and finish a project having a less turnaround time. Designed and implemented the boot menu in 2-line displays in 3 weeks. So again, that is a very good achievement, probably in 3 weeks for this particular person. And then another Python ongoing job at Makerspace, made over 800 insertions, 150 deletions to 4 central framework repositories in less than 3 months. Took a position which combined 2 roles, Python developers and Scrum Master as well. Scrum Master for a team of 9 people. Introduced a new approach to submit render for layout and crowd department. I mean, this just should give you the overall picture of what a Python developer would do, right? So at the end of it, Python developer you need to be good with your time ability as well, guys. So how good are you at maintaining time? Because as you can see, usually the turnaround time for a Python developer is less, but then this depends on your organization as well. But you need to be good with time, you need to be good with code, you need to be good with working with a team, and that is a very important part of being a Python developer, guys. I mean, you can just check out pretty much you can just Google it out, a Python developer's resume, and you can pretty much go on to read what these people have actually done in their course at the particular firms, and it's staggering to see that the achievements of people can make even as junior Python developers or an experienced Python developer as well, guys.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So on that note, coming to the next concept, pretty much you guys will be wondering by now, so what are the roles and responsibilities of a Python developer, right? I've broken it down to 3 important roles and responsibilities in this particular slide. And the first one is writing effective and scalable code, guys. Because as a beginner and an intermediate learner, you will be learning to just write code. It might not be efficient, it might not be scalable, but then just working more and more on it, doing projects on this, getting your hands dirty with code at a majority part of your time and learning will make sure that your code becomes effective and scalable. Because in an organization, in a huge organization which you pretty much will want a job in, will have a system which is already scaled, right? So you need to make sure that the tiny piece of code that you write will work across their spectrum of devices and networks as well. And the second most important roles and responsibility part is pretty much developing the backend components effectively. Just as important as developing the front end is with respect to an organization, organization, the backend is pretty much neglected, or for the common non-technical person, it is not seen, right? So it is an abstraction for the common user where they will not know what's going on in the backend. But as a Python developer, you must be very good at developing good solutions for backend components and handling them very effectively and efficiently as well, guys. So coming to the third thing, it's pretty much integrating this particular backend with respect to the front end easily. So you need to know how you can go about with a merger with respect to all the backend, let's say databases, data storage units, and so much more. And you need to bring these together with your front end to integrate this well, guys. So these three, I believe, are a very important role for a Python developer, and there are more as well. I mean, you can just go on to find many roles and responsibilities of a Python developer, but I think those three are the most important ones, guys. So coming to a Python developer's job description, here is an actual job description from Accenture. I picked this up from the website indeed.com, which is very famous for searching and hunting for new jobs. And this is their requirement, guys. They say that they require very strong quantitative and analytical skills, and they require 2 years of experience in data science as well. And this includes Python, R, Scala, Julia, or SAS. They require 2 years of implementing and developing projects in using CI/CD pipeline as well. So they require the continuous integration, continuous delivery pipelines here as well. And then they pretty much want you to have experience working with Git, Jenkins, Docker, Kubernetes, Kubeflow pipelines, and so much more. Again, 2 years experience in data science and using statistical methodologies. Well, this is the job description for a plain Python developer, guys. So look at the concepts that they pretty much ask you. You need to know Kubernetes, you need to know Python, you need to have worked with data science. Again, you will require some experience in machine learning methods, familiarity with clustering, regression, optimization, recommendation, neural networks, and other machine learning methodologies as well. Well, as I've been mentioning, machine learning has been a big part in the world of Python, and then if you're strong in that, you can pretty much go on to hunt and get a really good job, guys. So here is another job description from this one's from Bank of America. Well, here they say you need to have exceptional development skills in Python on Unix, knowledge of agile development. Again, these guys need Scrum and Kanban and so much more as well. Solid object-oriented design skills. OO is object-oriented. With respect to distributed low latency, high availability systems, you need to have excellent problem-solving capabilities, analytical skills in a high-pressure environment. You must have a degree in computer science, physics, engineering, mathematics, or an analytical degree as well. A strong understanding of algorithms and data structures. See, I told you. And then a strong understanding of all the design patterns and why there has to be a pattern that needs to be used. Well, this responsibility, this role and responsibility again is exactly what we discussed a couple of slides ago, right? You need to give importance to data science. You need to have a degree in computer science. Well, again, this is debatable. If you do not, then you can pretty much, get there. Because I personally know a couple of electrical engineers who had the interest to pretty much pick up computer science a decade ago, and now they are pretty much, vice presidents of big companies working with respect to Python, working with respect to C# and so much more, guys. So a degree is debatable, but then it would be really great if you actually have that. If not, you will need to work your way up the ladder of development, and you need to prove to people that you can pretty much handle the development job, guys. So coming to the next important thing in this particular video is the Python developer's salary, guys. So in America, in the United States of America, the average pay for a Python developer is somewhere around $95,000, guys. This is American dollars. And then throughout the world, let's say in India, it's about 10 lakh rupees per annum, which is again great if you are just starting out or if you're an intermediate developer. But then this is just the average pay, guys. So the pay lasts from somewhere around 6 lakhs all the way till 15 lakhs per annum for a Python developer from a beginner to an intermediate scale. I mean, if you're an advanced developer, then you can pretty much get a bigger salary here as well. But the comparing the entire world's average, I mean Australia, Europe, London, and so much more, the average base pay per year comes down to somewhere around $92,000. It can go as low as 60,000 American dollars and as high as almost $140,000 per year, guys. So this is really good amount, and you can tap into these with all the potential that you guys have. And I've seen a couple of comments from learners. You guys are just unstoppable. So you can pretty much get here. You can get here really quick, but then you need to sell yourself well. And I believe that having a certification will.
Why you should learn Python. So basically 3 simple facts are out there. First is that it is ranked 3rd in the index of the popularity for programming languages. It is ranked 3rd, and it tops the list given by IEEE Spectrum as the #1 language to learn. So in terms of popularity, as in the number of people who are using different programming languages, and there are a lot of programming languages with different company uses. So there are different companies who have created their own programming languages as well. So a lot of people work on those programming languages. Like there's a programming language called ABAP, which is for SAP, where they do business-based programming, and then there is programming language called Apex for Salesforce. Then there is C++, C, Java, C hash, and a lot of different languages which are out there. Among those, it ranks third in the popularity of languages which is being used, and it ranks number one in the language that you should learn. So since it is very easy to learn, very easy to interact with, so easy to use, that's why it tops the list for being the number one language that you should learn in order to begin your path in the programming field, if you will. And again, coming back to the point, the preferred domains like the data science, machine learning, and artificial intelligence, all inside of Python. And if you talk about it, even the web development, a lot of companies use Django for writing their backend. There also Python, that is a Python library which is again being used. Python there will also help you with that. So why we mention something data science again and again and again is, if you go about by the words of Harvard Business Review, which is given by Harvard, which is an extremely prestigious university, they claim that the data science is the sexiest job of the 21st century. It is the most highest paying job for people who are in the IT sector. So who are doing technical programming, data science is the field which will fetch you the most amount of money, and it has the highest average paid salary across the board, across all the different jobs that you might have. So there are business analysts, there are, let's say, program developers, there is system architects, there are a lot of different people. So in those, data scientists are the one who are paid more on an average than the others. So that is why learning Python is very important if you want to step in the field of data science. Okay, let's move along and talk about the different companies that you will be hiring. So if you see these companies on the screen right now: Facebook, Google, NASA, Quora, Amazon, Reddit, Instagram, Dropbox, Netflix is somewhere, it's an extremely good company if you are interested in data science. They do not pick anyone very easily, because Netflix, again, the data science department is crazy good in there. So these are the dream companies of almost every programmer who is out there. They want to work for the tech giants like Google, Facebook, or Netflix. And going for these if you want to land a job in these places, Python is like a staple that you must have at the back of your hand if you want to apply to these companies and be there as may be as a very good developer for them. Then if you're looking along those lines, you must learn Python if you're looking at any of these companies, or NASA for that matter, because NASA again uses a lot of data science, and for that Python is very important. So with that, let's move along and talk about how you should go about your journey of learning Python, right? So there will be different stages. So the first stage would be where you are Jon Snow and you know nothing, and at that stage it's fine. And then you start off with a few basic concepts. You learn about a few different things here and there, and then you become an intermediate. And once you're an intermediate, you must be dedicated enough to learn a lot of different things, and that is then in where you try to specialize across different things in Python. So as I mentioned before, there's a lot of different ways to go about in your career in Python, and once you reach the stage 2 where you have experimented with a lot of different things, a lot of different libraries, a lot of different career paths, what it looks like to get in there, and once you know what is that something which excites you most. Let's say if machine learning algorithms and programming and finding out data insights is something which is that something that you like, then you're looking to go inside the field of data science. But if you are someone who is very good at writing Django backend, then you are looking at someone who wants to go ahead and learn that with respect to that, and then you can go ahead and follow your passion in there. So whatever works for you, you can go there. Or for that matter, let's say if you start learning Python and you realize that there is some other way that you should go about in your career, then also I would say that Python is a very good place to enter this field. So if you want to learn basic programming concepts, and if you want to understand how programming is done, Python is a good step to get inside of it, learn various concepts, various data structures, learn various algorithms through Python. And then if you feel like, okay, maybe I'd be someone who is better at working with, let's say, some BI tools like Salesforce, or if I'm someone who should pursue some other paths, but which will probably have some tool usage or something like that, or some other programming language for that matter, having those concepts in the bag by learning Python, because it is very easy to learn, having those oops concept in the bag will help you learn any other language also very quickly, because you understand how programming is being done, right? So that is about this developers map. So how we go about in steps would be like to decide first and foremost, why do you want to learn Python? A lot of people have this aspiration that they want to get inside of computer science and they want to do programming, they want to do a lot of different things. So decide why you want to learn Python. If it's just a time pass for you, is it something that you want to just finish your semester with, or is it something that you want to use to build a great career? So if you're looking to learn a great career, then you want to learn inside and learn various different concepts which are in there. So a lot of different basic programming things that you need to understand will be in there, which you have to start with. Once you have that, so now you know that, okay, I want to learn Python for, let's say, data science, right? Or I want to learn Python for learning Django. Then in those scenarios, you need to understand that you must have great material to study with. And what I mean by a great material is that something that starts from very basic. So a lot of different things like if else concepts and different concepts like which will be there, which you want to understand inside of Python, and you have to work with those Python size dictionaries and lists and or whatever. So these concepts you have to get in the bag and first and foremost, and then you can maybe branch out of there. So find good material to study with, where you can understand how Python works, how programming works, how you write and structure the code is very important. And from there, we move on and enroll in an online training program for Python. So while learning, if you understand that, okay, I'm doing good now, it's time for me to step up my game. I want to do use Python into something where it is more useful. So enroll in some online Python certification course, or any other certification course that you find which aligns with some kind of certification. Just enroll in there and learn Python in and out, because doing these will give you the hands-on practice problems and different things which will enable you to learn algorithms and different data science. And once you have that in the bag, read the official Python documentation. And this step is only recommended like if you are very interested in Python and you want to go get deep inside of it, then you need to learn about the official documentation. You can go ahead and understand what the company is doing, sorry, what the programming language is doing, and you can get into the depth of things in there and understand how things are working. From there, what I want you to do is, once you have Python in the bag, let's say you have an online training program, or if you have just aced Python in the bag, so you have Python in the bag, you understand how Python works. Uh, I'm gonna tell you honestly, just learning Python will not be enough if you want to have a very lucrative career. Then you have to learn about various different libraries inside of Python. You have to get this is somewhere you have to grind and you have to learn about the various different things. And for this, you can enroll into various different data science courses or machine learning courses and AI courses, and find out different libraries which are there inside of Python, like Django and etc. You should branch out and explore whatever different libraries are out there across different fields, which and find the thing that interests you the most, right? So there's a lot of different fields out there, again, as I mentioned before, in Python itself. From there, you need to branch out and find out what is your passion, something doing what kind of programming makes you the happiest. So branch out from there and learn about these different libraries which are out there. And if you have let's say semi programming languages, then look into the I say this again and again, watching and learning through Python, you need to look at different source codes which are available out there. So there's a lot of free open source materials, free open source programming programs which are out there present with their source code for Python programs. Just look into it, what people are doing, how people are programming, learn about it, and think about your own project problems, and then solve those projects through, let's say, it might be an artificial intelligence project where you recognize a guy's eye opening or closing, or if you want to recognize if that is an apple or an orange, it could be anything. So you just start learning through these different things and writing Python programs for them, and just find out what your passion is. And looking through the programming of different people will help you understand what is the industry standard, and how clever people can be when they want to write code. So there are people who are extremely clever at writing code. Their code will be very efficient. By efficient, I mean two three different things. I mean that their big O of n, which is with respect to the time complexity. So what is the time complexity that their code is taking? So the code will not take that much of a time. And then like let's say if you want to do one simple thing of, let's say, going across and reading different elements in array, and finding a match, you can do it in different ways, right? So even if I write I can do it in various different kinds of ways. Some ways will require more time than the others, and finding that way which will take the least amount of time, and being that clever, being that cheeky, you get that when you see a lot of different kinds of codes that people have written, and you get a zest of different things, and then you start applying it yourself. So for that, it's very important that you explore different source codes which are present out there, so that you get a zest of things, right? So for that, that is there. So next point is what makes a good Python developer. Again, any good Python developer or any good C++ developer or any good developer for that matter will have this same skill set. They will be the people who are excellent at problem solving. These people are excellent at problem solving, and this, you're not someone who has to be it's like not a god given talent, right? Problem solving, you get problem solving through practice. So you see n number of problems and you understand the n number of solutions. So you see, let's say, n plus one problem, you have now n plus solutions that you can combine or mismatch and find out, okay, this might belong to this kind of problem and this is how it is being solved. So having that knack will only come from let's say a lot of practice, a lot of work on it, and a lot of seeing a lot of different problems. So having that problem solving mindset is very important. Then if you have then there is a lot of people who have n number of solutions, right? So they see a problem, they have the solution, but having strong technical skills to implement that solutions in a very efficient manner is a whole new department, right? Even in computer science department, you'll see a lot of different people who are very good at problem solving, but they do not have that technical skills, or they do not have the knowledge about how it can be done in the most efficient way, and that's why their code maybe does not perform up to the level of their solution that they thought of. So implementing that solution to the level of the solution that you thought of is also very important when it comes to programming, and having strong technical skills can help you with that. Then you have to have good communication skills. This goes across every job description which you find out, that strong communication skills is very important. That's why it's very important that you communicate across the board, because you may have a lot of good ideas, but you need to communicate that across the people, what you have done, what you are doing, and how it is better from the previous version. That has to be communicated, and that comes through strong communication skills. And finally, there is this eagerness to learn. So it goes without saying that, as I mentioned before, a lot of people learn Python and then they have to branch out, because there's so many libraries that you have to learn. And if you don't have the eagerness to learn these different libraries, then I'd say it's not worth it for you. So if you have that eagerness to learn, and if you have that knack for programming, and if you have that satisfaction of seeing your code run properly, then it is something that you should consider building your career in. Now, what next? So let's say we are at a stage now where we have, let's say, done the Python course, we understand Python, we have a Python certification as well, and I started seeing it across various different libraries. I know, let's say, 5-10 libraries by now. So what should I do now? The next step would be do as many projects as you can. So the only thing that will help your resume, apart from certifications or publications or a good work experience, is your projects, especially for people who are freshers. Any job interview that you go, you will be grilled on the projects that you have done, and do as many good projects as you can, because these projects basically, why, if you ask yourself, why would many interviewer ask you about your projects if you have done it? So having a project basically gives them a problem statement, and how you solve that using your programming language is a great solution, and it gives an insight of how much depth you have in the understanding of the programming language, and how good your problem solving skills is. So it gives you both of that in the same place, and they can grill you about the technical aspect of things, so that they can understand uh, how much depth you have in the programming language fundamentals. And some of the good projects to start with is here mentioned on my screen. So if you're interested, you can go for Twitter sentiment analysis using Python. Then there is Hangman game. You can make a lot of different kinds of game. You can make the snake game and different games which are out there, which you can start as mini projects. But as you move along and learn different libraries, you make more complex projects, make more better projects, which will basically help you enhance your resume and land you those better jobs tomorrow.
First, we'll see about Python. So Python is a high level interpreted and interactive language that is used in various fields of development. So it is also an object-oriented and a scripting language that is designed to be highly readable, and it uses English keywords frequently, whereas other languages uses punctuation, and also it has a fewer syntactical construction than other languages. So Python is a must for any working professional to become a great software engineer, especially when they are working in the field of various fields like web development, data science, machine learning, artificial intelligence, and big data. So the features that makes Python unique is easy to code. It is a very simple language that anyone can learn very easily, and it is also free and open source. Then it is an object oriented programming language, so it supports object oriented style or technique of programming that encapsulates code within objects. So it is also Python also supports GUI applications that can be created and ported to many system calls, libraries, and Windows systems such as Windows MFC, Macintosh, and the X Windows systems of Unix. So it is also a high level programming language. It is extensible, that you can add low level modules to the Python interpreter, and the modules enable programmers to add to or customize their tools to be more efficient. So this extensible features makes it more unique for the use in various development tasks. Then it is a portable language, and that can run on a wide variety of hardware platforms and has the same interface on all the platforms. Then comes integrated language, so it can integrate various other applications and technologies. Then Python is an interpreted language, so Python is processed at runtime by the interpreter, and you do not need to compile your program before executing it. And this is similar to the programming languages such as Perl and PHP. Also, it has a large standard library which makes the development in the various fields such as web development, desktop application development, software development, data science, big data, machine learning, and artificial intelligence. And finally, it has a large standard library. So there are various libraries and packages which helps in the field of web development, desktop application development, data science, big data, machine learning, and artificial intelligence. So these features makes Python a very unique programming language for development, and it is widely used across the industries, and there are top multinational companies who uses Python for their development task. Now moving on to the next part, that is R programming language. So R is a programming language and software environment used for statistical analysis and graphics representation and reporting. So R is freely available, and it is an open source programming language. So the core of R is an interpreted computer language which allows branching and looping as well as modular programming using functions. So R also allows integration with procedures written in the programming languages such as C, C++, .NET, Python, or Fortran languages. So there are various features of R programming language. So it starts with open source, then it is a comprehensive language. It has a wide array of packages that is used in the statistical analysis. Then it has various graphical libraries that are used in data visualization tasks. So the task of data visualization can be handled using R programming very efficiently. Then it does not need any compiler for compiling its codes. It also performs fast calculations. And the next feature is integration with other technologies. So it can very efficiently integrate with other technologies to develop software application. And then cross platform compatibility, that is R is platform independent. It can run on any hardware or more than one hardware or operating systems. So R is a well defined and simple effective programming language which includes conditionals, loops, and user defined recursive functions and input output facilities. It has an effective data handling and storage facility. Also, R provides a suite of operations for calculations that helps in the analysis and visualizations of the data. And R provides various graphical facilities and libraries for data analysis that you already know. So as a conclusion, R is world's most widely used statistical programming language, and it's the number one choice of data scientists, statisticians and researchers that who works on data. It is supported by a vibrant and talented community of various contributors. Now we will move on to another programming language, that is SAS. So it stands for Statistical Analysis Software. Going to the definition or detail, SAS is a software suite that can mine, alter, manage, and retrieve data from a variety of sources and perform statistical analysis on it. And SAS provides a graphical point and click user interface for non-technical users. So it allows for data to be read from databases and spreadsheets from various statistical analysis. So SAS is a leader in business analytics. Through innovative analytics, it caters to business intelligence and data management. So it gives various software and services for business analytics. SAS transforms data into insight which can give a fresh perspective on business. So unlike other BI tools available in the market, SAS takes an extensive programming approach to data transformation and analysis rather than a pure drag and drop and connect approach. This makes it stand out from the crowd as it gives much finer control over data manipulation. And SAS has a very large number of components customized for specific industries and data analysis tasks. Also, SAS is a platform independent programming language, which means you can run SAS on any operating system, either Linux or Windows. Now, let us look at some of the features of SAS. So, it helps in strong data analysis, it is highly flexible, it helps in efficient data management, support data encryption algorithms, support various types of data format. So we have SAS Studio where we can implement the queries or codes of using SAS programming for data analytics. Then finally, it has a report output format that we can get. Now we'll move on to the next part, that is fields of usage for these programming languages. So talking about Python, it is widely used for various sectors or various development fields such as web development, desktop application development. It is used for GUIs, it is used for game development, big data analytics, data science, machine learning and deep learning. Python has a wide set of libraries used in various development fields. So for web development, it uses Django, Flask, and for GUI it uses tkinter. For game development it uses pygame, and in big data, data science, machine learning and deep learning there are various libraries such as pandas, scikit-learn, scipy, numpy, tensorflow, keras, cafe. So there are n number of libraries Python has to develop various applications.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Now, talking about R programming, so it is basically used for data mining, data analysis, data visualization, and it is also used for building predictive models in data science, machine learning, and the main purpose of using R programming is statistical computing. It is mainly used by industries or organizations to analyze the data, to visualize the data, and draw some meaningful insights from it by using statistical computing. So, this is the sole purpose of using R programming. So, it also has a rich set of libraries that helps us in performing various techniques of data mining, analysis, and visualization. Now, moving on to the next part, that is SAS programming. SAS, that is statistical analysis software, it is used to output the statistical analysis in the form of tables and graphs, which is processed from spreadsheets and databases. The significant use of SAS is in the financial analytics. So it offers the full range of statistical functions and also provides the best GUI for data analytics application deployment. So it is used in advanced analytics, data management, business intelligence, and predictive analytics. So SAS is preferred over Python and R when the organizations need to analyze and visualize their financial data and which needs confidentiality. So that is why SAS is a very expensive software. Now we will look at the applications of Python, R, and SAS. So starting with Python programming, so it has various applications. So Amazon, Twitter, Flipkart, YouTube, Google, Facebook, and there are many more Fortune 500 companies who uses Python programming for developing their robust softwares. So talking about Amazon, so it uses Python for their recommendation engines. There are various libraries and packages in Python which helps in developing machine learning algorithms that runs the recommendation engine. And same is the case with Flipkart. It uses recommendation engine, which again involves the usage of Python programming. Then talking about Twitter, so it uses Python for analyzing and text analysis for the users. So same is the case with YouTube. It analyzes its data of customers. And then talking about Google, so there are various applications of Python, and Google uses Python for implementing natural language processing, for implementing its text analysis, optimizing the search results of the website. Then same is the case with Facebook. Now moving on to the applications of R programming. So here are the companies, that is Gartner, Deloitte, Genpact, Ford, McKinsey, and Facebook, Google again, then Zalando, which is again an e-commerce website, and Paytm. So they uses R programming for analyzing and visualizing their business data and implementing machine learning algorithms to make predictive models. Then coming to SAS programming, here are the companies, that is Amazon, Netflix, YouTube, Twitter, Fractal, Cognizant, HP, Citibank, Dell, and it also consists of various other Fortune 500 companies, that is Google, Tesla. So these all uses SAS programming for their business analytics. So there are a very few companies who uses SAS for their business intelligence tasks, and not all companies can afford SAS programming because it is a very expensive tool to use for their organization. Now moving on to the next part, that is support and community for these programming languages. So starting with Python, so it is an open source programming language and it provides no customer service. So you have to search for your doubts and queries in Google. But it has a very large community of Python developers who are from various fields such as web development, they can be data scientists, machine learning engineer, data analyst, big data engineers, game developers, and many others. So it has a very large community that can help you out in solving your queries. Now moving on to R programming. So again, it is an open source and free tool, and it does not provide any customer service, and it has a large community that can help you out to solve your queries, your doubts, and various R professionals who are expert in R programming and working can help you out in various data analytics tasks that you need to perform. Now coming to SaaS, so it provides a 24/7 customer service as it is a paid tool and it is a very expensive tool to use. So it has a very good customer service. So you can clear all your doubts, and there is also SaaS community that can help you out if you are stuck in a particular problem. Now let us move on to the final part of this video, that is job scope for these programming languages. So starting with Python and talking about number of jobs. So according to Forbes, in India there are 15,000 plus job available for Python developer in 2020, and in the United States the number of jobs are more than 50,000. So it is a very big number, and there are a plethora of opportunities for a Python developer. Talking about salary, so the average salary in India is 7,25,000, and in USA it is $1,15,500. Then moving on to the R programming. So number of jobs for R programming according to Indeed.com. In India there are 2,500 jobs available for R professional in 2020, and in the United States the number of jobs are close to 8,000. The average salary for R professional in India is close to 6,53,000 per year, and in the United States it is close to $1,05,000 per year. Now moving on to the next part, that is SaaS programming. So number of jobs according to Naukri.com. In India there are 1245 jobs available for a SaaS programmer in 2020, and as per the stats from Glassdoor, for SaaS programmer there are 4518 openings in the United States, and the average salary for SaaS programmer is close to 5,40,000 rupees per year in India, and in the United States it is $1,10,000. Now for choosing a career option, if you are into financial analytics, then you should go for SaaS programming, and for getting into the field of web development, data science, big data, artificial intelligence, machine learning, and development of games, you should definitely go for Python, as it is a widely used programming language and it has a plethora of job opportunities with a very good salary. So you must go with Python. Now if you want to get into the field of data analytics, then you should go with R. So you can see over here in the left hand side there is a Java code. So it prints hello world, and at the right hand side you can see a Python code that prints hello world. So you can see the difference in the length of the code in these two programming languages. So Python just uses a single line of statement using a print keyword to print hello world, and in Java you have to make a class and use various methods. So Python is extremely simple and it is popular due to, so while building robust or complex softwares, it requires a lot of effort and lengthy codes using other programming languages as compared to Python. So basically Python is popular due to its simplicity. So the features that makes it popular is expressive. So it is a very expressive kind of language. It is understandable, easily understandable and readable. Then it offers an easy to understand syntax, simple setup, and has many practical applications in various development processes. And the syntax isn't too annoying compared to other programming languages. And you can import a bunch of modules which can often make your code much shorter. So this is due to its simplicity. So the next thing is, it is an open source programming language. So in simple terms, you can freely distribute copies of this software and read the software's code, make changes to it. use pieces of it in new free programs, and that you can do these things. Now the next thing is it is open source. So in simple terms, you can freely distribute copies of this software, read the software's source code, make changes to it, use pieces of it in new free programs, and this makes it open source and free for all. Now the next point is it is object oriented programming language. So the Python supports object oriented features, and compared with other programming languages, Python's class mechanism adds classes with a minimum of new syntax and semantics, and it is a mixture of the class mechanisms found in C++. So Python classes provide all the standard features of object oriented programming language except strong encapsulation, which is only one of many features associated with the terms object oriented. Now Python is also an interpreted language. That means interpreter executes the code line by line at a time. So when you see an interpreted language like Python, there is no separate compilation and execution steps. You just run the program from the source code, and this makes debugging in Python easy, and thus it is very much suitable for beginners. So internally, Python converts the source code into an intermediate form that is called bytecodes, that you might have heard of, and then translates this into the native language of your specific computer, and finally runs it. So you just need to run your programs, and you never have to worry about linking and loading with libraries and so on. So this makes it now finally it is also a cross-platform language, and Python can run equally on different platforms such as Windows, Linux, Unix, Macintosh, and so on. A Python program written on a Macintosh computer will run on a Linux system, and maybe for others. So thus this makes it a portable language. So it is a cross-platform language. Now let's move on to the next part. So Python is portable and extensible. So this feature allows Python's extensibility feature. So Python's extensibility features allows us to write some Python code into C or C++ language, and also we can compile that code in C or C++ language. And it is also portable, and Python language is portable, which makes it so if we have a Python code for Windows, and if we want to run this code on other platforms such as Linux, Unix, and Mac, then we do not need to change it. We can run this code on any platform. So this makes it portable, and it is very useful for building software applications. Now we'll move on to the next point, that is it is used in web development. So Python can be used to build server-side web applications, and Python actually is not used in a web browser, but the language executed in the web browsers will be JavaScript, and then the projects are compiled from Python to JavaScript. So the web applications always uses a combination of Python as well as JavaScript to build an application. So the combination of both JavaScript and Python are used to build web applications, where Python is executed on the server side while JavaScript is downloaded to the client and run by the web browser. So there are various frameworks such as Pylons, Django, Flask, Web2Py that are used for web development. So starting with Pylons, it aims to make web development fast, flexible, and easy. And then now if we talk about Django, so it is again an open source and free web application framework that is written in Python, and this framework provides a collection of modules that makes development easier, and also it provides the features that helps in rapid development and clean and pragmatic design of code. Then comes Flask, which is a micro web framework which is also written in Python, and it is classified as a micro framework because it does not require particular tools or libraries to execute. It also supports extensions that can add application features as if they were implemented in Flask itself. Then is Web2Py, and it is also an open source web application framework. again written in Python programming language and designed to help to reduce tedious web application tasks such as developing web from scratch. So this is the use of Web2Py. So there are various frameworks that gives us the benefit of developing Python web applications rapidly and with efficiency. Now let's move on to the next part, which is Python is used in computer graphics and game development. So there are also various frameworks, that is Pygame, Tkinter, WXPython, Jython, which is used for computer graphics and game development. So it is also used to Python is also used to develop desktop applications, beautiful GUIs. So it can be made using modules such as PyQt5, PyQt4, WXPython, or Tkinter. Also, PyQt5 is the most popular option for creating graphical apps with Python. Now the next one is Python is used for software testing. So it consists of various frameworks that can be used for testing of softwares. Now there are various frameworks that are used in Python for testing, and it starts with PyTest, Testify, Unit Test, Nose, and Mimesis. So let's check in detail for what type of testing these frameworks are used. So starting with PyTest, it is a testing framework which allows us to write test codes using Python, and you can write code to test anything like database, API, and even you can check UI if you want. So, but PyTest is mainly being used in the industry to write tests for APIs. Now the next one is Testify. That is a replacement for Python's unit test module and Nose. So it is modeled after unit test, and tests written for unit test will run under Testify with a minimum number of adjustments, but it has features above and beyond unit test. And so basically it is the advanced version of unit test. Now checking with unit test. So unit testing is the first level of software testing where the smallest testable parts of a software are tested. So this is used to validate that each unit of the software performs as it is designed to do so. So the unit test frameworks in Pythons are like XUnit style framework, which provides the benefit of checking each and every unit of the software. And then comes Nose, that is a testing framework again, and it collects tests from the unit test and also supplies a number of helpful functions for writing timed tests, testing for exceptions, and other common use cases. Then comes Mimesis, which is also a package for Python which helps generate big volumes of fake data for a variety of purposes, like using it for testing database or populating a testing database, creating beautiful JSON and XML files. So this is the use of Mimesis. So you can see over here that there are various testing frameworks that helps in automated testings and supports easy debugging using Python language. Now let's move on to the next one, which is Python is used in big data. So again there are frameworks like PySpark, PyDoop, and Dask, which helps in processing big data. So basically Python and big data are the perfect fit when there is a need for integration between data analysis and web apps, or maybe statistical code with the production database. So Python helps in big data analytics, and various Python frameworks helps in writing codes for data analysis. Also Python provides advanced support for image and voice data. So talking about frameworks, so it is PySpark framework used by big data. So first of all, talking about Apache Spark, that is an open source and it is one of the most popular big data frameworks that is used for scaling up the task in a cluster. So the Spark Python API exposes the Spark programming model to Python. Then comes PyDoop, that offers MapReduce API for solving complex problems with minimum programming efforts. After that comes Dask, which is popularly known as Python Parallel Computing Library, and through its parallel computing features, it allows rapid and efficient scaling of computation, and it also provides an easy way to handle large and big data in Python with minimum extra effort. Now let's move on to the next one, which is data science. So Python is widely used in data science. So there are various libraries such as Matplotlib, scikit-learn, pandas, Seaborn, SciPy, Numpy, and there are thousands of libraries that is used by data science, and it mainly deals with data exploration, manipulation, visualization, and descriptive analytics, and even creating machine learning algorithms. So starting with Matplotlib, it is a plotting library for the Python programming language, and its numerical mathematics extension is Numpy. Also, it provides an object-oriented API for embedding plots into applications using general-purpose GUI, like the general-purpose GUI toolkits like they are tkinter, Qt, or wxPython that we already discussed in this previous section of this session. Now, the next one is scikit-learn. So the scikit-learn is probably the most useful library for machine learning in Python, and it is also used for data analysis or data visualization in data science. Now coming to pandas, it is again a software library in computer programming and written for Python programming language. So they are used in Python to deal with data analysis and manipulation tasks. So to put it in a simpler words, pandas help us to organize data and manipulate the data by putting it in a tabular form. After that, Seaborn, that is used for statistical data visualization, and it is a Python data visualization library that is based on Matplotlib. So it provides a high level interface for drawing attractive and informative statistical graphics. Then comes SciPy, that is an open source Python library that is used to solve scientific and mathematical problems, and it is also built on top of Numpy extensions and allows the user to manipulate and visualize the data. So the reason for telling all the details about these Python frameworks is that you get to know about the specific libraries that are used in specific technologies such as data science, machine learning, big data, artificial intelligence, web development, game development, for getting into these fields as a Python developer. So that is the sole purpose of discussing about these libraries as well. Now let's move on to the next part, that is machine learning. So Python supports machine learning software frameworks. So basically Python helps in implementing machine learning algorithms. So here are few of the frameworks to implement machine learning algorithms that are on Python, and it starts with accord.net. So it contains algorithms that perform vision processing, and they are usually used for the tasks like facial detection, image integration, and tracking moving objects. So after that comes Apache Spark. So it is an open source, also general purpose distributed computing engine that is used for processing and analyzing a large amount of data. So basically Apache Spark is written in Scala programming, and that compiles the program code into bytecode for the JVM. Then the open source for processing of large amounts of data. Then comes SciPy, which is again a library, Python library used for scientific computation and performing mathematical operations. After that, Caffe, which is a deep learning framework developed by Berkeley Vision, and it is written in C++ and has Python and MATLAB bindings. So it is used in integration with machine learning and deep learning. So we'll go to the next part, that is artificial intelligence. So artificial intelligence is one of the where Python is used extensively to build AI based software. So it does so by using various libraries, that is TensorFlow, Pandas, PyTorch, NumPy, Keras, and there are various other libraries that we come across for building various AI based softwares. So starting with TensorFlow, that is one of the popular libraries of AI. So it is a Python library, and it is used for fast numerical computing and created and released by Google. So it is a foundation library that can be used to create deep learning models, or it can be used by wrapping libraries that simplify the process build on top of the TensorFlow framework. Then comes Pandas, that is used for data manipulation and visualization tasks. After that, PyTorch, that is native Python package, and that provides a complete end-to-end research framework mainly used for research in deep learning field. After that, Numpy, that is a Python package mainly used for scientific computing. And then Keras, that is a powerful and easy to use open source tool for developing and evaluating deep learning models. Now, moving on to the final point of discussion, that is career opportunities and salaries. So we can see various Fortune 500 companies such as Amazon, Google, YouTube, Facebook, Twitter, and Flipkart that are using various AI based technologies, machine learning, data science, big data to enhance their business. So Amazon uses data science to build their recommendation system. Google uses NLP, deep learning, AI, machine learning, data science for voice recognition system, Google Maps, and for search optimization. Then YouTube uses data science to provide their customers a better personalized experience, and so on. Facebook, Twitter, Flipkart uses these technologies. So all these technologies uses Python libraries to implement and to make their product a better version of before. So this wide acceptability of Python makes it one of the popular language in the industry. And due to this, the scope, the job scope and career opportunities for a Python developer is rising day by day, and it is very high in comparison to other job profiles. Talking about job profiles, so these are the popular job profiles that are posted by the employers in various job portals. So starting with Python developer, then Django developer, web developer, software developer. After that, data analyst, data scientist, ML engineer, and AI engineer. Now discussing about the salary of Python developer. So the average salary in India is rupees 835k per annum, and in US it is 125k dollar per annum. So it is a very awesome package to start your career with as a Python developer.
Let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. Now, I've broken it down to a couple of steps and let's go with it together, right? So step 1 is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows. So we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with this screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Thus, before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now. And this will ask me for my admin password, because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. And I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install. And step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the setup, guys. So guys, now the setup is successful. Let me quickly open up command prompt to verify that it has been installed correctly, guys. So if I go ahead and type in Python there, then pretty much Python console is ready for us. So let's type in a sample code. Hello world. And as soon as I go ahead and run this, we have the output, guys. So pretty much, well, as of this moment, Python 3.8.0 is the official stable release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do A equal to 1, B equal to 2, C equal to 3, and so much more, right? So let us create a new variable D and then probably add A and B to it. So let me just quickly do this. We can print D. Well, D is 3. Let's multiply. You know what? Let's create another variable. Call it E. Multiply D and C. Let us print E. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3, and so much more. To just get out of the console, you will have to type quit followed by parentheses, and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotlib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video, but note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console, but here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, The data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter, and if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using, because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that, okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen, and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSBA and CSS, and as you can see that it added it to the it added those two strings together. Now if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes and 4 bytes, depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value, or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age, and equals 25, this is going to show me an error. because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start it with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far, and we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is a equals to b equals to c equals to 10. That means set all the variables on the left hand side, which is a, b and c, to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go a equals b equals c equals 15, and if I were to print a, it's 15, b is 15, c is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, a comma b comma c. Now I want 10 assigned to a, comma 15 assigned to b, and 20 assigned to c. I press enter. A, b, c. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use a, b and c, if I were to use b, c and a, then b will be assigned 10, c will be assigned 15 and a will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form, and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter, and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand. So let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and one. So when you hear something like integer can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have this will be 0 since all the 4 numbers are 0. Now what we're doing is I want to check if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3. This should be 2. Should be 1. This should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0 plus 2 to the power of 2 which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1 which is 2 multiplied by 0 and we go 2 to the power of 0 which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1 and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 can also represent some number between 0 and 16. Now we come to bitwise operators.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what they do is, they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0, 1 and 0 will return 0, and 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator, and we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary AND and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is, I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is, it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I have given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator does. It takes the binary format and shifts it by 2. Now on the other hand, we also have right shift operators. And it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed, and add 2 zeros at the beginning. And we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0 0 0 1, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this. And this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 18, 187, 522, and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4, and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token, in Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discuss are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code. And we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others. And these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type ret is equals to 7, this works just fine. But if I were to type return return, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every character in small lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's, you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, and it's 72. So if I were to print VAR with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 VAR equals to 7. We'll get a syntax error. But if I were to do it V1AR, this is just fine, it will work. V1AR, and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, Boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path. Press enter and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. You just need to understand why there's 2 quotes and why there's 1 quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use 3 single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with 3 quotes. I press enter. As you can see, the prompt, instead of it being 3 arrows pointing left, it's now become 3 dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this, I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type 3 single quotations, press enter. I get back the prompt with 3 arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line, as you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you've worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers. So we can store that in integer as well. Let's say that I want to store negative 77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version. So never mind. So if that was the case, then I could do that, but it's not. Yeah, so as you can see, it's working fine. Now if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're choosing the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now that is mainly because in Python you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it. unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirm password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type BOL, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that could that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers and tuples will have some value assigned to them, and then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable we have lists, dictionaries, sets, and in lists we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So Again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this. And if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters, because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the 5th character, or this the 6th character in this, which is on the 5th index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the 5th character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the removing the last one character. If I were to remove the last two characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f g. I press enter, it returns another string to me, which is a b c d e g g h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me. Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to into the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday, weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousands. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple, 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple. to see if it's a tuple or not, and it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add two curly braces. Inside it, add the key, which would be the person's name, let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter, and now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good, but one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. Press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of lists in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is, if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scenes that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you can access it using numerical indexes and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0 and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? A set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in S, and it will show you 2. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time, and let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do one in S as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in S I can type 1 in L, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window, and here type in VS Code, press enter, and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open with this code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py and right and click on edit. It will open it in Notepad and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder, so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. Here you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again I press enter and it's there. Let me just increase the font size here as well, so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I print it. It's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num 0.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And then I keep going on, like print num1, num2, num3, so print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understands what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parentheses, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter and pop is also not available. But you can print them, you can loop over them just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this. DICTIONARO dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys, these are the values. So Jane earns 15, John earns 20. So we type it, we print in the keys. Now if we don't want to print the keys, let's say we want to print the values. I do that, now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print s, it's 1, 2, 3. So this works fine. But if I were to loop over it for x in s, let me just print x. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in s, I'll get true. And if I were to print 4 in s, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for x in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10 because the end is exclusive. So always remember that. And now if I do L dot append x, and finally we can print x, not xl. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code? Because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add x to the list. Now Python is waiting for me to define what x is. So I'll go for x in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier, and this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this, I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and this is where you will get into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you've probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if-else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if, say, the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand, if the condition is true, then statements 1 is going to execute, and if condition is false, we'll execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true. Then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than 20. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif, x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Run this again, is correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else. I can write some code. X is greater than 15, and finally else. X is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We assign a value of 17 to x. We check this condition. We check if x is less than 20. It is less than 20. We go down. We print x is less than 20. We go down. We check x is if it's less than 15. It's also true. So we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read. If you can you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code, else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on, so don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if anything, if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flowchart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does. And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So end space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and there's space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list, and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list, and you don't want to print the name of people whose salary is less than, let's say, 40k. So what you can do, if person, let's say that for each x, 0 index is x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number, a is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control-C. I don't want it to run forever. So if I do this, then it understands how to do this. It'll take a loop at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. Another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1. I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code, and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you are working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry, and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform. If that's the case, then you don't return anything, you just omit the return statement completely. To give you an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's lambda functions. Now this is a concept that gets overlooked quite often, but lambda functions are very powerful. So lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using def multiply x comma y, and then I return x multiplied by y. But since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36. Now another thing that lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is will it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. All right. So if I were to call this function, download file, and let's say that the URL is ftp : www.abc.org. Now if I were to run this, let me just run this here. It's going to perform these tasks. But the major advantage of using a function is, now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL, df ijk, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database, that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines. So this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see. And it's downloaded it, but as you can see that this step is now added to all 3 of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x, y. I get in 2 data and I perform some task. Now I want to return x multiplied by y. Let me call it, again, this is a very trivial example, multiply, right? And if I want to multiply 2 numbers, you multiply x and y. Now x and y are going to be numbers, so let's say 15 can be 10 comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it to multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply and we want to execute. If I run this again, it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. Taking a look at what are data structures. So a data structure is a particular way of organizing and storing data in a system's memory so that it can be used efficiently for some purpose. A good example of this would be and arranging data is a very important aspect of any programming language. Some kind of arrangement of data might be better suited for one purpose than other purposes. To give you a more concrete example, if I were to give you a few numbers, let's say from 1 to 10, let's say I were to give you 10 numbers of any, I were to give you 10 numbers and those 10 numbers were given on a card. All of those cards were placed face down in front of you, and you had the option of arranging them in any way possible by looking at their value. Then I would ask you to check for a particular number to be existing in one of the cards. So if I were to say, okay, check whether 10 exists in one of those cards, what you could do is If you had arranged them all in a linear fashion in a random order, you can just take a look at each card and see whether or not it contains the number 10. So that's easier for you to do for 10 numbers, but let's say that the scale increases and now you need to do that for 100 numbers, for 1000 numbers, for million numbers, and for even billion numbers. That is going to be really time consuming. On the other hand, if you had stored it in a different way, let's say that you had stored it in a way in which when you get the data, what you do is you first take one card, see if it is what the number of the card is, place it someplace, then take the other card and see whether or not it's smaller or larger than the card you had previously taken. If it's smaller, you put it on its left hand side a little below, and if the card is larger, then you put it on the right hand side, and you keep doing it again and again and again. This forms kind of a tree like structure in which a card is at the top, all the numbers smaller than the card is on the left hand side, all the numbers larger than the number on the top is on this right hand side, and this rule is followed on for all the cards. So if you have many cards, this will be followed for all of them. Then I can come along and say, for the 10 million numbers that I have given you, tell me if the number 15 is in those. What you can do is take a look at the card right at the top. If the card at the top is larger than 15, which means 15 is smaller than the card at the top, you look at the left portion of the structure that we have created. On the other hand, if it's larger, then you look at the right portion, and you keep repeating the step. Each step is going to cut down half of the tree for you, so you don't have to worry about that. So this is what's called a tree data structure in essence, and this is specifically called a binary search tree. And the technique we're using inside it is called a binary search algorithm. Basically, if you have data that is sorted in a particular order, you have the ability to look at the data that's right in the middle of the deck, figure out what the number is. If the number you are looking for is smaller than the number, then you have to discard everything that comes after that card, the middle card that you have chosen. If it's larger than the number, then discard this and everything that comes before it. And you keep doing it again and again and again, and you will eventually get to the card that you choose in a very few number of steps. In fact, the number of steps is different from linear to logarithmic scale. So it's quite different. So this is one of the ways that storing data in a particular way can help you. Similarly, you can, if you wish to grade a few papers, you can store them in a stack that's easier for you to deal with. And if you're trying to manage a few people getting through and doing things in an orderly fashion, you can store them in a queue. Similar concepts are carried over to data structures as well.
Let's start with creating the threads. Now you guys know what is thread and what is the purpose of it, why do we need it, and all you guys got an idea. Thread is nothing but a task. Now let's create a task. So in computer programming, a thread refers to a small lightweight processes performing a certain task, and the life cycle of the thread includes the major states: start, execute, and stop. I have not created any PPT or something like that. I have added the descriptions here itself as activity 1, and here will be doing the code. So you can just refer here itself. So threads in Python can be created using the construction of a thread class in the threading module. So this is a syntax for creating a thread. So threading dot thread. So this is a syntax. Inside the target will be the function name. So we will be creating many functions. For which function you are creating a thread, so that name needs to be given here. And then the argument. So this is optional. If your function takes any input, you can pass this input to the arguments here. If it doesn't take any input, no need of giving the arguments. It is optional. Okay, so this is the syntax for creating a thread. So that is what it's given here. Function name is the name of function executed by the thread, and parameter tuple is the collection of input parameters required by the target function, that is function name. So the parameter tuple collection is passed in the form of a tuple. Let's import the module first and create a new thread. Okay, first let's import threading. It's imported. Now just look into the syntax for the thread class. The constructor given here in this activity. Yeah, so it requires the target function and the arguments. The target function is the task that is performed by the thread. So the function can be anything like an addition function or recursive function like a factorial, any functions. You guys have already worked on functions concept. So in real time, these functions are a different application and their subparts like opening multiple tabs in a browser, or writing in a document, or an antivirus program executing in the backend. So these things and all can be the parts. So now let us create a square function to observe the thread behavior. See, square of 32 is 1024. 10 tens are 100. So this is how now I have created one function here. Now let's create a new thread using the function square as a target. Okay, the same syntax we saw there already. So let me name my thread as thread underscore 1. I'm naming my thread as thread underscore 1. Threading dot thread. So it should take the target. Target is my function name. So square. Square is my function name. So here I'm not giving the parenthesis, you need to observe. So probably you would have learned when you're learning the Python basics. When you're using the apply function, you would have learned the apply function. In apply function also, it takes function name as an input. So there you don't give the brackets. Usually if it is a function, you just give the brackets, parenthesis, right? So when it is taking input as function name itself directly, no need to give the brackets. So here we have one more parameter called arguments. args equals. So you can give any number and not anything. So as I told you already, we are passing tuple as an input. It's taking tuple as an input over here. So you know already the tuple concept. If you give comma, it considers you are inserting only one value here. It considered that it is a tuple value. So if I run the code, so now my thread 1 is assigned to function square. So if you call thread 1, if you just check, you will understand how to check. It is as I have assigned my square function to my thread 1. This thread will not execute unless we start the thread. We need to start it, execute it, and end it. So let's start this thread. The syntax is thread underscore object dot start. So once the thread starts running, it will run independently till the target function will complete. So thread underscore 1 dot start. Yeah, see, if I just give thread 1 dot start, I get an output square of 10 is because I have assigned the square function to my thread 1. So if you call the thread 1 in the backend, it is executing. So there is an output given by the target function. Like sometimes when starting the thread, there is no output. This is because there is already another thread executing in the program and the program is not free. So let's use the print current threads function of the threading module to check the name of current thread that is getting executed. Let's print the name of the current thread using. So this is a syntax threading dot current thread. Current thread is nothing but currently what it is executing. So this will be the current thread executing. So my current thread name is main thread. What is this main thread? It is currently executing. The main thread is executed. The main thread class allows applications to run code on the main thread of execution. So it's nothing but the current thread is nothing but the main thread only. And to determine if a particular block of code is currently running on the main thread. So now I just check my current thread which is executing, that is main thread. So now let's understand what is this main and how do we start and how do we stop it and all. Now let's understand multitasking. So now till now we just created only one thread and we worked with the one single thread. So now let's understand multi-threading, multitasking. So it is the ability to perform multiple threads simultaneously. So this means if a function sum of numbers is executing, then simultaneously another function, let's say decimal to binary, can also execute at the same time concurrently. So this is the ability of the processor, which saves time and thus increases the performance. Now let's create two iterative functions and two threads to observe whether they are executing simultaneously or not. To observe multi-threading, we need to follow a few steps here. First, we need to create a function which takes a number num as an input to calculate the sum of number from 1 to the output using the loop. And then we need to create a function called decimal to binary. So which takes number as input and it will convert into its binary notation and stores the digit in a list. And then we create thread 1 with the target as sum of numbers and give name equals thread 1. And then we create thread 2 with target as decimal to binary and give name as thread 2. And finally, we will execute both the threads using start and check the current thread that is executing. Now let's create two functions and understand. Okay, create two target function and threads to observe the multi-threading. So first let me create a sum of numbers, def sum of numbers, takes num as an input. We set initial value to 0. Then for I in range 1 comma num sum equals I plus I plus so let me explain again what I'm doing it here quickly. So first we are creating a function sum of numbers. It takes a number as an input. You can give any number. So here in my case, I have passed a number as 5. Initially my sum will be 0 here for I in range of 1 comma 5. Initially my I will be 1 and sum is 0. So sum equals 1 plus 0, it is 1. So the sum of num, it will be printed. I mean after this complete iteration, it will just print here. So the sum of 5 numbers is 10. So it keeps incrementing in the for loop until we complete this range, whatever you have given. So sum of 5, the sum of 5 numbers is 10. So the sum will be 10. So format string is one concept and it is getting advanced than format also. We can use the F string also, F string. So you need to use F at the starting. So the sum of num, usually how we used to print if you're not using this F string, it would be like sum of comma num comma numbers. This is how you do, right? Numbers is comma sum. So instead of doing that, this is called as placeholders. The brackets what I'm giving, the dictionary concept is called as placeholders. So this is how we usually print it. If I want the sum of 5, the num value it will take, numbers is, and then the sum value. Even this gives me the same output. There is no change. See, the sum of, oh, it didn't print. Num is my variable. Oh, no, see, sum is the range, num is the input, what we are passing it to my function. So here, while passing the values, I'm giving like threading one target, sum of numbers, arguments. Okay, I'm passing my arguments as a tuple over here. So it should be in the same format only. So that's the reason we have used the dictionary format. Yeah. So we are using the F string in order to fetch it. This is called as placeholders. So this value will automatically fetch it from here. I'm just passing as an argument as 5 to my function. So that value will automatically fetches and it will here in this placeholder also the value will be fetched. And is sum. Some value will also be fetched and will be printed in the sum. See, the sum of 5 numbers is 10. Current thread name is this. Binary equivalent of 5 is this. Current thread name is this. I'm formatting my string. So if in general, if you just use the print statement, it won't be in this format. current thread. See, there is no new line after the current thread name. So this is called as F string, and it supports like in whichever you might use the PyCharm or the Jupyter Notebook, whichever it is. I haven't tried with Jupyter Notebook. Yeah, I think so. It will work. It is almost the same, right? Google Colab and Jupyter, it will work. So printf, the sum of num, this is called as placeholder. The value is fetched and printed here, and the numbers is sum. So I got it as 10. If I pass the sum of numbers of 10, 5 is 10. So then decimal to binary. We are converting whatever the decimal value, whatever the value we give, we are converting it to a binary numbers. So initially I'm setting n equals the num, whatever the num we are passing it as 5. It would be n as 5, and I'm creating an empty list over here. Later I'll be appending the values into my empty list. While number is not equal to 0, the number whatever we have passed there 5, if that 5 is not equal to 0, I'm taking the quotient. So this is called as floor division. Hope you guys, few might come across or few might not know about this. Floor division, this is called as floor division. Floor division is nothing but like round off. I can tell as round off. If you have like 49.999, it's nothing but 50. So that 50 would be assigned to the quotient. That's just an example I have told, but in our case, num is 5, right? 5/2. It's nothing but floor division. Whatever you get the number equivalent, it will round off, and that value is assigned to my quotient. Because we want the binary numbers, right? You can't take the decimal value. So we use floor division in that case. Then my remainder. Remainder equals num modulus 2. This is called as a modulus symbol. So it would just be a revision. Even if it is simple, I'm explaining it to you guys so that it would be a revision for you how it works exactly. So num is 5, 5 modulus 2. Modulus is nothing but it gives me the remainder. So 2 divided by 2. So remainder is 0. Right? Remainder, whatever you get in the remainder, that will be the modulus here. And then the binary digits dot append. Binary digits is nothing but my empty list which I have created here. I'm appending the values to my empty list because I have a list, right? It's not only a single number. As in sum of numbers, I got only 10 as an output. But in my binary digits case, it's not like that. I have few binary digits like 0, 1, 1, 1, 0, 0. You know the binary digits concept. So I'm appending my remainder to my binary digits in empty list. And then num equals quotient. So num would be nothing but my quotient will be become the new dividend now. Quotient is 0. If I take an example, if it is 0, 0 would be my new dividend. And then I'm reversing. The binary digits needs to get reversed after that. So the binary equivalent of n would be 5. 5 is, I'll be getting the values as 101. In the thread 1, threading dot thread is a syntax as I told. Sum of numbers we are passing here, and the input as 5 I'm passing it over here, and the name will be thread 1. For thread 2, name would be thread 2. One extra parameter I've given here is name. Then I'm starting my thread 1 as well as thread 2. Thread 1 dot start, print current thread name is threading current thread dot name. Threading dot current thread dot name. I'm printing both the threads. So the output is, if you observe, both are main thread only. If you observe, it is not even thread 1 and it is not even thread 2. Why it is the current thread name is main thread? So you need to observe that always the current thread that is running will be the main thread by default. Current thread, whatever it is executing, main thread. Main thread in the sense it is an application. Okay, so it is which executes always in the backend application. So this is because the target functions are not complex and is executed within few milliseconds. It might be the sum of numbers or this binary. It is executing within a milliseconds. Thus, the program is executing the thread 1 and thread 2 very quickly, and immediately it will switch back to the main thread. And so it is showing here as main thread. Okay, when we print, so when we are printing here threading dot current thread, so it is displaying as the main thread. It is executed after executing thread 1 and current thread will become the main thread. So first thread 1 is executed, thread 2 executed, and then the current thread will become the main thread. So it is very quickly it is getting executed. So that's the reason it is showing as main thread. So Yeah. To observe multi-threading, we need to introduce a delay in the target function. So I want to understand how my threading thread 1 and thread 2 are getting executed. I want it to get delayed. I want it to display my output. At what time is it getting executed? And after how many seconds it is getting executed, and quickly at when it is shifting back to the main thread. I need to understand all those things in detail. If I want to understand these concepts, we need to introduce a delay in the target function using the sleep function. We have a function called sleep. I'll make my function to sleep for a few seconds, and then my next function should execute. And then again, it should come back to the same function after the sleep time, and then it should print the output. So it takes, and from the time module we are doing it, you guys would have learned the daytime modules and all in the basics. So it takes the number of seconds function that needs to be displayed as an input. So this will make the current thread associated with the function to wait for a few seconds and allows the program to be free to start another thread. So we also need to join the threads here with the main thread using the join function of the thread class. In layman terms, the join function will let the main thread or program know about the sequence of threads that are either ready to start or already executing. So time dot sleep number of seconds. You can give the number of seconds. How many seconds it should be in the sleep state. And after that, in this way, when the current thread executing is waiting, the program can start the execution of another thread which is sequenced after the current thread. So syntax to join, I will be joining with my main thread. So we have, as of now, we have thread 1 and thread 2. I am joining those threads to my main thread. So now let's modify the functions by delaying them in the loop for 3 seconds. And then let's print the current thread inside the functions. Okay, for this, first we need to import time, because as we are using the sleep function, import time. We copy the same sum of numbers. So by default, it takes seconds as an input. So whatever the number you give, it will be within the seconds. So while passing the number, be careful. Before it, let me print the current thread also. So at each iteration, we'll understand which thread is it executing. Yes. So now let's try to understand this. As you can observe from this output, when we introduce sleep, after starting the thread, it will attach to another thread that is available because of the join function. Here we are joining it. That joins both the threads to the main thread. So here in the first iteration, as we have passed already, I have given my number as 6. So initially, I will be 1. 1 plus 0, it would be 1. So the current thread name it is executing here is thread 1 because it is in the sum of numbers. So current thread name is main thread, because why it is even showing as main thread? I'm joining it. I'm joining my thread 1 and thread 2, and these threads will get joined to the main thread. Okay, so the sum of by default it is showing a sum of 6 numbers. I have gone wrong somewhere. It should be sum of one number initially. So let me explain this. So initially my sum of one it will be there because I'm giving the range as 1, 6. Number 6, I'm passing input as a 6 for that. So initially my I will be 1. 1 plus 0, it would be 1. My sum is 1 now. Current thread name will be thread 1. It should be thread 1 because already I have assigned thread 1 to the sum of numbers function. So it should be thread 1. Then the sum of I numbers is sum. So sum of 1 numbers is 1. And then it will go to sleep. See in the output, if you observe in the first output, current thread name is 1. Sum of 1 numbers is 1. It will go to sleep. Now it is going to sleep, and then I'm printing my thread name. See, it is the main thread. So that thread is stopped working. The for loop with the first iteration, it is stopped for 10 seconds. And automatically it will go back to the main thread because I'm joining here. Once it goes to sleep, it will come back to the decimal binary function. So for 10 seconds, this is idle. So it will come to the next function, that is decimal to binary. So here it will work with the first loop. So with the first number, it will work. It will print the thread name, and again this will go to the sleep for 10 seconds. So the current thread, once it goes to sleep, it would be main thread, because I'm using the join condition here, because I'm attaching my thread 1 to join and thread 2 to join. Next, it will go for the next thread iteration. So that is for binary. It will go for the binary. So binary digits, so far it would be 0 initially. Current thread name is 2 and it would be 0. And when it goes back, again now the 10 seconds is elapsed, right? It will go back to the thread 1 again. Once it is going back to the thread 1, again it will iterate for the next iteration. That is sum of two numbers is 3. Then the current number thread would again go to the sleep for 10 seconds. Again it will go for the decimal to binary digits. So see, again current thread name is thread 2. So the next iteration is executed in thread 2, that is 0 and 1. Again it will go to sleep, it will go back to the thread 1. So current thread name thread 2, you have binary sum of binary digits so far as 0, 1, 1 here. So why we are getting the output for sum of two numbers is fine, then you are getting the current thread name as thread 2 and binary digits as 0 and 1. Then it will again go to the, after 0 and 1, again it is printing as current thread name as thread 1. Why it is printing like this? Current thread name is thread 2 here, it is 0 and binary digits so far it is 0 and 1. And then again it should go to the thread 2 only, but not the thread 1. Thread 2 only, then it should be 0, 1, 1. And then current thread name should be 1. Okay, somewhere we are missing the statements. Let me make it clear again. If you observe, every time I run the code, the output will change, because it depends on the time it gets executed. Because as of now, we are setting the time as 10 seconds. So when that thread is executed in the 10 seconds, and again automatically it will be assigned to the main thread, and then we'll go back to the thread 2, it will get executed, and again it will come back. See, if you observe here, now my output is different. I didn't make any changes to my code. Now my output is different. As how I got previously, now I don't get it. So see the thread 1, it's not like sequentially thread 1, thread 2, main thread. It's not that sequence, it should get executed. It depends. So my current thread would be thread 1 initially. See, then the current thread name, it is going to the main thread here. See, that is what we are doing here. Current thread name is thread 1. So by the time it comes to the sum of I numbers as sum, so automatically after this thread, in the span of seconds, it is just occupying the main thread is getting occupied here. This gets executed so quickly, and automatically main thread is executed, and then the sum of one numbers is 1. And then it is going to sleep. See, after sum of one numbers is 1, it is going to sleep for 10 seconds. By default, it will go to the thread 2. So in my thread 2 binary digit, so far it is 0. Then current thread name would be thread 1. Again, it is going back to thread 1. Sum of two numbers is 3. Then again, next it will go to the thread 2 again. And then again thread 1. And again thread 2. And again thread 1. See, the sum of four numbers is 10. Simultaneously, after this, it is just automatically going. The wait time matters. So it will be waiting for 10 seconds. But the time it gets executed the next thread, right? Automatically, if it finish early, automatically it will go back to the thread 1. It will get executed and it will print the output over here. So if you see here, current thread name is thread 1. Sum of four numbers is 10. So I got the binary equivalent already. Binary equivalent of 6 is 110. And then the current thread name is thread 1. So the sum of 5 numbers is 15. Sum of 6 numbers is 15. So I have passed here as 6 for my range, 1,6. And the binary, decimal to binary also 6. I have passed as a tuple for both the things as an input. So the sum of 5 numbers is 15, sum of 6 numbers is 15. In the thread 1 only, it simultaneously just got executed with both the numbers. And then the last current thread name would be main thread. So if you observe in the output, when we introduce the sleep after starting the thread, it attaches to another thread that is available because of the join function, because we are joining it, right? So simultaneously in between, if it finds few seconds as free, it will occupy that space. and it will get executed. So that is nothing but the main application. I can tell the main thread. See, I'll give you the general example of phone. In the main application, you're in the call, and even you want to browse something, you want to get some information regarding the Python. So when you're in the call, you'll just turn on the speaker. So the main application, as you call it, is just executing the main application in the backend. Again, you're going to the internet. You're just browsing something, the details regarding Python. And after that, you are just going to the calculator. You're performing some calculations. Like simultaneously, you're executing many things. So multiple tasks are running behind. But the main, what is your main task? It's like you're in the call. You're in the call and that is executing always. So simultaneously it is executing. Your call, it's not getting disconnected as you're using the calculator or you're browsing something. It is getting executed simultaneously. So we are joining the function that joins both the threads to the main thread. So my main thread is my call. Simultaneously, I'm adding the calculator and the Google Chrome. I'm joining to my main thread. It joins to the main thread. So this means the threads can execute concurrently using the multitasking. So here the sleep function, what will it do? It will keep in the wait state. That's it. So it will keep in the waiting state and then it will proceed further. Bit confusing. Just try to understand the mobile example which I gave you just now. What will be your main thread and what will be your thread 1 and thread 2. Thread 1 will be my calculator, thread 2 will be my Google Chrome. So thread 1 and calculator and Google Chrome, I'm joining it to my phone. I mean phone in the sense to the call. So that is how multi-threading will work.
Right, let's take a look at what is a linked list. So a linked list is a linear data structure. Now, a linear data structure basically means that data inside this data structure is stored in a linear fashion. Linearity basically means that there is an order. One data point comes after the next data point, and that comes after the next data point. So this is how linear data structures work. The most common and famous example of a linear data structure is an array or a list in Python. If you have used other languages such as Java and C++, then you are using arrays, and those have linear data. Those are linear data structures as well. So each element or node in a linked list, and node is a term that we use to define a particular data point in our data structure, which is linked list. So node contains two things or two pieces of information: the value that we want it to hold and a reference or a pointer to the next element. Now that pointer could point to the next element if there is one. If there is no next element, it points to none in Python. None basically refers to an absence of value. So this piece of information comes in handy, which we will take a look at when we're implementing the linked list. So as you can see that a linked list, we use node. Now node is one way to refer to what we are describing. You can use other terminologies such as elements or any other thing, but node is what the community has settled down on. That's the keyword here, and it uses reference or pointer for the next element. Now the reason why we're using the word reference and pointer is because depending on the language you call them different things. In Java and in Python you use reference, which basically means you ask for the address of an object in memory and it will be given to you by the runtime environment. On the other hand, in languages where you get to manipulate the raw internal memory of a system, such as C++ and other languages, you can use pointers. Pointers also allow you to do arithmetic on the addresses, where you can add a few things and get the next address. But that's not possible in references. In any case, you can implement these data structures in any language that you desire. Whether it's Python, whether it's Java, whether it's C++, whether it's any other language, you can use them in all of those. Right? So let's take a look at the benefits of using linked list. So a linked list, using a linked list has several benefits. The first one is that it is dynamically sized. A dynamically sized linked list basically means that it is a list in which you can add as much data as you can, or as many nodes as you want to, as long as there is space in memory for you. Now you might be wondering that that's also the case with arrays or lists in Python, and we'll get to that in a moment. But since lists are also dynamically sized, there is one tiny bit of problem with lists that we'll discuss later on. But the important aspect is that they are dynamically sized. Now, similar concept to list in Java and C++ and other statically typed languages is arrays. Arrays are not dynamically sized. They cannot be sized dynamically. They only have one type, and you cannot add more data to it after a certain point. You have to define the capacity of an array when you're declaring it and when you're instantiating it. In C++ and Java, if you have created an array that can hold 10 memory items, you can't add 11th one. That would be considered an illegal operation, and that would cause your program to crash. Just know what the error is and how you can use linked list to solve those errors. Arrays are not bad. They are used for specific purposes, and if you want to only store 10 memories, then using a linked list is just an overkill. So understand the problem and then use it. In any case, linked list can be dynamically sized. It allows for faster insertion operations. So let's compare it to other data structures such as arrays, as that's the only one we know right now. In an array, let's say we have 1,000,000 elements, and I want to add something right at the beginning of the array. Even though it might be dynamically sized, what I would have to do is firstly grow the size of the array. So from 1,000,000, it should now be able to store 101,001 element. Then I have to shift all the elements one place back. So the element that was at the millionth place now needs to go to the 1,000,001st place, and that way we need to shift all the elements available.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And then all I have to do is rewrite the element that is the 0th index at the beginning. Similarly, if I had to do the same thing for any other place in my array, such as the 10th index, 15th index, 17th index, I would have to do the same kind of process. Just I would have to stop at the 10th index and not go till the end. Now that's useful, but as you can see, it's quite inefficient. I just want to add one element at the beginning. That's not what I want to do. So in linked list, you can do it quite easily. Since in linked list, all you have to do is just create a pointer, point its next pointer or reference, store the next reference to the beginning of the list, and point the pointer that's pointing at the beginning of the list to the current pointer. It might sound very typical, but don't worry, we'll take a look at that in the demo. So you don't have to worry about that. That's the way it works. So this is why insertions are much faster in linked lists. This is why linked lists are preferred in situations where we have data that is being dynamically added. So we need to figure out where we want to add it and how we can do that. Next, let's take a look at faster deletion. So again, it's the same problem. If I wish to delete 10 elements from my array at random points, and I want to shrink the array, now I have to firstly remove one element, shrink the array from the back, then do the same thing again and again and again. That is also quite inefficient. In linked list, all I have to do is just make sure that there are no dangling pointers. That means that if I'm removing an array or I'm removing a node, I just want to make sure that the node that is occurring previous to the current node and the node that's occurring next to the next node are connected to each other. That's the only thing that I need to take care of. Other than that, we just have to remove the data. The rest all will be managed by either the garbage collector, or it's something that I would have to take care of on my own. Now, again, depending on how you are implementing these structures, you can implement them in several different ways, but it generally leads to a faster deletion time. Then comes memory utilization. Now, many data structures need contiguous blocks of memory. In linked list, you don't need continuous blocks of memory. So, for instance, if I want to store 10 million data points or 10 million nodes of linked list, I just need to find 10 million small patches of memory where I can store my linked list item, and the rest I can just point to the memory address of the next element in each of the node, and it will work just fine. On the other hand, the memory utilization is not going to be great in arrays, because in arrays we have a lot of we need to have contiguous blocks of memory. This is how arrays are implemented underneath the hood. This is also why we need to define a fixed size right at the beginning, because it's more efficient that way. So when we have an array and we want 10 million data points, what we need to do is we need to firstly find out a block of memory in which I can store 10 million data points, and assign that block of memory, that block of contiguous memory, to my program, so that it can add 10 million arrays, 10 million indexes inside my arrays, inside my memory. Now, that's easier for us to do, but it causes a lot of overhead on our memory's part, because let's say that there are few patches of memory that can store 2 million, 4 million, and 4 million again. Now, for our memory to be able to be used by arrays, our computer or our operating system would have to defragment the memory, which basically means just rearrange the memory in such a way that all the empty space is patched at the bottom, so we can easily use this again. That takes a lot of time and could hang our computer and could lead to degradation in our computer's performance and speed. So let's take a look at how we can fix something like this. So we use linked list for that. But before that, let's take a look at lists versus linked lists. So what is the difference between a list and a linked list? A list is a Python programming construct. So when we're talking about list, we're talking about the native Python implementation of a list. And a linked list is going to be something that we will be implementing in a few moments' time. So in Python, we already have a built-in data structure named list, but it is a little different than linked list. So although it might seem that the internal implementation of Python's list might be the same as linked list, mainly because we are using dynamically sized linear data structures, there's some key differences. A list is stored as a contiguous block of memory, while a linked list is stored as a bunch of nodes scattered around memory connected to each other. So if you want to store some small pieces of data, then you can use lists. But if you are going to store a large bunch of data and you need to be able to dynamically size it and want to add and remove data continuously from it, then you can use, instead of using list, you can use linked list. Linked list is much more efficient for that purpose. You can use lists for that as well, but the memory consumption is going to be high and it's going to lead a degradation of performance. So it's up to you which one you use. You just need to understand how to use, or in which situation to use which one. Both these are tools. Understanding which tool to use when is going to be really going to be the key to building good software. So now let's take a look at the types of linked list. So there are many types of linked list. Since linked list is a very versatile language, we are going to mention only 3 of the most used types of linked list, but you can use other kinds of linked list as well. The first one is singly linked list. In a singly linked list, we only share a single reference to the next one. So basically what it means is that we have a data point that contains, or a node that contains some data and reference to the next element. If I go to the next element, I can't go back to the previous element. There is no dual connection. It's just a single line of traversal. So this is what a singly linked list is. Then comes doubly linked list. In a doubly linked list, we have both pointer to go from current to the next node and from the current to the previous node. So that way we can traverse both front and back in our data structure. So these are two different kinds of data structures. And then there's circular linked list, in which the last element of my node is going to point to the first element, so that we have a circular linked list. Instead of storing it in a linear fashion in which we have the beginning and the end, we have, instead of having a beginning and the end, we have a circular structure. Now all of these can be used for their own purposes. In singly linked list, we use data structures to implement single data points. These are called nodes. The main important aspect that is different from singly and doubly is the memory usage. The memory usage of the doubly linked list is going to be significantly more because it's storing 3 pieces of information, not 2. Whereas in singly linked list, you're only going to be storing the data and the reference to the next element or next node. So that's the thing. Now, another thing is that they are used in different things. So singly linked list can be used in the back and forth feature. It can be used to develop stacks, which can be used to develop the forward and backward features in web browser. So when you visit a browser, then you go forward, then you go backward, then you go to another address, then you go backward, and then you go forward. All of this is implemented by singly linked list, and it's quite easy to do it with doubly linked list. In singly linked list, it's a little difficult, but it could be done if you do it using stacks. On the other hand, in doubly linked list, you can perform many different kinds of things as well. And circular linked list can be used for developing caches, something that is called LRU, or least recently used cache. And that's one of the most important implementations of circular linked list. So you can use it that way. And you can implement circular linked list using singly and doubly linked list, which basically means using single link or double links. Double links means something that points to both the current next node and the previous node as well. So you can use it that way as well. Now let's take a look at a demo of implementing linked list in Python. So as promised, I have a Jupyter notebook, and here I'm going to implement the linked list. So you don't have to worry about how I'm going to do it. Just follow along with the code. If you have Jupyter notebook with you, you can do it quite easily. So Jupyter notebook is not really necessary in this case. You can also write the code inside a simple Python file and then run it. I'm using Jupyter notebook because it's easier for me to show how things are being implemented. Since we need a node, the first thing I'm going to do is implement a node. So just create a class, call it node. That node class needs to have a constructor. In Python, a constructor is called an initializing method. Call it self. In the self method, inside the self, after the self keyword, I need some data and the next pointer, and ext, should be pointing to null. As you can see in Jupyter notebook, this is highlighted as green because next is a keyword in Python. In case you don't wish to use the next keyword, you can use something else, some other keyword that makes sense. I'm going to use it here. It doesn't really make much difference here, but you can use it for something else as well. And by default, it's none. So if there is no other point that is given to us, it's going to be next. So now all I have to do is just give it some data. And also I can use the data to be none as well. So it just doesn't contain any data. And now self dot data is equals to data, and self dot next is equals to next, and that is done. So that's our node class. This is what is going to contain a single data point. If I run this, I don't see any error. If I were to create a new data, let's call it n1, and I don't do anything, press n1.data, run it, doesn't print anything. If I press n1.next, doesn't print anything. On the other hand, if I were to pass in 1 and if I were to print n1.data, it contains 1. And if I were to pass in as the next element a new node with the value of 2, this is 1, n1.next would give me the address, and I want the data here, and that's no. And I can do the same thing again and again. So here after this I can do it node 3. This is what it looks like, and I can go to the next element and it's this. So it's quite easy to use it that way, but we want to do it in a little more efficient manner. So all I can do is I can implement it using a linked list. Now inside the linked list, I don't need to inherit it from any other class. Here I am initializing it, and all I need is self. So self, and you can call it anything. Many people call it start, I call it head. So head is going to be the element that is pointing at the beginning of our list. If head is null, which means there is no beginning, that means our list is empty. And if your head is not none, that means that there is some element at the beginning. How many elements are there? That can only be determined by going through the entire list, but we know that there is something at the beginning. That's all we want to know. So with that, we have created the initializer or the constructor function. Now comes the meat of our application. Here we have to implement the insert function, or the insert method, since it's inside a class. First parameter is self, second parameter is data. Now comes the interesting aspect. So what we do is we create the new node here. So it contains the data, and the next pointer is going to be pointing to nothing. Now it is up to you how you want to implement it. What many people do is that they create two separate functions: insert front and insert back. Now this depends on how you want to implement it. I want to keep this simple, so I'm just going to call it insert. Insert front and insert back basically mean I want to insert some data at the beginning of my list, and insert back would mean insert some data at the end of my list. Depending on how you wish to implement it, both are validating. Just understand why you want to implement it at the front or at the back. Now all I want to check is if, not if self.head is not null. Now I could simply just do this, if self.head. That would lead to the same thing, but I want to be more explicit here. So basically means if there is some value in the head, the head is pointing to, that means our list is initialized and there are some elements already there, and I want to put it at the end. All I have to do is I have to current is equals to self.head while current dot next is not none. So all I'm checking is, so I'm going to go to the next element till I don't reach the end. So right at the beginning of the end, which I'll show you, current is equals to current dot next. So what I'm doing is, let's say that I have a list in which I have one that point to 2, that point to 3. Let me just make it a little easier to read. Now what happens is I take a look at the head. Head is going to be pointing to 1. From here I take a look at the head and I understand that there are elements here. So I assign this to current, which is here, and then I keep checking, does it have any next element? It does. So I go to the next point, which is here, current is equal to current.next. Then I check if there's some element after it. There is. So I go there. Then I check if there's some element after it. There is not. So current is currently pointing to the end of the list, right? So after reaching there, all I want to do is current.next is equals to new node. So let's say the new node is 4. Now current.next is going to be equal to 4. In actuality, it's going to be pointing to none here. So I'm checking if the next element is not none, then move ahead. It is none, so I'm going to go to 4, and its next element is none. And now we're done. So this is how this is working. We have inserted an element when there is no element present inside our, when there is some element present inside our list. But what if there is no element? Well, then we can just basically do it this way. Self.head is equals to new node, and we're done. I'll have to add an else clause here, and we're done. So we have created the insert function. Now insertion is fine, but what if you want to print the list? That is where we come here. So def print list, and I don't need any argument other than self current is equals to self.head, and while current is not none, all I have to do is print current.data. Okay, so this is done. Now all I have to do here is create a linked list, which I can call it anything. I'll call it list, or for simplicity's sake, I'll just call it L. Linked list. I have created an object of linked list, which means this code ran completely, this portion of it. Now I have to insert some data here. So L dot insert 1, that works. 2, that works. 3, that works as well. So as you can see, I didn't have to define a particular size. The size is being automatically generated for me. It's automatically being increased in its size. Now, if I print the list, as you can see that it is going on uninterrupted, right? That's a problem. So let me just call cell dot, and this is a problem that we're going to see in a moment. Restart and clear output is going to be the one. This is also one of the reasons why I chose Jupyter Notebook. And now let's take a look at why this failed. And the reason is quite simple, because we have not moved ahead in our list. What happened is, after we print the data, we want current is equals to current dot next. This is a mistake that many of us make many times. What's happening is printing the current data, and we're going to the next value, and we're checking, okay, now am I pointing to nothing? If not, then that means there is some data left to be displayed. So I'll just rerun it again from the start. Linked list, insert, and print. And as you can see, it's being printed correctly. Now, if I want to print it entirely on one line, I can just, and now it's done. So this is what it looks like. As you can see, it's not really difficult to implement. It's basically 15 lines of code, creating, insertion, and printing. You can also delete the nodes. There's many different articles and different ways of doing it. And now I'd like to show you how you can implement a doubly linked list. So we'll implement it from scratch again so that it gets settled in your memory. To implement it in a doubly linked list, you have to implement it the same way you implemented singly linked list. Firstly, you have to create a node that's going to be a little different from the singly linked list node, and I'll show you why. Hopefully you remember why, but let me just show you anyway. So we need self, then we need data, which could be none. Then we need the next pointer, which is by default none. And then finally, we need a previous pointer, which is going to be equal to none as well. And this is the crucial bit of difference. We didn't have this earlier. So now all I have to do is just self dot data is equals to data, and do the same thing here. Self dot next, and self dot previous is equals to previous. Run this. This is working. Now let's just check if it's working correctly before moving ahead. Node data is 1. Okay, so I print n dot data. This is what it prints. Now I want something to be before and after this, right? So I can just do it this way. Node 1, node 2 is going to be this. Or we can do it this way. We can create 3 nodes. 2 and 3. N1, N2, and N3. So N1 dot next is going to be N2. So right now what we have done is this. We have created 3 nodes, N1, which is 1, which is pointing to 1, N2, which is pointing to 2, and N3, which is pointing to 3. Now what we want to do is, we want to convert it to this. N3 plus N2 should also be pointing backwards, and N3 should also be pointing backwards. This is the whole reason why we do doubly linked list. So N1 should have a reference to the N2. N2 dot previous should have a reference to N1. So this could be done. Then N2 next should be N3, and N3 dot previous is equals to N2. If I do this now, if I were to print N1 dot data, prints 1. If I were to print N1 dot next dot data, I have an invalid syntax error here. N3. Now if I were to do it, if I want to go a step back, I can just do previous, it should print 2. And again, I try to go previous, it should print 1. That's how that looks like. Now if I were to do this, here's if I want to implement it in a doubly linked list, all I have to do is type class doubly linked list, def init, we pass in self, and that's about it what we need to pass in. The implementation is going to be quite similar. It's just going to be one piece of difference which I will highlight. By default it's not pointing to anything, so it is working. Def insert. To insert something, what we need is the reference to self and some data. So all we have to do, if self.head is not none, which means that there is some value in self.head, then all we have to do is, firstly we have to create a new node as we had done earlier. with the data. And now if there are some values, first we have to get to the end of the data. So current is equals to self.head, while current dot next is not none. Current is equals to current dot next, and we keep doing that. Once we reach till the end, we make current dot next to be equal to new node, and now comes the new bit. New node dot previous is equals to current. So what happens is, let me just visualize it for you. As we had done earlier, let me just use this. So we have the first node, which is head. It is pointing to 1, let's say, which is pointing to 2, which is also pointing backwards, right? And now we are here.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The next of 2 is pointing to none thus far. We create a new element, which is 3. So we go here, we remove it with 3, and we create the previous pointer to be pointing to 2. This is what we're doing, right? So it's easy to understand, and this is, we can do it very easily. But if there is no element, then basically all we have to do is self.head equals to new node. Quite simply the same code that we had earlier. And similarly, all we have to do is call the print list function, pass in self, while, and also we can current is equals to self.head, and just check if current is not none. We print current.data, and we go to current's next pointer. Run this. We have run into an error, which is if self.head is not none. We are running into an error in line number 7. So it's here. Let's see what is the issue. Is not none, not in, not none. That is the issue. So now we have come up with the issue. Now let's create a new node. Let's call it L again, and I'll call it W linked list. Don't need to pass anything. L dot insert 1. Now we want to insert 2. Now we want to insert 3. And now all I have to do is go through the entire thing as we had done earlier. So L dot head dot data, L dot head dot next dot data, L dot head dot next dot previous. So we go one step forward and then one step backwards. Should print 1, which it does. Next dot data 3, previous dot data, and should 2. So as you can see, we have a way to move forward as well as backwards here as well. So that's what W linked list is. You can do other things as well. Deleting items here is going to be a little tricky, so just make sure that you have access to the previous and the next nodes, and that way you can take the previous nodes next pointer pointed to the current element's next node, and the next element's previous node should be pointed to current element's previous node, and then you can just remove the data that you have. It's very easy to do, quite easy to do in many ways. So we're done here.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what are these operators? Well, these are some specific characters which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes 2 operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So for example, I'm defining a variable var equal 10. So this equal to is nothing but an assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20 since the value of var is already 10. So 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again, the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, B equal 20. A is greater than B. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator.
Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay, let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equals 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1 and again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. So that's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Alright. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched, like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2. Since you have mentioned 10 right shift 2. Alright. So 1010 shifted 2 bits to the right. 0 0 and remove 1 0 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0 0 1 0. Now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you're performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010 and you're adding 2 bits in the end, since you are shifting 2 bits to the left. So you're getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 000 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you are getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright. For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright. It is just used to test if the operand shares an identity or not. Alright. So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright. And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So this was all about the Python token. So moving on ahead, we'll learn about data type in Python. Well, Python has majorly two data types, immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright. Immutable data type consists of numbers, strings and tuples. On the other hand, mutable data type, they consist of lists, dictionaries, and sets. Alright? So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has 4 different types of numeric literals: integer, long integer, floating number, and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function, or complex function. Alright, you have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now, what if I want to check the data type of these variables? So how can I do that? So for that, we have type function. So print the type of variable A. Alright? Or print the type of variable name. Or print the type of variable salary. Fine. Execute it. Sorry, there's a typo. It's type. Alright. So you can see that variable A is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright. Let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright, let's perform some operations on string and understand them in detail. Suppose I have first string as hello world. And my second string is Intellipaat. Alright. Now, what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1 and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello starting from 0 and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 + 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find, and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5, and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str dot replace. What I want to replace? First mention that I want to replace me with what I want to replace. It's m. Fine. Execute it. So you got the output as attachment. attachment. Fine. me is replaced with m. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach dot replace. So what you need to replace from here is ment. You don't want ment from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the base of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these 3 different words are separated by comma. So what I want to do, I want to split the entire string on the base of comma. So I'll write split str dot split on the base of comma and execute it. So as you can see, I got the output as 3 different words. Word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals Intellipaat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me it will be 1. I'll tell you why. See, the output is 1 because well, remember I told you Python is case sensitive, so both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me Intellipaat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? Since in capital Intellipaat you have 2 i's. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, @ #123, capital A, small b, small a, c, capital C. Alright, so this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5, execute it. I must to mention this, put it under the quotes, execute it. So the character with maximum ASCII value is small c. Alright, or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine. So let's move ahead. So well, next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright. So this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal, within the parentheses, I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically, concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. What is the invalid syntax up here? Something is invalid, yeah. Let's define it again. Okay, this semicolon is missing up here. Fine. Execute it. So yeah. So this concatenated me and gave me the result as A, B, C, D, E and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3 and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple, I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3 and 4. Fine. So I'll get the output as B, C, D and E. Let's check it. So I got the output as B, C, D and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learned in tuple. It is used to add two or more lists together. Let's define another list as my list 2. My list 2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with my list 2? So what I'll do, my list plus equal my list 2. Let's see what is the result. Let's print the value of my list. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because yeah, I executed it twice. It's my fault. So what you can do, you can just my list dot remove. Hold on. I don't want to execute this entire list or statement, so I'll define it under different block. So my list dot remove Python. Okay, I have misspelled Python as okay. Remove this. Again, remove this. And remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of times. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1, 3.14 and Python. And we want a sublist from 1 to 4th index number, like 1, 2, 3. 0, 1, 2, 3 plus 1. 4th won't be included. So we'll get the output as 1, 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right. It's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different strings. Alright. For example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want. For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position and you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between a list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you're grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, 1 apple, 2 ball, all are taken as a pair element. Fine. Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, my dict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces. And you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. my set S2 consists of 1, B and C. So if I'm performing a union on it, so it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1, 2C, 1, BC. So we have 1 and C common in both the sets. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set, and it will return the only value which is a unique in first set. For example, we have 1, 2C in set 1 and 1, BC in set 2. So if you subtract it, so you have 1 in both the sets, so it will emit it. 2 and B, so nothing can be done about it. C and C, again it will emit it. Now since only 2 is left in set 1, so you get the output as 2. Alright? Fine.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So this was all about the data type in Python. So now that your base is clear, let's have a quiz. So what would be the output of the following code? Test1 equal Python programming and print test1 from 2 to 6. In order to know the correct result, do post your answer in the comment section below. Alright, so let's move ahead. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break, and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Let's see the flow of execution. You start it, you check the condition. If the condition is true, then execute block 1. If the condition is false, then go to the else part and execute block 2. Fine. Yeah, this block 1, it comes under if part. Alright. Let's move next. Let's move ahead. Next is nested if else. Let's see the syntax. If condition 1 is true, then execute statement 1. Else, if condition 2 is true, then execute statement 2. If none of them is true, then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition, that is else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, then finally the else block would be executed. That is execute block 3. And yeah, remember one thing, there is no condition associated with the else block. else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterating variable in sequence, colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement. Again increment the value of count by 1. That is count become 2. And again check if 2 is less than 3. And so on, continue this till 10 is less than 10. And when this thing arrives that 10 is less than 10, your condition become false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright, we have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x. X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for x in fruits. Now x of 1 is banana. Then print x. X is what? Banana. So it will print as banana. Again, it will go back. X in fruit of 2 is what? Cherry. Print x. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code. Like a equal 1. In variable part I got a equal 1. While a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is, A is even. A in this case was 2, so 2 is even. Fine, so this is our output. Next, again it will go and increment the value of A by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
For example, A equal 10. While A is greater than 0, check for if A is not equal to 5. If A is not equal to 5, then print A. Else break it. Fine, let's execute it. Sorry. Just manage. A minus. So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition. Alright, let me just show you. Let's just replace this break with continue and let's see what is the result. So yeah, see, got the output as 9, 8, 7, 6, 4, 3, 2, 1, but you didn't got 5 up here, right? Why? So as I told you, this 5 was skipped. Fine. So this was all about the flow control. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instructions that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by user is a user-defined function, right? Syntax. It starts with the keyword def, after that an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b and return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that I'll write a function name as add. Inside that I'll pass two arguments, a and b, semicolon, and this function should return me the sum of a and b. Alright, fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function which returns the absolute value of a number. We have all function which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def that is keyword. So we are defining the function as print the value of b is b, and again inside the function we are updating the value of b to be 100 and print the new value of b is b, and then what we are doing, change it and we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you in order to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function, we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30. And the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2. Inside this, d is what? Print the value of d is d. Alright. Next we'll define some numeric literals like d of 0 is equal to 99. D of 1 equals 98. And then print the new value of d is again d. Fine. This is my function. Now if I call my function using pass by reference, so my function 2, and I pass the value c into it, so let's see what we get the output. So we got the output as the value of d is 10, 20, 30 and the new value of d is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright. In pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Now let's discuss about the lambda function in Python. So what is this lambda function? Well, a lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10 and then print x. Inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright. If you change 5 to 10, the output would be 20. Alright. Let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes two arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 comma 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass two arguments up here, x and y, colon. Now return me the product of x and y. That's it. It's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass two values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n. So you are defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook. Define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it. So my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the lambda function. Fine. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon, and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python. So coming to our last topic of file handling in Python. Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it will return you an error. Next is the append. and the mode is A. Alright, what it will do, it will open a file for appending, and in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine, I'll tell you about the difference of appending and writing later in this section. Alright, next and the final one is create, that is X. It creates the specified file and it returns an error if the file with the same name exists. It creates the specified file and it returns an error if you already have a file with same name. Fine, let me just show you. Like f equal open path of the file. I'll open it in my D drive, D slash name of the file, test file dot txt, and comma, what should be my mode? It is a reading mode, R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here and it will create your file. Let's go to our D directory and let me just show you the file. D, so you can see the test file up here, right? So this is how you can open a file in Python, or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. Test file. Hello everyone. Welcome to Intellipaat. Good luck. Let's save it. Save it as test_file.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode R. R is what? Reading mode. And then print f.read. Fine. Let me just open that file for you. F equal open. The path of the file, it was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f.read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to Intellipaat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine, which would be used to return one line or the first line. Again, copy it, paste it up here, read line, just hit enter. Sorry, you got an error. Okay, read line. Okay, sorry, L is small, read line. So you got the output as hello everyone. This is my first line. Next, what if I need to read first two line of my document? So what will I do in that case? So in that case, what you can do, you can use read line twice and it will print first two line of your text like this. Again, do it once more, f dot read line, hit enter. Again, the same error. Okay. So what you got? So you got the first two line from your text. All right. Now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to Intellipaat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f dot write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, just check the existing file. Open it in a readline mode. R for x and f, print x, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use w instead of a? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen my file.txtx, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do? You have to first close the open file. So f.close, inside this, mention the name of the file, or the path of the file, d:/test file1.txt. First close it. Sorry. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Test file1.txt. That's it. Got the error. The system cannot find the specified file. So I guess the file is, no, it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Okay, let's get started with NumPy. So I believe you guys already know like what Python is capable of, how powerful it is. So we can use Python for all sort of things, right? From desktop development, web development till data science, we can do anything and everything with Python in the programming world. And next thing is Python builds upon its functional modules. Okay, so it has all core constructs of programming. Like there are 3 types of programming that we have: structural, object oriented, and functional. So it is capable of doing everything. Okay, next is when we work with anything in Python, we have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with Pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have a alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am getting it again and again, pip install numpy, so it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing, yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Next is ND array object. Okay, so in NumPy, as I have shown you, two 2D arrays, right? It can go up to n and then can have any number. So in the real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use numpy arrays. So in numpy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for numpy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see if you want to see the first column, you need to do this, right? So you need to do this, so you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming. Okay, I am working on 2D arrays, sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names? A and B, right? 2D arrays I will be showing you, not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print whole. If we do this, that also will mean the same and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now numpy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than numpy array. Okay, now next is if you go into check the individual. Yes, right. So it will be begin colon n minus 1. That is how. So right hand side will always be excluded like that. Okay. Next is numpy array initialization, right? So how do we initialize numpy arrays? As we have already seen, right? How do we do that? But still, this is how you do it. Okay. So initialize means what we want to do is we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in numpy. So what you do, you write np.zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np.zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in numpy. So that's how you print zero arrays in numpy. Okay, next is if you want something with the interval, right? So how you do, you write like this, np.array, within bracket we pass, so it will print you another new array. So what we are doing, we are in here what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's a range, so it's a range actually. Okay, so what we are doing, we are passing three variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having five, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have three numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go, okay? Till 20 we will print it out, okay? So that's how this kind of arrays are getting printed out in Numpy. So using this A range you can have other type of arrays also. Data visualization, why it is needed, what what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture what is data visualization. So data visualization is basically presenting a data, presenting numeric or any kind of data with using using charts and graphs and or any other pictorial formats, right? So by that what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay, also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like, see, this is the data that we drill down and this is what we have found out, so this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time what you will do is, you will grab a already defined and already optimized library that is available in net. Those are all the time will be open sourced. So those open source libraries you can grab and you can use those use those as it fits your purpose. Okay, so that's what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are going to give a summation like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them like, okay, this is what is the thing. Okay, and we can ask data from clients also. So that's how we can do. Okay, so in those cases, data visualization comes really handy. Okay, and data visualization is presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have, 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some till 18 you will have some xyz kind of data. But that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, right? Like girls are more initiative in this. Or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this. And next is data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just just plot this data, if you just show them with the picture, like compare the upper table and the below pictures, then later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always always be using this technique to get some insight from the data, like that. Okay. Okay, so now the thing that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right? Like some average, standard deviation and all this kind of average basic stats, then you will see that those have almost the similar kind of values, right? Some is always like 99, some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye, like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you will, where you will see how different the data sets are, how different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right? This will look something like this, that is in my screen. So let me just grab my piece of code for this ANASCOM portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried, that that is already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation, it's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only one or two points are here and there, those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data, it is stacked. All the points are stacked in here, because if you check this, all the x values for the last one is set as 8 except one, for one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one, for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this ANASCOM portrait is a unique data set. Okay, this ANASCOM just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this NSCOM quartet was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with 4 data set, obviously with 4 x and y data sets. So for 4 of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay. So for in here, those 4 of them are all the 4 of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay. So that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import Matplotlib into our Python code. So Matplotlib, why Matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this Matplotlib code, right? So that's where what we are doing is, in this Matplotlib code, what we are doing, we are just this is a Matplotlib library, and this is a object oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this xy points and you can try plotting these points in the plot like we showed in the last class, right? How to plot a line chart. So you can try it that way also. If you are not having the data set also, so then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this Anascom quartet picture won't be given. I think so, because I don't have it. If they have updated, then fine, you can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take 2 arrays x, y, x1, y1, x2, y2, x3, y3, 4 arrays you can take of x and y, then merge those, like for x, y plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see, the equation will fit this one to some extent. So yeah, that will be better. So if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here, we have used plt.plot x and y1. If you even if you for now, if you do even if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now, keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things. No need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done xy1, xy2, xy3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why is that? Because if you see, the x part for all these 3 datasets are same, right? So only one array would do, and for y we have 4 different arrays and we have plotted those. Okay, We have plotted those using this plt.plotline. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, I mean, if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one it will take the horizontal axis, second one it will take the vertical axis, so it will have x and y too. Okay, other things we are that will be we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have Matplotlib, ggplot, Seaborn, Plotly, and geoplotlib. So all these plots comes handy in data visualization, but the Matplotlib, it has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like, as you saw, right, we have a setup function, we have a access function, text function. Those all those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is Matplotlib is there. Next is Seaborn. Seaborn is again built on top of Matplotlib, and that's also a very good plotting library. So, but and generally we use Matplotlib the most. Then comes the Seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multidimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that, like the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multidimensional graphs. So 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is this is a next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings. So that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name, that's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on Numpy, so Numpy is also possible. I have shown you examples, but this Matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib, and how that can be used, and what are the usage of those graphs, and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.arange. Okay, we have taken a x variable np.arange, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is I mean, that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is.
What are exceptions? So let us understand that. Firstly, let us look at the definition of exceptions with regards to programming. In programming, an exception is defined as an event which stops or interrupts the intended flow of a program's execution. So, as a programmer, when you write code, you have an intended flow of how your code blocks will execute, in what particular order, and what exactly you need to execute. So, anything that comes in between, anything that occurs out of the blue, any exception, so to speak, any error that happens that is unaccounted for will totally interrupt your flow, and that is called an exception. And we need to deal with that in programming sense, because otherwise we can break our applications, right? So let's look at this from a technical perspective. There are two types of programming languages that exist. So the first is compiler based languages, and the second is interpreter based languages, right? So in compiler based languages, what happens is all of the code is firstly compiled and converted into bytecode so that the machine can execute it all at once. So in this particular case, before the execution of the code is converted into low level language, right? The entirety of the code. So in this particular case, what will happen is you'll basically have your code structure where the code starts. There will be a code module 1, a code block 1 that will execute, which doesn't have any errors or exceptions. So it will execute successfully. And then if you encounter a code block or a part of the code where there is an exception, a code block, so it will simply throw a compiler error that there is an exception over there, or there's a code error over there. Simply go and fix that. But it will not interrupt the code module 3, at least in the compiler sense of way. The module 3 will compile successfully, and you can even run the code and it has a chance of running successfully. So this is called compiler-based languages. These are like, for example, we can take C, C++, Java. These are compiler-based languages. All of the code is first compiled and then it is executed. So on contrary to that, we have interpreter-based languages. Now, in interpreter-based languages, the entirety of the code is not compiled. It is just executed line by line. Right. So Python is one of those languages. Obviously, Python is an interpreter-based language. So the workflow of interpreter-based languages goes something like this. So the code starts line by line, right? The first code module is executed because it does not have any exceptions. It is correct, so it is executed. So the next code module where there is an exception, when that is encountered, right? What that will do in interpreter-based languages is that it will stop the execution altogether. So the next code module will not execute either. right? So what happens essentially in this particular case is that even if the code module 3 does not have any exceptions, it is completely logically correct, right? It will still not execute. So in interpreter based languages, not handling exceptions could lead to the entire application breaking, right? So we want to execute things that are correct, right? Even if code module 2 is wrong, we want to resolve that particular issue and we want to move on to code module 3. So unless we handle these exceptions, that is not going to be possible, right? So exception handling is meant to deal with exactly this. So let us look at the workflow of this particular case if we handle the exceptions. So how to handle exceptions in interpreter-based languages? It is sort of the same for compiler-based languages as well, except we all know the logic of whether all the code modules will compile or not in compiler-based languages. In interpreter-based languages, we do not need to concern ourselves with that. Uh, what exactly happens over here is that the code module 1 will execute successfully as it should. When the exception is encountered in code module 3, we can see a little bit of change in the flowchart, except for the arrow, instead of the arrow pointing downwards from code module 3, right over here, as we can see, the arrow goes to the right and it basically goes into the condition which says that if there is an exception, execute this part of the code on the right hand side and then continue as usual to code module 3. So even if there is an error in code module 2, we have created a fail safe for that essentially in this if exception clause. So whenever there is an error which is encountered, we go to the if exception clause and then the if exception clause continues on to code module 3 and we are able to execute the entirety of the program as much as possible without actually having to stop the execution at all, right? So this is how exception handling happens in a diagrammatic view. So now that we understand the workflow of exception handling in Python, we can look at some examples of exceptions that can actually occur in Python in day-to-day programming. So we'll look at some simple ones so you understand the concept. The first one we're going to look at is called the zero division error. Now, the error name is pretty straightforward. It happens when you try to divide a value by zero, or you basically try to get the remainder of that particular value by zero. So, the modulo operator or the division operator. So, essentially, if you understand this arithmetically, when you try to actually do this in theory, what happens is you get infinity when you divide a number by zero, right? In computational terms, you cannot actually compute infinity. So to deal with that particular issue, what programming languages do is that they throw an exception when you try to run this particular operation, right? So you can design cases to deal with this particular exception if it happens. Other than that, this is what the error is called. It's called the zero division error. Then we have the name error. Now, in name error, what happens is when there is a variable name that you're using, which has not been defined previously, right? And you're directly using it, it'll throw a name error. For instance, if you try to write a statement, which is a equals to b plus 3, and you haven't defined the value of b, right? Then it'll throw a name error because this b variable has not been defined. Then next up, you have type error. Now, the type error refers to data type mismatch, essentially. So what happens in this is when you try to basically perform an operation where there is a data type mismatch. For instance, in this particular example, we can see that A equals to hello, which is a string value, plus 4, which is an integer value. We are trying to add an integer to a string without any implicit or explicit conversion, right? We're not trying to convert this particular integer to a string value and then trying to add it. We're trying to add it as a numeric value itself. Now, in programming logic, that cannot happen. We need to convert this 4 into a string if we want to add it to our hello value, right? So in this particular case, it will throw a type error because there is a data type mismatch between string and an integer. So, if programming languages have defined a variety of exceptions, there must be a way to deal with these exceptions as well. So, what happens essentially is that every programming language has its own way of dealing with these exceptions, right? In Python, there are ways as well. So, let us understand what is exception handling first. Exception handling theoretically is defined as the process of adding fail-safe measures into the code to keep the program running in case of an exception, right? So it's essentially used from the application point of view to stop the application from breaking when an error is encountered, right? So let us understand the various methodologies that Python implements to deal with these particular exceptions. So firstly, we use the try block, right? So the try clause is used to define the block of code that you intend to successfully execute if no exceptions occur, right? So instead of writing code straightforward, like writing print text without the try block, what you'll do is you'll simply write the try and then you'll indent a print statement after the try, right? So this print statement is now under the try clause. So if an exception happens, you can now handle this particular exception. And instead of the program simply giving you an error and stopping, you can now find a way to deal with this particular exception. You can try this code. If this does not work out, you can deal with the exception that happens. So next up we have the except block, right? So the except clause is used to define the block of code that you would want to execute if and when an exception is encountered in the try block, right? So say in this particular case, suppose the print statement fails. So when it fails, the control goes to the except block and it will print exception, right? So you can deal with this various ways. You can add various categories of exception in front of the except clause to deal with that particular exception only, which we will see in the example that we are going to execute. But this is how you would deal with a particular exception. When you try a part of code and it does not execute successfully, you can straightforward go to the except block and execute that statement, which is present in the except block. Then you have the else block. Now this is an optional block of code that you can use. It is used to define the block of code that you would want to execute optionally if no errors occur in the try block. So say if the print statement executes successfully, the except statement will obviously not execute because you haven't encountered an exception, but the else statement will execute because the try statement did not have any exceptions essentially. So it will basically print the value of X and then it will print no errors. Then finally, we have the finally block, right? So this particular block of code is also optional in exception handling. You can use this particular block of code when you want to execute a particular set of instructions, regardless of whether an exception is encountered or not. So the finally block of code will execute whether an exception has been found in the try block or whether the try block has successfully executed. It will still execute. So in this particular case, whether the exception prints or the value of X prints, the will always execute will always print. So this is essentially how you handle exceptions in Python. So now that we understand how these four particular clauses work, we can now move on to the demonstration part of this particular tutorial. So let us see how exception handling works in an hands-on experiment. So let us now see some of these exceptions in action. So firstly, let us try to execute the name error. So if we try to do this, A equals to B plus 1, right? And we execute that. So it simply gives us a name error, right? So the way we can deal with this is by simply going over here and adding a try clause, right? So when we add a try clause, we can put a tab statement over here and add in except statement and print the message that we want to print in case this particular exception occurs, right? So exception has occurred. We do that and we click on play. So we can see that instead of this particular statement executing and giving us a name error, we can see the message an exception has occurred, right? So next up, what we can try is something different. We can write over here except name error, right? So this is the category of exception that we want to deal with specifically instead of dealing with all of the exceptions. That is what happened, right? So if we play this as well, we can see the statement exception has occurred, right? So let us try something else with this. We can also add a finally clause over here or an else clause. Let us first try an else clause, right? So when we add an else clause, we can type print no exception has occurred, right? When we do that and we click on play, it still gives us the message exception has occurred because the exception is actually occurring, right? But instead of that, if we simply change the B to 1, right? Now the statement should successfully execute because there is no exception over here now. We click on that and it'll simply print no exception has occurred. And if we type something like print A over here and click on play again, so it'll first print the value of A in the try block, right? And then it'll go to else and say no exception has occurred. So next up, we can try something else. Let us try the zero division error. So in this particular case, what we will do is A equals to 100 modulo 0. Let's try that. And print A, right? Now we can type except name error. So we know that this is not the name error, this is the zero division error, right? But we'll still write that and we'll see which exception is actually caught, right? So print name error has occurred except zero division error will print zero div has occurred. Then we play that and we can see that instead of this particular exception printing, the zero division exception has printed, right? So since we did not catch any name errors, the zero division error was caught when this particular statement tried to execute, right? So instead of that, if we simply go over here and change this to 1, right, it'll simply print the actual output. So when we divide 100 by 1, the remainder is 0, right? We can add something else over here, which is called the finally block, and print hello, right? So in this particular case, what will happen is we play this and we get the 0 from the try block and the finally from the hello block. But that is not all. Say if we change this back to 0, right? Now this means that we get the zero division error once again, right? So now what will happen is we'll get this statement, which is zero div has occurred, in which in this particular case the error was caught, the zero division error, and then the finally block was executed regardless of whether the try block executed successfully or an exception block executed, right? So that is how the finally block works. And finally, to look at the last error, which is the try, which is the type error, we'll simply type try b equals to hello, plus 17, which is an integer value, right? We do that. We type print over here, type b, we go to accept, and we type in the type error, which is the error that we are probably going to catch over here. Print type error, we do that, and then we can try to add an else statement over here. Print the print statement over here will say something like no exception has occurred. And finally, we get the finally block, which says I am going to print regardless. Right? So when we try to execute that, we can see the exact workflow of how this is working out. So the tried statements tries to execute. We get this p equals to hello plus 17. This does not execute because there's a type mismatch, the data type mismatch, string and integer. We go to the type error, right? Now, since an error was actually encountered, an exception was actually encountered, the else statement will not execute as well. So this statement will not execute because error was encountered, right? And then finally block, the finally block that we have over here will execute regardless because it executes regardless anyway. So if we simply go back and change this to say 11, which makes this a valid statement now. So it'll change the output. So firstly, we will get the 28, which is 11 plus 17. We get the 28. We get the output from the else statement, which says no exception has occurred, no exception was encountered. And then finally, we get the finally statement anyway. So I am going to print regardless, right? So this essentially explains how exception handling works in Python. Now, additionally, we have the option of raising exceptions as well, right? So we have the option of specifically specifying conditions in which we would raise exceptions instead of relying on the predefined exceptions that Python already gives us. So say if we want to throw a type error or an exception in general. So let us type in something like x equals to 14. Right? So this is a value, and now x is equal to 14. Now what we can do is simply type in if x is equal to 14, in which case we will write if x equals to 14, and then given the condition of that particular statement, and then what we would do is raise an exception. This is an exception is the message that we're going to use. So when we do that and click on play, it throws that particular exception, which is this is an exception, right? So we can even configure Python in a way, or we can configure our code in a way to throw exceptions on our custom predefined conditions, right? So the raise statement is used for that. We can also do other exceptions with this particular statement. Now, if I simply start a code block again over here, right, I can raise another exception. Say, for instance, I type in a variable. Now I give the variable a string data type. So let us call this string data. Right now, what we will do is we will check the type of this particular variable. Now, to do that, we'll simply type in if not type a. Now we're checking the data type is int, which is the data type that we're actually checking whether the a variable is of integer data type or not. Raise type error and say that integers are allowed. When we do that and we click on play, we get an exception which says the exact message that we typed in, which is a type error and integers are allowed. So that was the example of how exception handling works. I hope you understand the workflow of it and the exact pattern of how these exceptions occur and how you can handle them very easily. You can also see how you can create your own exceptions by using the raise keyword.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
What is an IDE? An IDE stands for Integrated Development Environment. So it is a software application that contains several tools for helping programmers to write, edit, and evaluate their code. So think of it this way. Whenever you're writing code, you need several applications to work together. Things like code editors to write code and save files, compilers to compile the files, to run the files. If you are writing tests, then you need test runners. If you are trying to take a look at the memory consumption of your application, you might be using a profiler. There are many other tools that you can use. For instance, checking the memory leaks, and all of these things can be done using several tools, but they are all interspersed in the coding world. So to bring them all together, what you can do is you can use an application like Integrated Development Environment. So Integrated Development Environment, or IDE, is just a term used to describe such an application, and these kinds of applications are available for a lot of programming languages including Python. So what are the benefits of using an IDE? So let's take a look at them. So there are several benefits of using an IDE or an Integrated Development Environment. Let's take a look at them one by one. So firstly, it allows for rapid development. IDEs provide some really great tools for you to write and edit code in quite a speedy way. They allow you to define code snippets so that you can write just a few keystrokes and expand the code and then fill out the important details. It reduces boilerplate coding. They allow you to generate files. They also allow you to do syntax completion. So if you're typing a long name for a variable or a function or a class, you can just type the first few letters of the entire name and the suggestion will appear, or whether or not you want to use it is up to you. Then comes enforced standards. So many development environments allow you to use something called a linter. What a linter does is it takes a look at your code and it takes a look at a standard that has been set by a company or maybe by you, and it checks whether the code is following those standards. So these standards could be not more than 80 characters on a line, small method names or large method names, methods that are not more than 6 lines in definition. There could be many other standards that you could use. Many companies use these standards to make sure that the code is clean, it's readable, and many companies also enforce standards such as writing documentation, without which your compiler might not even compile your code. So these standards can be set up depending on what your requirements are. If it's just for taking a look at clean code, or whether it's more than clean code, it's more about tooling and all. So these standards can be enforced using an IDE. Then comes easy configuration. You can mold an IDE, especially there are many IDEs that are really easy to configure to your needs. You can change almost anything about many IDEs that you use, going from font to the user interface, configuration about the compilers and interpreters. You can take a look at a lot of things, and you can change all of these things depending on your needs. They do come with a sensible default, but these defaults might not work for you, so you can change them at your own pace. And then comes project management. If you're dealing with multiple projects, then dealing with them without an IDE could be a little difficult. Let's say that your project contains several sub-projects as well. So these kinds of problems can be really difficult to keep track of, and IDEs can help you with that as well. They allow you to export configurations for projects so that you can share that with everyone around your team and they can use the same thing again.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, another thing that project management that comes under project management is version control system. So things like Git, GitHub, Subversion, Mercurial, all of these things, they also come under project management. And many IDEs, including PyCharm, have a really good support for using Git and Subversion and Mercurial and other kind of version control systems. Let's take a look at some of the most popular IDEs. So here are some of the most popular IDEs. As you can see, that's PyCharm, it's IntelliJ, which is also from the same company of JetBrains. Then comes Eclipse. Eclipse is more popular for Java development, but it's not really necessary that it can only be used for Java development. For instance, if you want to use Eclipse with Python, there's an extension called PyDev, PYDEV, that could be really, really helpful. If you are proficient with Eclipse, you know the shortcuts and you want to use Eclipse for Python development. So for that, you can use PyDev extension. It's a little difficult to install, but if you've already worked with Eclipse before, then you already know how to install it. And once you do, you can use Python with Eclipse. Visual Studio comes with a built-in support for Python. So if you want to use, and if you want to install some additional templates and other things like that, they are also available via the use of plugins. Then comes Komodo IDE. It's also very popular, especially in the Python community. So you can use that as well. Then there's RStudio. It's not for Python, but it's used with R. So it's very useful in that regard. And then as you can see comes PHP Storm. So PHP Storm is something that many web developers use. And since many of these IDEs are free and many of these are not free. And when they are not free, then you need to either download a community version, which is a version of the IDE that comes with limited set of features, which are helpful for you when you get started, or you can buy the pro version or the premium version. Many IDEs have different terms for these, or at the end of the day, you can also apply for a student's license, which if you are a student, they can give it to you either for free or for a much reduced cost. So you can take a look at that as well. Then comes Introduction to PyCharm. So let's take a look at what PyCharm is. So PyCharm is an IDE for Python language. It has been developed and maintained by JetBrains. It's currently under active development. New versions are being released every now and then, and new patches are being released every now and then as well. It is one of the most popular IDEs, especially for Python. If you're a Python developer and you are writing code for Python and you're working in large corporations, chances are you have already come across PyCharm. And PyCharm is really, really good for writing code in such a manner. PyCharm has got some really great features. It's got some really good plugins as well that you can use for your Python code. You can enforce standards. You can do a lot of things. Let's have a demo and we'll see how to use PyCharm. So if you want to use PyCharm, the first thing you have to do is you have to download PyCharm. Now it's very easy. Go to Google, and first thing you have to do is you have to download Python. So you can go to python.org, click on downloads, and download the latest version. Mine is 64-bit Windows. So it already gives me that version to download. And if you don't find the version you want to download, you can scroll around and get the version that you want to. Downloading the latest stable version would be the best way to go. After you have installed Python, you can install PyCharm by downloading it. So you can just search for PyCharm. Click on the download link that is given to you in your Google search. When the link opens, it will show you multiple options to download. One of them is the professional version and the other one is the community version. So the professional version is quite useful, especially for those who need the premium features that come with PyCharm. And for those of you who don't really need the premium features, just want to try it out, just want to make sure that you get the basics of PyCharm correctly, then you can download it using the community version. The community version is extremely easy to install and really easy to use, and it's free. And the professional version, although it's not free, gives you a free 30 days trial. So you can use that. It's available for both Windows, Mac, and Linux. I'm using Windows, so I have downloaded Community Edition and I have installed it. Installing it is really easy. So let me just open it for you. I've already installed it, so I'm not going to go with the installation again. But if you want to install it, just open the installer and it will work just fine. After you install it, it gives you the option of opening the PyCharm IDE right there. As you open it, it gives you the opportunity to create a project. If you already have a project, and bear in mind that this has to be a PyCharm project. A PyCharm project basically is a folder with a .idea folder in it that contains all the configuration that PyCharm will use. So you don't need to worry about that. You don't have to use these. You don't have to edit those files yourself. But if you don't already have a PyCharm project, then I would suggest you create one using create new project, which is what I will do. Now, this is just the basic setting. If you want to take a look at some advanced settings, you can take a look at here. Now, you can take a look at the environment that you can use. If you are working with scientific computation, you can take a look at Conda. Pip-N is for creating a virtual environment using virtual-N or Pip-N. I like using Pip-N. It allows you to isolate your dependencies. So if you're trying to use some library such as Django or Flask, but you already have it installed, and now for this project you want to use some new version, you can use a virtual environment in which all the libraries you install will stay in that library, and that for that project only. No other project would be able to access those libraries. So you can use that. And you can take a look at the interpreter. I have Python 3.7. I have Python 3.7, and you can also take a look at Anaconda's distribution of Python if you have and you want to use that. So with that selected, if you have an existing interpreter and you don't want to use the current interpreter, you can just click here and browse for it and then use it. But as of now, I'll be using the base interpreter that PyCharm has already detected for me. I need to change the name of the project. I'll call it Intellipaat demo. I have used pip-n because I find it really easy to use, but it's your choice. If you want to use virtual-n, you can use that. If you want to use Conda as your development environment, you can use that as well. It's totally up to you. Click on create, and the first time you use it, it will take a little bit of a time because it's setting up a virtual environment for you, and virtual environment takes some time. So as I had already created say demos like this, it will create a virtual environment for me, and if it already finds a virtual environment, it will just use that virtual environment. As you can see, it's creating the virtual environment. So let's just wait for a few seconds, and when it gets done, we'll get started with the next steps. Now, if it's just a new installation, then it could take a little bit of time for you. And if you have already installed it and if you have already used it, then it might not take that much of a time. So don't worry about it. It will just take a few moments. And when it does, it will open everything up and it will start creating something called indexes. So let me just tell you what indexes are. They are basically things that your PyCharm IDE will create so that it's easy for it to scan the entire project and find files. So that, as you can see, it's launching the skeleton generator. Everything can be seen here. It's discovering the module, reloading the generated skeleton. Skeleton is basically the project structure that it has generated for us. Now it's telling us that it's indexing, which is basically it's taking a look at scanned projects, and it's taking a look at all the files that we have, so that when we try and scan something or search something for it, will be able to much more speed and accuracy. So now that that is done, we can use Python for whatever we want to use. So as you can see, this is the folder that I have. I can click on this arrow to expand it. As of now, since I used pip, I only have pip file. If I open it, this is what it looks like, and it's giving me an option to install a plugin that will help me create to get syntax highlighting and better support for pip files. I don't need to do that right now. I'll show you how to install packages in a moment. But first, let me just create a file and show you how to run it. To create a file, right click on the project that you want to create a file in, go to new, and I want to create a Python file, and since it's giving me that option, I'll just create on Python. This has to be a Python file, not a Python unit test file, not a Python stub. So I'll just create a Python file. I'll name it main, and I'll press enter after giving it the name. If I don't give it the name, then I won't be able to create any files. It'll create one for me. Now, as you can see, this is fine, but the code editor looks fine. It's working fine. If I type something as you can see, it's working fine. The problem that I have as of now is that the text is really small. So let me show you how to customize Python to your own taste. So go to settings by clicking on file. Once this appears, you can take a look at a lot of things. It opens with the editor setting, but you can take a look at a lot of things. If you want to search for some setting, like let's say font, click here and it'll show you all the things that you care about. I need to change the editor font, so I have that here. Now it is by default using the JetBrains mono font, but I want to use Fira code, and I want to increase the font size, let's say to 18, let's say to 16, and for line spacing I can take a look at this as well. And as you can see, I get this nice preview right underneath it. So after doing that, I can also enable ligatures. So enabling ligatures basically means that it will allow the code to dictate how it wants certain symbols to look. So if I disable the ligatures, as you can see that not equal to will look like an exclamation point and then an equal to symbol. But if I enable the ligatures, then it looks something like this. So the font will now dictate how certain combinations of symbols should look like. I click on apply and then I click on OK, and now as you can see, the font has been changed. Now you can play around with it a bit, but it works fine. Now let me just write some Python code and then execute it so you can see that it works. So the first thing I'll do, and as you can see, I have syntax highlighting. So if I type in name and I get the suggestion that I want, and I want it to be equal to main. Now if you don't understand this, don't worry. This is just some simple Python code, and I'll even show you some resources through which you can learn Python if you want to get started with Python, and you can already see how we can use PyCharm. So I'll just create a function named main, and here I'll just move the code. For those of you who are wondering, I'm using the shift key and then moving things around. So if I use shift and then press down key, PyCharm will automatically insert the pass keyword, but I don't want that, so I'll just do it here. So now what will happen is my script will get executed. It'll take a look at the file name, and it'll take a look at an internal variable called name, which automatically gets set. So if I use this file to execute every other file, then I'll get main, and then it'll execute this function and it will print hello. So to do that, there are many ways I can do it. I can just click here and run it, or I can go to run, click on run, which is here. I click here, I want to run main, and it will run it for me. And as you can see, it's printed hello, and the process exited with the code of 0, which means everything went successful. Now let me show you what else you can do. Let's say that this is not just one file and you use multiple files. So I create another file in which I'll create a configuration class. Let's say configuration helper. Okay, this will be the name of a Python file. I click insert. I'll type in some code, configuration helper. Firstly, I'll define a constructor, and in a moment I'll tell you how I'm doing this. So just type in, as you can see, let me just show you again. I type 2 underscores. It shows me all the things that I can do. I press the tab key. It automatically does everything for me. And now I'll just print construct. Okay. So now if I want to go back to this file, let's say I have multiple files and I've closed this file, first thing you can do is press the shift key twice. So shift 1, shift 2, and you need to do it really fast. And then as you can see, recently opened files are showing here. But if I want to open a file, just type main. It will show me the main method as well as the main file. So let's say that I want to go to the method wherever it's declared. It's showing me the file name right beside the function name as well. I press enter and it automatically takes me to that function. Now that that is done, let me just import it. So I need from configuration helper, import configuration helper. I'm using the control and space key together. So hold down control and press space to get automatic completion. And after doing that, all I have to do is create, let's say, an object out of it. This gets done. So now what will happen is if I run this, I can run it from here, and you can take a look at some of the shortcuts as well, which is Control Shift F10 if you want to run it. So the constructor gets run first and hello gets put second. Now as you can see, I have made a spelling mistake, which is deliberate because I want to show you some of the other features of PyCharm. But first, if I want to go to that file again, hold down Control key and then hover over that class name. I click on that class and I am immediately taken to this file in which I have declared this. Now, as you can see, I have mistyped the name. So as you can see, it's already giving me an option to do something about it. But another thing I can do, and I want to show you this, is select the class name, right click. There's something called refactor. So if you can see, it's here. And then it also gives a shortcut key, which is Shift F10. Click on rename, and I want to rename it wherever I can. And in the project files, you can click on all places as well, so that it can take a look at all the places available to PyCharm and rename anything that's named like this to configuration helper. So as you can see, configuration helper. Now I can click on preview and it will show me all the changes that it will make. So these are the files in which the changes will be made. Click on do refactor. Now it has changed it here, but it has also found out that I'm referencing configuration helper in the main.py file, and it has changed it here, here, and here as well. So these are the kind of facilities that you don't get when you're trying to code it out in a simple notepad or simple text editors. And these are the really powerful benefits that you get when you're using an IDE. Now that that is done, let me just show you another thing, which is the debugging capabilities. So I'll just create another function, print with hello. And all I'll have to do here is I have to print, and I'll do some Python code here. I'll format the string, and inside the format, all I have to do is pass in name. So what it will do, it will take a look at the string, print hello, comma, and then takes a look at a variable. I can remove this as well, and takes a look at the variable named name and prints that for us. Replaces this empty brackets into name. This is what's known as Python string interpolation also. So you can do that as well. And now, just to make it a little more complicated, I'll just create another function, def get config name. And as you can see, as soon as I type this character, which is an opening parenthesis, PyCharm automatically types self, closes the parenthesis, and types a colon for me. And all I have to do is return default config. Save this, go here, and now if I run this, it works fine. We get constructor, we get hello, and instead of doing this, now what I will do is I will print with hello, but I will use the config get default name. And now if I run this, you will see that the execution will be changed a little. We get constructor hello and this. Now if I want to debug this, debugging basically means stepping through the code line by line to see what has changed. Now this is really easy to do, especially in Python. I want to debug from this line, right? So I can, instead of running it, click on debug main, or I can click on debug as well and choose main. As you can see here, if we do that, and that happens, starts debugging, and we get here. As you can see right now, no variables have been declared in memory, so we get nothing. And we get options to step over some code, step into the code, step into to see your code. If it's a library code and you don't want to step into it, then you use this function, which I will do in a moment. And you get to step out. So I want to step into my code and see what happens when this configuration helper gets instantiated. Click here, it opens the file, it gives us the name of the value of the self variable. If I open it, it's giving me the memory location as well. And as you can see, nothing's been initialized as of now. I step in, it prints constructor. If you want to take a look at this, you can take a look at console simultaneously, and you can see constructor has been printed. Now you go ahead, print hello world, take a look at the console, it gets done. Only the config variable has been created. As you can see, there are no variables associated with the config object. And I then step into the function, it returns default config. After that, it steps into the function that we have declared with the print with hello function, prints everything, and then exits, because that was the last line. Everything has been printed, and we have come to the end of our code. So that's how you can debug things. Now that that is done, let me show you something interesting. Let's say that you want to, after going to that, click on settings. There are many settings available for you. You can install some plugins to make changes to the way things work. If you are using Vim as the code editor, then you can install the IDEA Vim plugin. You can change the look at the material themes as well. There are a lot of things that you can install, and these things either upgrade the functionality of some existing feature, or they introduce new features as well. For version control, you can take a look at many other version control systems like Git. If you want to add a GitHub repository, you can do here as well. Mercurial, Subversion. And finally, for our project, we can take a look at Project Interpreter. Right now, we have not installed any package, so we don't have to do anything. If you want to install a package, click on the Add button. And as you can see, it's getting the list of available packages. Let's say that I want to install Flask. This is what the current version is. If I want to install Flask, I can just click on Install Flask. If I want to specify a version, here are the list of available versions. So you can see it's very graphical, very useful. I'm not going to install Flask right now because I'm not going to be using it in this demo, but you can do it if you want. So with that in mind, this is what it looks like. This is what a breakpoint is. So when we were debugging, I put a breakpoint here so that I can just debug my code and the execution will stop here, and from that point on I can just step into the code. So it's very easy to do if you want to do it. So there are a lot of features that I can go into. This could be a really long demo, but to help you get started, I hope this was quite enough and has whetted your appetite. And if the Python code was not something that you understood, don't worry, I'll guide you to the resources that can help you out. But the intention of this demo was to help you get started with PyCharm, to help you understand how you can use the basic features, how you can customize it to your liking. You can change the theme, you can do a lot of things that you want to do, how you can navigate around the code, how you can debug the code. There are a lot of things that you can do.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So with this, let's come to a quick introduction to what Seaborn is. Seaborn is a data visualization tool in Python. So as a data visualization library, Seaborn is considered to be one of these amazing tools that's actually built on top of another library called as Matplotlib. So Seaborn is an extension of Matplotlib in a way where it adds more aesthetics, in a way where it adds more ease of use to the already existing Matplotlib, which again, I'm sure if you read this video, you might have heard of Matplotlib, and there's a good chance you know that it is again a beautiful looking library where you can work with a lot of things and you really don't have to put a lot of effort. So it's nice to work with, it's easy, and if you love data and visualizations, you're gonna thoroughly enjoy the Seaborn tutorial, guys. Well, this is how the pipeline works, right? So this is a very simplified pipeline, so take a look at it. You will find data from multiple sources, be it Excel sheets, be it data from your client's place, be it data on the cloud, be it data anywhere else, right? So data from multiple sources is brought into your company or into your business by a data engineer or so, and then the data scientist sits there and data scientist performs all of these analytics. A data scientist adds algorithms to make sense of this data and then pushes it on to the data analyst team. And you as a data visualization person is a key part of the data analyst team, because in a way with visualization, what you're trying to do is you're trying to make more sense of data aesthetically and in fact, and you have the ability to drive detailed analytics in a way where you will not have to put in much effort, but you can see hidden insights and treasures that lie within the data, which you might not see as soon as you look through it through the naked eye as well. So with respect to that, Seaborn is an amazing tool to use. So why would one go on to choose Seaborn, right? So Michael Wascom is the creator of Seaborn, and he says and affirms to a lot of Python users and a lot of data analysts across the globe that Seaborn tries to make hard things very easy to use. And see, in the world of programming, this is a very bold statement to say, and it's not just Michael who says this. It's a lot of people. It's hundreds of thousands of developers across the globe who actively contribute to Seaborn because it's an open source library, and at the end of the day, it's a common consensus that this is an amazing tool to use. And as soon as we move to the hands-on section at the end of this presentation, you will understand why I'm just saying it's this easy and this fun to use as well. But then at this moment of time, you really have to understand that it's a very powerful visualization tool, and do not be fooled for a second thinking that it is easy, so it's not powerful. Absolutely not. That is the huge advantage when you're working with Seaborn. So now, to understand why you have to use Seaborn, you have to compare it with Matplotlib. Only then you will understand what Seaborn brings to the picture, right? So you cannot have a total head-to-head comparison with respect to Matplotlib because Seaborn is actually built on top of Matplotlib. Matplotlib serves as the foundational library on which Seaborn is built upon, and eventually it's an extension of Matplotlib, if I have to put it that way. But then there are certain differences, and at this point of time, you have to know this if you're looking towards Seaborn as well. So the first most important thing is that Seaborn has a high level interface through which you can work and write code in, while Matplotlib, you really have to think about working with a low level interface. See, the level of interface what we talk about is how easily you can work with the syntax, and how easy is it for you to teach, or in fact convey to the programming convey to the interpreter on what needs to be done how. If it's easy, if it's readable, if it's very similar to common English language, it's a high level interface. If you really have to dig into the details, put in a lot of effort understanding the syntax, put in a considerable amount of time knowing what the syntax does and eventually doing it, well, Matplotlib does that. And if you're beginning to learn Seaborn, this might be a very a big turn off or a disadvantage. But then do not get me wrong here, Matplotlib and both Seaborn are amazing tools to use, but just that with respect to its level of being user friendly, I would say Seaborn wins out here. In fact, even in our hands-on, let's compare what Seaborn and Matplotlib are there, so make sure to stay tuned to that.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And then think about the theming, think about the beautification, think about the aesthetics, think about the control you have over your graphs and visualizations. See, Matplotlib and Seaborn, both of these are data visualization tools. It's going to take in certain numbers, it's going to crunch these numbers, and it's going to give you a beautiful looking graph. It's going to give you an entire sheet full of graphs, or it's going to give you a lot of plots, hence the name Matplotlib. So having the ability to theme it, having the ability to customize it, and having the ability to do this easily, this is where Seaborn wins. Matplotlib of course can do it to an extent, but then it takes a lot of work, and it's not just a lot of work to just have a basic graph or a plot, but then it takes a lot of work to make those plots look aesthetic as well, right? So in today's world, when you're in a business meeting, when you have to pitch the productivity, when you have to pitch the analytics aspect of things to a person who is not into programming, who doesn't like to see numbers, right? So let's say you're in a meeting, rather than showing them an Excel sheet, you would rather present them with beautiful looking graphs to tell them this is where we are, this is where we should go, and all of that, right? Think about it for a second. And this is where Seaborn wins, in my opinion. And then when you think about it, right, a very important thing, if you've used Python and if you've used pandas, if you've used all of these other libraries that are dependent especially to provide data for these data visualizations tools, you will understand how important it is that these tools can understand data from a variety of sources, right? For example, think about data frames. You might have used data frames in the past, but then if you've tried to use it with the Matplotlib functions, there's a good chance you cannot use it at all. But then even if you do, it's very complex to work with, especially especially huge data sets and data frames as well. So in that aspect, again, Seaborn has the capability to handle all your data frames very well and cope up with all of that as well. So in terms of developer productivity and in terms of the basic ability to support another library hand in hand, Seaborn wins in my opinion. Now, after you have understood what Seaborn is, how does it compare with Matplotlib and more, you will have a question saying, okay, I'm on this video and I want to understand how to learn Seaborn. Well guys, I'll not let you wait any further, because you really have to know how to learn Seaborn in a structured way. Well, let me tell you this. It is very similar to learning any of the other libraries in Python, or in fact any other library of any programming language as well. Firstly, you have to take a practical approach, guys. So you cannot sit and read theory and say, you know what, I'm going to implement all of these later after I finish the theory. That really will not work, because I'll tell you why. See, the first thing you'll have to do to become an expert in any of these libraries, which might get complex along the way, is to have a strong foundation. And you can build your strong foundation by learning in context. Like you're learning a concept, you're implementing it, you're learning it, implementing it, and on. So to begin all of these procedure, right, so your step one will be to install all of the dependencies, install Seaborn, and to use Seaborn you have to install other libraries as well. I'm going to walk you through that in a second, but then the step one is this: you have to install all of these and only then you can work with them side by side, right? So it's pretty common and you know that by now. Step number two is to understand the basics and the paradigms of Seaborn. See, you have to know what makes Seaborn what it is, rather than what makes Seaborn stand apart from, let's say, Matplotlib or any other beautiful visualization tool out there. Because if you're honed in on Seaborn, you need to put your time, you need to put your effort into understanding how it works thoroughly. After you understand how it works, then step number three is concentrating on a data set. Take up a data set. Let it be a basic one. You really do not have to start with a very complex data set and overwhelmed and feeling like Seaborn may be a lot for you. And of course that will not be the case, and you will see why, because I have a data set for you guys and we will be working on that. But learning in context by making use of a data set will concrete your learning in terms of practical application along with theoretical learning as well. And of course there's always the last step. In fact, in my opinion, a very, very important step that a lot of people tend to skip is to go around communities, talk to a lot of people who have used Seaborn, make contact, leave them a message, ask them about their journey into Seaborn, see what projects that they're doing, see if you have an idea where you have a lot of data and you want to convert it into visualizations, right? So you can put your ideas into fruition by making use of this. You can implement your projects, you can have your ideas customized, and in fact you can outsource yourself to other people where you can implement their ideas as well, right? Think about it in an experience standpoint, think about it in a monetary standpoint. Again, it's a win-win with Seaborn. Now, you will have a question saying, all right, I am all set. How do I start with this? Well, let me tell you this, guys. To start with Seaborn, right, you have certain dependencies. It's a data visualization tool in a way where you have to provide it with data, right? So to provide data to it, Python has amazing tools, right? Be it numerical computation or any scientific computation, which requires a lot of algorithms and whatnot. You have Numpy, you have SciPy, and then to handle data in a structured way, you have the Pandas library, a beautiful library to work with, which makes Python the beautiful language that is, in my opinion. And of course, since Seaborn is built on top of Matplotlib itself becomes a dependency for Seaborn as well. So to get started with this, it is vital that you understand the basics of all of these libraries, guys. At this point of time, do not worry in case if you do not have the basics of this down yet. You will see that it is pretty simple to work with it. And of course, while working on Seaborn itself, right, you can work on the data aspect of things and eventually start visualizing it side by side too. But then as of now, understand that these are the dependencies and you will have to install all of them as well. So the next question you'll have is, how do I install Seaborn? Well, it's pretty simple, guys. You'll either use the pip installer, the package manager to install Seaborn. It's a very simple command, pip install Seaborn. Or in case if you're using the Anaconda interface, again using the conda command is very similar. Instead of pip, you just just type in conda, install Seaborn, and it will install everything that's required to run visualization as well, right? So that really doesn't take much effort, and I would suggest you guys pause this video right now, install Seaborn in your machines. It's very simple, and I'm going to show you another way where you really can work with an online Python notebook, a Python workbook, where you really do not have to install anything too. I'm going to show you that. Make sure you stick around for just a couple of minutes here. But then before that, right, you have to understand that you have to import all of the dependencies that you've just installed. Just installing it is like, okay, it's on your machine, but then to make Python use all of these, you have to import them into your program. You have to import them into your runtime, right? So that's what we have done on the screen right now. We have imported Seaborn, Matplotlib, Pandas, Numpy, SciPy, and of course any other libraries that you wish to use in your program, or let's say any other libraries that your program itself demands that you use as well, right? So this is a very important step, that you import it and then you begin working with it. But to work with Seaborn, you have certain prerequisites, guys. The first thing is that it is always an added advantage if you understand a bit of computer programming, the basic structure of how a computer programming language works, and the basic structure of even Python will help you a lot, because Seaborn, Matplotlib, Pandas, Numpy, SciPy, right, all of these are libraries for Python. So if you understand Python, then you can use this as a stepping stone to become a better Python developer, or use this to become a data analyst and whatnot. But to go there, you really need to have the basics of Python down, because even though the syntax of Python is extremely easy, as you'll see in a couple of minutes, it is vital, and more than vital, think about it, it's an added advantage, right? If you already know it, you will have a quick head start to eventually go on and work with it. But then yeah, you will require a certain basic idea of how Matplotlib works as well, because plotting a graph is pretty simple, but then you do have to know the syntax on what you're plotting, what type you're plotting, how you can work with the theming, and why the plot shows itself as it does as well, right? So working with basic computer language understanding, Python and Matplotlib can be a good amount of prerequisites. But do not worry in case if you do not have either one of these or all of these. Stick with me till the demo. You will understand how easy a data visualization tool like Seaborn is to use. Now, before we jump right in, you need to understand the features of Seaborn, right? So I've been telling you that Seaborn has been built on top of Matplotlib. In case if you had a question saying, hey, can I replace Seaborn completely with Matplotlib, or can I replace Matplotlib completely with Seaborn and not have anything to do with the other? Well, it's dependent. You can just use Matplotlib and you can still work with it. But to use Seaborn, you really have to know Matplotlib, because since it is built on top of it, well, if you take away the foundation, it really doesn't work, right? Similar principle here. Now, coming to the features of Seaborn, it has a lot of inbuilt themes to work with, beautiful looking visualizations, beautiful looking 2D and 3D graphics are there. You can do a lot of multivariable data analytics as well, right? If it's univariate, it means you're working on one variable. Bivariate is you'll be working on two variables and tracking them actively and driving analytics based on that. And of course, you can visualize all of the linear regression models without having to put a lot of effort as well, guys. Plotting time series data, statistical analytics, and all of the other types of plots is very, very easy in the case of Seaborn. And then when we have to talk about NumPys and Panda, right, the last point you're already very familiar with now, right? So it works really well with all the data handling stuff that Python offers for us, and the other libraries too. So after all of these, in case if you have not had an introduction to Python, you will have this question saying, you know what, even R is a beautiful language to use for data analytics and data visualization, and R has a beautiful data visualization library called as ggplot2 in case if you have used that, right? So you'll have a question saying, why do I have to pick Python? Why is Python amazing for data extraction and visualization? One is that it's very easy to use. You really do not have to put in much effort. The syntax is very easily understandable, even if you're a beginner, or let's say if you're a person moving from another domain. You might be an MBA person, a person in business who loves doing this, who has a requirement to do this. You might be a marketing person. You might be a person who's coming from another programming domain as well, right? So switching to Python is very easy. And after you switch to Python, data extraction and visualization will become very easy as well, guys. And then point number 2 is very simple. It's just that it has a lot of libraries that you can do a lot of things with, right? See, for numerical computation, as I mentioned, you have pandas, you have numpy. For data visualization, you have Seaborn, Matplotlib, and it has hundreds of libraries. So I literally can go on for hours and hours talking about the libraries of Python, what it does, and how you can use it. And you know what, we can actually have a video on that as well, guys. So if you have any video requests, right, head to the comment section and let us know on what topics you want videos about. So this way we can customize it and we can provide you the best content possible. Anyway, coming back, one important thing about Python is that you will have to write a small amount of code to have a huge result. This is the biggest advantage for whenever you make use of Python for data extraction and data visualization, right? So whatever code you write really won't be lengthy, but whatever results you drive out of that code, or whatever the outcome of that code is, right, that will be huge. So that is why Python has become one of the popular languages, in fact one of the most popular languages for data science, data analytics, and data engineering as well, guys. And one last point I have to talk about is Python is a beautiful community. It's an open source language. Most of the libraries, in fact 99.9% of the libraries are open source. So there's a huge community. There's hundreds of thousands of developers across the globe. Interact with them, talk to them, find out about their journey, find out about their tips on how to get started as well, right? Of course, we strive to give you the best content possible, and with the community you can share all of these and tell others about it too, right? So it's all about seeing each and every one of us grow together, guys. And in fact, we have an Intellipaat community as well. So just go to Google after this video, type in Intellipaat community, and you will see that we have experts across the globe and people asking a lot of questions, and people answering these questions and helping each other out. It's a beautiful place to be. I spend a lot of time in the Intellipaat community, so make sure you check that out as well. And now to the most important aspect of this video, right? Let's take a quick hands-on session on how to use Seaborn. And if you're wondering what I'm using here, it's actually Google's Collaboratory. So Google Collaboratory is like a Jupyter notebook, Python Jupyter notebook, but that Google that's completely hosted on the Google Cloud platform, guys. So when you think about it, you really do not have to install Python. You really do not have to install 100 dependencies to work even with the most complex programs. Even the most complex projects that I work on, there's a 90% chance that most of it I can work with Jupyter notebook. You can take your code wherever you want. Let's say you're working from your home on your PC, perfect. You want to take it over to your phone and do something over there, monkey around with your phone and write a little bit of code like you choose. Of course you can do that. That's the biggest advantage, right? And there's an unspoken advantage here. You're using the thorough power of the world's most powerful cloud platform, right? The Google Cloud platform is extremely powerful. They have a lot of manpower behind the technology, and it just makes things easier, guys. I'll just show you how. So coming to the usage of Seaborn, right? So I told you the first step is to install it. The advantage of Google Collaboratory is that it already comes installed and all you have to really do is import them. So let's begin. All I have to do is click this play button, and what it does is it imports all of the packages for us. We're importing Seaborn, we're importing pandas, and we're importing Matplotlib at this point of time. Secondly, as I told you, it's always vital to take a dataset approach, right? Take a basic dataset and work with it. Now, we'll be considering a dataset which is the we'll be considering the iris data set, and I just uploaded the data file for that. So this way, as soon as I click play here, the data set gets completely loaded. sns.load_dataset is probably the most used command for me, especially with respect to Seaborn. So this one command will load your entire data set. Now, to talk a little bit about the iris data set, right? So it is actually a data set which consists of 150 samples of flowers. 3 species of flowers to be very precise. One is the Sentosa, and we have the Virginica, and we have versicolor as well. So what we're trying to do is we're trying to compare a lot of things such as the sepal length, sepal width, petal width, and a lot of other things too. So what does this data set looks like? Typing iris.head will reveal just this, guys. Iris is the name of my data set. .head is basically used to print it out. So as you can see, I have 150 rows of data and 5 columns out here, right? So you can see the type of petals here. There's setosa, there's virginica, and of course once you go on to print everything, you're going to see the entire thing as well. But then sometimes, okay, this is a very simple data set. Looking at it will make a lot of sense, and it'll be very easy. But then what happens is that if you have a complex data set, right, you really cannot print thousands of rows and hundreds of columns. So there's a very simple command to use that, iris.describe. Iris again being the name of the data set. Iris.describe will give you an overall high level presentation of what your data is. You will get a lot of mathematical insight from this. What is the maximum value? You will get the deviations out of it. What is the standard deviation? You get the mean value. You get count as in how many values for each of these columns you have, and so much more, right? So iris.describe, or in fact dataset.describe, is a beautiful command to use in all of Python, guys. Now the fun part starts when we go on to start visualizing some things, right? So let's have a visualization. It's called as a swarm plot. It's pretty common, but then it's very easy to use. All it takes is literally one line of code to create a very good looking plot, guys. So basically sns.swarmplot, x equal to species, y equal to petal length, and we're picking up the data from the iris data set, right? So x equal to species, we're trying to say on the x-axis plot the species for us, on the y-axis use the petal length to describe on the graph, right? As soon as I hit this, you can see this very beautiful looking swarm plot. It's a basic plot, but at the end of the day you will get an idea, right? So with each of these species, what is the petal length that's been plotted, and what is the flower that we're trying to match the petal length with, right? As soon as you start marking the x-axis and looking at the corresponding y-axis, you'll understand how many units of data are present there. In fact, how many categories of flowers are present here. 3 categories of flowers. In each category of flower, what is the average petal length, right? You can see the average petal length of versicolor species lies somewhere between 3 and 5, and of virginica, it has a longer petal length. It goes somewhere about 4.5 all the way till 7, right? So it's a beautiful way that you can look at it. And if I scroll up and if I show you this, it's really hard to sort of drive this insight, right? And it took one line of command for us to say, hey, this is the average petal length. You can find a lot more with this, guys. So this is a very simple example, a toned down example, so that even you guys as beginners can pause the video, type this set of code, work with me. So pause as and when you require, and make sure that you can get this as well. So we will make sure to put the data set. It's the common iris data set. You can just Google it and you can download it from the first link that's available as well. Now whenever you think about plotting it, right, it always adds value if you can see a lot of graphs and drive a lot of analytics out of it, right? So whenever I teach data visualization to people, they're always excited to see a lot of colorful things happen on the screen, and pair plots is one of these ways where you can use a lot of graphs to map a very complex data set and dial it down in a very simple way, right? Just look at this, guys. My programming line was very simple. sns.pairplot. Pairplot is a type of plotting that we use in Seaborn. Iris data set, what's the hue we're mapping on species, what's the size of the entities, it's 2.5. And very simply you can see on your screen, right? So I have 12 beautiful looking visualizations, and you can see the color that it's been mapped, right? So all the blues that you see on the screen is setosa, all the orange you see is versicolor, another type of flower, all the other green dots that you see is virginica, right? So you can see for petal width versus sepal length, petal length versus sepal length, sepal width versus sepal length, and sepal length versus sepal length itself, right? So each of these graphs have a common x-axis and a common y-axis, but then the analytics that you can drive on a whole, right, as pairing, especially when you're performing bivariate analysis where you're using 2 variables to drive any sort of analytics, pair plots are amazing to use, guys. So as you can look on the screen, you can do a lot of things with a lot less code, right? So whatever I said about 5-10 minutes back makes a lot of sense now, I hope. Now all of that is good, but what's the basic difference between Matplotlib and Seaborn? The most basic difference is this, guys. I'm going to show it to you, right? Of course, the first step is always to import all of these code. We're going to have to import all the libraries if we have to use it. We had already imported it before in the first line, and it's still going to stay in the same runtime. But then just to keep it a little separate in case if you guys are, writing a program from scratch again, I've just put it out here. And secondly, we have to create some data, right? So let's create some random data and try to see if we can use this random data to create a Matplotlib plot for us. Creating a plot basically in Matplotlib. So we have 6 lines that's been created out of random data here for us, and do not worry about the data as of now, right? Just look at the quality of the graph. Now let me start using Seaborn. So with Seaborn, the syntax, as you can see, is pretty similar to Matplotlib, but at the end of the day, a direct comparison, even in the most simple looking visualization, you can check out that with respect to Seaborn, it looks a lot more aesthetical than a very shabby looking presentation. Of course, I am a huge fan of Matplotlib, do not get me wrong, but at the end of the day, when it comes to making use of aesthetics, why not go that extra step to make it look beautiful, right? You can make Matplotlib look as beautiful as Seaborn, but it's going to take a lot of effort and a lot of time. So why put in all of that when you can just use Seaborn, which is meant for that, right? I hope you guys got my point here. And you might be wondering, saying, hey, okay, so what are the other good things that we can do with Seaborn? Guys, we can talk over 10-12 hours to understand in depth about all of the data, in depth about all the types of data visualization, theming, customization and whatnot. But my point here is to not overwhelm you guys. So as simple as possible, let me give you a head start in case if you know what histograms is. Again, all we're trying to do is create a random multivariate data for us using a pandas data frame, and we're just trying to plot it one over the other as well, right? So how many lines of code is this, guys? Honestly, this is 4 lines of code, and you have a very complex looking graph. And here, of course, we're trying random data out, but at the end of the day, if this is driving your business analytics, you really do not have to put in a lot of effort to get meaningful insights. That's my approach here, guys. So apart from all of these, now when you think about it, there's so many other things you can do, right? So there's something called as kernel density estimation, or what we call as KDE as well. So you can have smooth estimations based on that. Now with you can see a direct comparison in between a histogram and a smooth comparison, right? A smooth estimation, or a kernel density, or KDE, what we call as, is used to perform a lot of statistical analytics. As you can see, it can be standard deviation, it can be deviations, or any statistical concept usually takes smooth estimations as its output figure as well. So when you think about it, a histogram stands out very much. So if you have a requirement for histograms, yes, it's available. If you want to make use of a beautiful looking smooth curvy if you want to make use of a smooth curvy looking graph where this curve in fact adds a lot of meaning and it's not just aesthetics, then yes, you can use that as well. Now you'll have a question saying, okay, so histograms are good, I can make use of kernel density estimations in a way where I can smoothen things up. Can I do both? The answer is yes. And no, it does not take in 10 lines of code or 12 lines of code. It just takes in 2 lines of code, guys. With 2 lines of code, as you can see, you will understand how kernel density estimation works when it's mapped over a histogram as well, right? So it's a pretty simple thing, pretty beautiful to look at. And trust me, in an actual production environment, right, this can have so much meaning, and you will understand once you're serious about Seaborn, right? So I'm sure you'll be looking into more depth about it. You'll be looking to become a serious data analyst, or a Python developer, or a data visualization professional as well. So when you think about it that way, once you start monkeying around, once you start understanding the in-depth concepts and the offerings that Seaborn offers, right, on the beginner level, on the intermediate level, and even on the expert level, you will thoroughly appreciate the beautiful data visualization tool that it is, guys. So let's say if you want any 2-dimensional plotting as well, again, all it takes is 1 line of code. You're going to be using KDE plot. KDE plot is going to give you a basic 2-dimensional representation of what your random data looks like, and it's random here because we have considered random data, right? So here you can see that data is equal to PD.data. We have a random multivariate data analytics going on out here. But then if the data is not random, then this graph will make a lot of sense for you guys. But then just for the representation's sake, I have tried to keep it as simple as possible, guys. And then you have something called as joint distribution or joint plots as well. With respect to joint plots, you can actually have multiple distributions on the same screen, right? So this is, let's say, a modified version of what a KDE plot looks like, but then that's dialing it down to a lot simple extent, guys. You can you can have multiple plots. That's basically how it got its name, joint distribution. And with this kind of a data, you can try to look at things which weren't visible to the naked eye previously as well. It's just not this, right? Think about it. Totally, how many lines of code have we put down out here? Most of it is importing the data set. In fact, we seeing the data set, describing the data set, and that's about it. As soon as you're done with that, as soon as your data is clean, your data is ready to use, a data visualization guy steps into the picture and does his or her magic as well, guys. So as you can see, a small amount of code, a very big impact, right? So at any point in time, you can pause this particular video, follow along, and we'll make sure that we'll share this particular collaboratory file as well. So this can be handled as a Python Jupyter notebook file that you can use, import it onto your local Python environment and work with it as well, guys. So I hope this Seaborn tutorial was very effective for you guys to get started with Seaborn, and I hope you got to learn a lot from it as well.
REST APIs are quite useful, and Python is quite easy to use when we're trying to build REST APIs. So in this session, we'll take a look at how to combine your knowledge of Python and web applications and how to deliver the data that you want to deliver via a web service or a REST API. And in this session, we'll take a look at what REST APIs are, what are APIs, how do you use REST APIs, and then we'll bring a quick demo in which we'll be using the Flask web servers to build a web API using Python. So without further ado, let's start. But before we begin, if you have any questions, then please do ask in the question section. And for those of you who are joining via YouTube, there's a link in the chat box that you can click to join this as a webinar, and then you can ask me questions in real time so that I can answer them. So let's take a look at the agenda for this session. So in this session, we'll take a look at what are data types. Then we'll take, so we'll take a look at APIs first. We'll take a look at what are APIs. Let's take a look at what APIs are. So an API stands for an application programming interface. So in case you've ever wondered how two applications interact with each other, or how two applications can connect to each other and then can pass messages, then APIs are the way that we do it. So in case you've ever logged into a website and they give you the option to log in via your Google account or Facebook account, you might be wondering how they do that. Do they get the access to the Facebook's database servers and use those credentials to then log into the Facebook's databases and then authenticate you? That's not really a secure way to do it, but a more secure way to do it is via APIs. So that's why we use APIs to expose certain endpoints or certain procedures that other programs or applications can use to talk to us, to describe to our application what data they want, what applications or what processes they want to perform. This API transaction or API communication also allows for a lot of other kinds of applications like cloud computing applications, in which you are basically offloading a lot of your computations to cloud computing. And this is also something that is done via an API. So APIs are quite prevalent, but a particular kind of API is called a REST API. So what are REST APIs? Well, when you take a look at an API, you could be many kinds of APIs, but if you're looking at a web API, then it's most probably a REST API. So REST API is basically a standard. It's an architectural style. It's how you define your URLs so that the person who's trying to get something from your API can describe the best way that he or she can the data that they want. And then our APIs respond to those requests. So these requests work on URL parameters and methods. So to give you a quick introduction, if you've ever worked with HTTP, which is the protocol that the internet uses, there are several methods that you can use. A method is basically just the intention of your request. So for instance, if you wish to get some data, if you wish to get data from a web API, then you use the GET request or the GET method, as is shown in the image below. You use the POST request to submit some data to the web API so that you can save it. The GET request with a ID or a unique identifier gets you a particular record of that. So for instance, if I have a web API that is serving up user information, then I can just tell it to get me all the users or save a user to my database. Or if I give it a particular ID, then my API will check in my database to see if that ID belongs to a particular user. If it does, then I will send back that user. Otherwise, I'll send an empty response. Similarly, if you want to update the information that the person has given, you can use a put or patch request. Now, a put request is basically a request in which you tell it to update the entire row. So all the columns are rewritten. And in a patch request, you just update a particular data field. Nowadays, these are used in conjunction. So both of them are used with each other, but there could be other reasons as well. And then finally, if you want to delete a particular user or a particular record from a database using our REST APIs, then you can basically send a delete request to a user URL by providing a particular ID. Now, one thing you will notice is that I've written /users. So the URL is not going to be like that. It's going to be the localhost URL. You can type http:// and your entire web address to the API, and then /, and then from there the API's URL will be like the one that you're saying. So for instance, api.mywebsite.com/API/ and then I send the request to the user's URL. This will get me all the users. Now, APIs can be really, really more complex, and APIs are built around the idea of resources. So resources are basically things in our databases. So it could be users, blog posts, comments, anything like that. And instead of us then using the user's URL, we use the blog post URL. So instead of going api.mywebsite.com/users, I'll go api.mywebsite.com/ and then blogs or comments. And then I can use the same request pattern that I'm using here by providing an ID, get a particular ID, so on and so forth. So that's how that works. Now let's take a look at REST APIs in Python. So Python is quite easy to use when it comes to building REST APIs. In Python, you can use many of the available frameworks or libraries or any other kind of software package that you can to build a REST API. Now, Python is quite versatile, so you have a lot of options when it comes to building a web API in Python. You have Django as a framework. Now, it's a full-blown framework. It's not a micro framework like Flask and Web2Py. Mainly because in Django, you get a lot of functionalities out of the box. You don't need to configure a lot of things. You get a web server, you get database interactions, you get validations, you get template rendering. There's a lot of things that you get out of the box for free. On the other hand, frameworks like Flask and Web2Py, they provide the basic functionalities that they think is required for a web API. And the other tasks, such as interacting with the database, caching the data, other things, you can build on your own, or if you want, you can probably use a plugin that has been built to integrate with the framework. So there are a lot of things that you can mix and match when it comes to Flask. So when it comes to using micro frameworks over full-blown frameworks, it really comes down to your choice. You could use a full-blown framework if you choose to. The problem there is that then you lose a lot of flexibility. You would have to, if you want to use your own caching mechanism, you need to figure out a way to integrate it with the framework. On the other hand, if you use micro frameworks like Flask, you get to choose your own ways of doing things. You get to decide how you want to cache data. You get to decide how you want to validate your data and how you want to parse the requests and responses. So you can do it that way as well. Depends on the application, depends on the team size, depends on a lot of factors when building a REST API. Now let's take a look at a demo. So before we take a look at the demo, you should have an application called Postman. It looks like this. You need to have this installed on your system because we'll be firstly taking a look at how to send requests and get response back. So this is a client that allows us to send HTTP requests and analyze the response that we get back. Now, I have already created the code for API and we'll walk through it. And mainly what I've done is I have created a folder called user API. Inside it, I have installed Flask, and that's the only thing I've done, and I'll show you how I did that. So I go into the user API folder. Now I am using something called pip-env to do that. Now pip-env is quite useful. In case you want to know what pip-env is and how you use it, we have other sessions on that as well. But to give you basic understanding, a pip-env or a pip environment is basically something that allows us to create a virtual environment for our application. So any software package that I install for this application will be confined to this application. On other folders, other applications, I won't be able to use the same frameworks and the same libraries. So in case tomorrow I decide to build another web API, but not using the Flask current version of Flask, but an older version of Flask, let's say Flask 0.8, I won't have to uninstall the current version and then reinstall version 0.8 for that particular application. I can just use a pip environment and do that. So after doing that, I can just install using pip env install Flask. Now I already have it installed, so I think it's going to not work, or it's going to say the requirement is already satisfied. But in case you are going to install it on your system, then you can, as you can see, the installation succeeded quite fast because it's already installed. But
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In case you're doing on your system, then you will get a much longer description of the steps that have happened. Now, that's the only thing that I need you to install, Flask. Other than that, we are going to be using in pure Python. So you go to the folder and you create an api.py. And then you create two other folders, a user model and a user service. So let's wait for it to open. So our goal with this API is to build an API in which a user can access users in our database. So if someone sends a request to our web API, then they can access our users in the databases, and they can store and they can do a lot of other things as well. So I'll just reconfigure my IDE. Now it works. So to give you a brief understanding of what I'm doing, I have firstly imported Flask, request, and JSONify from our application. I'll explain why we're using that in a moment. And we have imported from user service, we have imported the user service module. So when we go to this folder, we have imported user service from here. Now what's going on here is that I have created a Flask application and I have instantiated my service, and I'll explain why we have separated these things out. And this is the piece of code that you need to write if you want requests from other origins. So when you're building a REST API, then this is something that you need to add. This is something that we use to allow requests from other origins. This is to allow us to get away from an error called course error or cross-origin request error. Basically, what we're doing here is we're telling any other website that tries to access data from our website, it's going to be fine because we allow them to do that. So with that, now we'll go to the routes. So these are the URLs that we had already discussed. If I want to get all the users, I want to respond to my web address /users. So it will go here and it will get all the users using the user service and then JSONify it. Now we'll take a look at what these things are doing. We go to the user service, and in the service, all we're doing is we are taking the model and then we are getting data from the model. The reason why I am just forwarding the request here is because in services, you can do a lot of things. So if I had a caching service, then I could probably cache the data that I get from the user and then use that there as well. But I don't need to do that. So in the model, all I'm doing is this. Let me just open up the model for you. Here's the model. I'm importing SQLite 3, and then I'm creating a model. Inside it, all I'm doing is connecting to a database named todo.db, which exists already here because I've already run it. Then I create user table. So what this function is doing is that it's taking a look at whether or not is a user table exists or not. If it does not exist, then it creates it. And if it exists, then the query doesn't get executed. So we take a look at this. We take a look at, we create an ID, which is a unique field and primary key. Take a look at the email and password. All of these are not null. And then finally, after doing that, I just create a row factory. If you work with SQLite 3, you'll understand why we do this. But basically, we want data to be given to us in the form of rows. And finally, when the user model is deleted, I want to commit the changes that I made to the database, and I want to close the connection so that there's no memory leak. Then for get all users, I use the select ID, email, password query from user table. I execute the query, and then I return the result in form of a dictionary. If this code looks a bit difficult for you to understand, that means that you need to understand this dictionary and list comprehension. And if you want to learn all of these things, then stick around with me till the end of the session, and I'll show you a resource for you to learn these things. So all you have to do here is, after converting it to a dictionary, we return it back. And then when we return it, our user service will return the data that we have fetched and converted into a dictionary. And that data, it then gets returned in the form of JSON. So JSON is basically something that's called JavaScript object notation. It's a format in which we exchange data from one service to another service. Earlier, we used to use XML, but XML was not very easy to use and very difficult to parse, took a lot of computation, the size of the our request would response would get really large, because XML requires a lot of closing tags and opening tags. So with that, we come to the other route that we have described. But before that, let me just show you how to check whether or not it's working. I've already created the requests for you. So I open the request, and by the way, if you want to create a request, just click on new request. After that, put in the address. I've not started my web server, which I will do now. Just type Python space, and my file name is api.py. Press enter, and this starts. So it's showing me that it's starting on localhost :8001, which is the web address. And if I open it here, as you can see, we have opened /users on our base URL. If I send a GET request here, as you can see, we get the username and password that's already stored in our database. Now, let's take a look at what else we have. We have a way of getting a particular user in the database. We'll take a look at that in a moment. And we also have a way to save user on our database. We do the same thing. We go to our service, and the service is basically delegating the task to a model. And in the model, we're just creating the user. So in the user model, I go and create user. I get the data from the parameters. I get email, I get password, and then I just save it using the insert command. And then you just return back the last row ID, which is basically the last thing that you inserted, and you get it by user ID. So let me just show you how this is working. Firstly, let's try and add a user. So suppose you are trying to create a form that submits user data. So go to body, and let's say instead of I create james@example.com, and password is abcd@123. Now I send the form data with the request using a post request, and it sends me back the data that I got. So this is the one that I have. And now if I want to get a particular user ID, I can get the data associated with the first user ID, which is john@example.com, and I can get the second one as well. And I've gotten that as well. Now, another thing we can do is we can update the users. So to update a user, all you have to do is, again, use, as I've already told you, we can use the put and the patch requests. So for the put and the patch request, we update user by ID. We take the user ID from our URL, which Flask does for us. So the benefit of using a framework is that it does a lot of request parsing and things for you. So you don't have to go look at the entire URL and then find out what are the parameters that are passed to me. Flask will do it for you. It passes in the user ID, and all we do is we call the service.update method. We go to the service, and again, update is doing the same thing. It's delegating to the user model. And we go to the user model and we take a look at update user by ID. By the way, for getting user by ID, we're doing the same thing, just checking if user ID is there. Then we connect to the database, we fetch the result, and then we send it back as a JSON. And finally, we get the update user function, in which we basically use the update query. We set the username, we set the email, we set the password, we execute the query, and then we get the updated user using the last updated ID or the current ID that was passed to us. ID will never get updated, so we just update email and password, and using the ID that we have. And then if we take a look at whether or not it's working, we go to update user and go to body. As you can see, I've written the ID as 1 and the method is put. So instead of Jane, let's say johnny@example.com and password is this. Now if I send this request, I've updated the ID. It's now Johnny, and if I now try to get the users, let's try and get all the users first. And we get Johnny and James. So Jane has been updated. And if I get by an ID, I think I've updated it to be the first ID. And as you can see, the changes have been persisted to our database. And finally, if you want to delete a user, basically send a delete request to one of the users. Now, deleting is a special case, mainly because if I open the api.py file, as you can see, I use the delete method. It's the same thing that I've done before, delete user by ID. I send the request to services. In my user service, I use the delete method, and inside it, I just pass it to the model. And inside the model, all I'm doing is I'm deleting it. But the thing is, I'm taking a look at how many rows were affected by the last query. So if it was affected and 1 row was affected, then the status is 200. Now let's understand HTTP status codes. 200 basically means in HTTP protocol, 200 means that everything went okay and as expected. 404 means that the thing that you were trying to access was not found on the server. So we send the status as well as the affected rows back to the user. The service returns the same thing back to the API, and the API converts it into JSON and then send it back to us. So I go to the web API, and in the delete users part, if I send in an ID that does not exist, I get the response of status code 404 and 0 rows were affected. But if I send in an ID that does exist, I get row count of 1 and status of 200. But if I do it again, then again, since row of ID 1 was deleted, then we don't get that. Now, this is how you use it to check whether or not it's working or not. Now, the main benefit of creating a REST API is that you can now create web applications, you can create Android applications, you can create any kind of application that can access this API. So I've created a really small function here. Here, all I've done is I've gotten data back from the API and then displayed in the table. It's a very simple use case. If you want to take a look at the code, let me just show you. This is what it looks like. Now, again, if you don't know HTML, don't know CSS, just stick with me till the end of the slide and I'll show you. Basically, what I'm doing is I'm creating a table, adding this header here, and then basically getting data from the users and then converting that data into HTML elements and then adding it to our HTML web page. This is what it looks like. Let me try and add another data and then this will be fetched dynamically. So if I add another user and instead of James, I type in John. Save it. Now you get the ID to be 3, name, email, and password. So if I refresh this, as you can see, I get both the usernames and passwords that are available in our database. So that way you can build a REST API quite easily. Now, again, this was a very rudimentary example, mainly because REST APIs are quite deep topic and they take a lot of time to cover. But this should give you a basic understanding how you can use Flask and how you can do it. Now, another question that you might be wondering about is why are we separating things into other files like user model and user services? We could have just created it in the same folder and then called the queries and all. But when you're trying to build a good application, main things that you need to consider is separating things into smaller pieces and then separating those responsibilities into other classes, functions, modules, etc. So, for instance, the reason why we are using another layer of service instead of just using the model is because if in future, let's say that you get a assignment that says that this API is working, but we want to convert it into JSON, but not in JSON, but we want to convert it into XML and we want to cache it as well. So for caching it, you can just go to the user service, add your caching code here, and it will work just fine. And for sending it back to the user as XML instead of JSONify, you can use another function. So instead of you having to then dive deep into the code and then figure out which line or which file of the particular project do I need to change, you already know how to do it. And it's easy to understand as well. We can just take a look at the application and understand the flow of request and response. And finally, we are just running this application in debug. Debug allows us to take a look at errors if we run into any. And we also take a look at port. So the port is 8001. You can change it here. This is exactly why I'm getting my API running on the 8001 port. If I change it there, it will be changed here as well.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Just a quick info, guys. Test your knowledge of Python by answering this question. Which of the following is not a keyword in Python language? A. Val. B. Raise. C. Try. D. With. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what will we be doing in this session is that we'll be taking a look at the global data for the COVID-19 that's available. It's an open source data, so you can use it whenever you want and however you want to. And we'll be building a model that can tell us the number of confirmed cases and fatalities that are expected to occur the next day. And that will be done by analyzing the trend of the data that we have right now. So with that in mind, let's take a look at what we have next. So let's take a look at the data that we'll be using. Now, the data, as I've already told you, is open source, so you can use it whenever you want to. But basically, we'll be using the global COVID-19 data. So this data contains information about countries, it contains information about regions, it contains information about the population, and it gives you a column named target. Target basically tells us that the data we have is of either the confirmed cases or the number of fatalities. So as you can see in the screenshot that I have right below me, we have cases for Afghanistan and we have certain columns that are having the values of NAN. NAN stands for not in number or not available. So the problem is that when you have a data set, there are many times when you don't get the data that's completely accurate. There are going to be some missing values. There are going to be some values that are out of order and not in the correct format. And there could be a lot of other things. So that would be the problem. So if you want to get this data set, you can get it from Kaggle, and that will explain to you how there are competitions going on COVID-19. This data is available on Kaggle right now. You can take a look at the COVID-19 competition, and you'll get the data, you'll get the problem statements and everything, but just the data is enough for you to get started.
We'll see the learning path for Python. So for a beginner, you must start with OOPS concept, input-output operations in Python, error handling, looping statements, and libraries of Python. So you need to first master these fields. You need to work on these fields in order to master the basics of Python. Then you have to decide which field you want to master, either data science, machine learning, artificial intelligence, game development, or web development. So accordingly, you can choose the framework that you have to learn, such as for Django, Django is used for web development. For game development, we use Pygame of Python. Then PyTest is used for testing. Then Pandas, Matplotlib for data science. TensorFlow for machine learning and artificial intelligence. So there are hundreds of packages that are individually used for these fields. So you need to master the use of these packages and libraries by implementing it. So you should select a use case or a basic project of your choice so that you can use these frameworks for working on basic projects to clear the concepts. And finally, you should move on to working on real-time projects that will help you to gain hands-on experience, and that will help you to provide experience in working on projects, how an organization implements a project using Python. So this will help you to become an expert or a professional in Python and master the field related to it. So this is the learning path for becoming an expert in Python if you are a beginner. Now I will tell you some of the useful resources that we provide to master Python. So these resources are blog and tutorials, YouTube videos of Intellipaat that you must follow to learn the basics of Python, and along with it you can learn various frameworks such as Pandas, Numpy, scikit-learn, Django, along with their implementation in real time. We also have a large community where you can post your question and clear your doubts and queries. We also provide a comprehensive training on Python. So let me take you to the course page. So this is our Python certification training course. So there are instructor-led training and self-paced training. So instructor-led training consists of 42 hours of comprehensive training, 50 hours of project work and exercises. Then it has a flexible schedule and 24/7 lifetime technical support and access. So if you will be having any doubt or queries, it will be cleared by our experts at any point of time. So it has 24/7 lifetime support and access. After the completion of the course, you will get a certificate and you will be assisted for the job. Also, we have 24 hours of self-paced training videos that you can enroll for, and in this instructor-led training you will be guided by an industry expert on the subject. So let us check the course content. So the trainer will be starting with the basics of Python, and then OOPS concepts in Python, database connections, Numpy for mathematical computing, that is again a framework of Python, then SciPy, Matplotlib for data visualization, Pandas for data analysis, exception handling, multi-threading, packages and functions, then finally web scraping with Python. So this is the course curriculum. Now you can also check out other courses. So you can go to the course section. So there are master programs on various technologies, on big data, data science, business intelligence, Salesforce, cloud computing, mobile development, digital marketing, and so on. So Intellipaat also provides free courses. So you can go to Intellipaat Academy and check out our free courses that we provide, and these are just the demo courses, and you can watch. Now you can go to the last section of this website and you can go to the blogs that we provide, the interview questions, the tutorials that you can go through. So these are the blogs. We regularly update and post our blogs on various technologies. So there are interview questions. There are interview questions according to various technologies. So if you want to learn Python, then there are top Python interview questions. Then going to tutorials, you can go to, so there are tutorials for various technologies that you can go through. And for programming, so here is Python tutorial that you can go through for learning the basics of programming.
So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'd have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it would be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key which is 3 and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary. And we can create a dictionary with the help of these curly braces over here. So I'll give in the key name which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run. And we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2 and house number 3 are our real world entities which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create two variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name, and after this I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object, right? And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard, right? So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be getAge. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self.age equals input again. Right. So we have created two get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def and I'll create the method to be put name. Again, this will be self and I'll just print out the user's name. So your name is self.name, and then similarly I'll create another method which would be put. Methods would help me to print the name and age of the person. Right, I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the getName and getAge methods. So person1 dot getName. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right. So now it's time to get the age of the person. So I'll type in person1 dot getAge. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right. So we have successfully created our class which would print out the name of the person and the age of the person. Right. So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method, right? So we have created our init method, which is basically a constructor, and going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this, we have age. So let me change this to be age over here. And this would be self.age. After this, we'll have to print in the branch. So let me just put in branch over here. And this would be self.branch, right? So we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now, since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use this super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A. and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again the syntax would be the same, np.array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3, and the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 numpy array comprising of all the zeros. So it's a 5 cross 5 numpy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the numpy library. Let me just type in import numpy as np, and inside a I'll just state np.zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out a. So we have successfully created our 5 cross 5 numpy array where all of the values are just zeros. Now let's say we have two numpy arrays like this. So this is our first numpy array, this is our second numpy array. First numpy array comprises of 1, 2 and 3. Second numpy array comprises of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7 and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the numpy library, import numpy as np. I will go ahead and create my first numpy array, a equals np.array, and the values are 1, 2 and 3. Similarly, I'll create my second numpy array which is b. I'll change this variable to be equal to b, and the values are 4, 5 and 6. Now to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the numpy arrays which I'd have to add. So I want to add a and b, and I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a numpy array. So this is our numpy array over here, and this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68, and I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Ctrl X, I'll do Ctrl V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X, and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this NumPy array. So 168 are the two highest values from this NumPy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as PD. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4, and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24, and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango, and orange, and the count of the fruits is 12, 24, and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, petal width, and species. Now out of this we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as PD, and after this, to load a CSV file, I'd have to use the pd.readcsv function, and I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this dataset, iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal dot width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we given the first condition, where sepal length is greater than 5. After that, we'll use the AND operator, and then we get the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be pandas and numpy. So import pandas as pd and import numpy as np. After this, I'll load the iris dataset. So iris equal to pd dot read csv, and I will pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column and the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified dataset. So iris1.head, right? So we see that this is our original data frame, and with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the pandas data frame. I'll type in import pandas as pd. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readcsv function. And I'll give in the name of the file, which is enhance.csv, and I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this na function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels. So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right? So we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here. Right, so this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in 2 parameters. The first parameter is just the path, and after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right. So this is the sentence which was stored in this file. This is para and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda and then you'll give in all of your arguments. After that, you'll put in a colon and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda and I'll give the name of the variable to be a. I'll give a colon and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x.
Just a quick info, guys. Test your knowledge of Python by answering this question. What do we use to define a block of code in Python language? A. Key. B. Brackets. C. Indentation. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So this is how we can create a simple lambda function. Now, I'll call the function and pass in a number. So let's say I'll pass in 8. Now, this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10. And the title of the plot is y versus x label is x-axis, y label is y-axis. So a simple line plot, and we can create this line plot with the help of the Matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the Numpy package. So I'll type in import Numpy as np, and I would also need the Matplotlib package. So I'll type in from Matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x and I'll get the values with the help of a range. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt dot plot, and I'll pass in x comma y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title. plt dot x label. So the label would be x-axis. Similarly, plt dot y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt dot title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the Matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange, and we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From Matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list, right? So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1. Right, so this is our numpy array which comprises of the numbers from 0 to 9. And we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the NumPy library, import NumPy as NP. After this, what I have to do is create my NumPy array. So ARR equals np.arange and it will go from 0 to 10. Let me just print out this NumPy array over here. This is my NumPy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So ARR %2 and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1 and 9 with -1. Now we'd have to perform an operation so that we get the common items between two NumPy arrays. This is our first NumPy array. This is our second NumPy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays. And I'd want to extract these two. Right, so we have created our arrays over here. This is the first NumPy array and I'm storing it in A. This is my second NumPy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d and I just have to pass in the two NumPy arrays inside this as the parameters. So A, B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here and we'd have to convert each of these elements into title case. So Mary had a little lamb. So we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as PD. Now I'll create the series pd.series and I'll pass in the values which are basically Mary had little lamp. Right, so this is done and I'll store this in, let's say, SER. So I have created my series. I'll just print it out now, right? So this is my Panda series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital, right? And as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a Panda series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x, colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to SER. Now let me print SER over here. Right, so all of these elements have been converted into title case. So now we have the same Panda series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3 and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this Panda series. Import pandas as PD. Let me again create the series. SER equals pd.series and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this Panda series, I'll have to use the map method. So ser.map, and inside this, I'll again create a new lambda function, lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside a. Right, so we see that the length of the word Mary is of 4 characters. In had there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s_length. Let me load the package, import pandas as pd, and I'll also load the file. So pd.read CSV, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s_length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here. I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s_length. So it'll be s_length. So this is how it goes. So iris.rename, and the original column name is sepal.length, and I'd have to change it to s_length, and I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1.head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the pandas library, import pandas as PD. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Knox, RM, and so on. And MEDV is my target and my feature is RM, or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target, right? So pd.dataframe, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in xtrain, xtest, ytrain, and ytest. So xtrain would comprise of all of the training values or all of the training records for the features. And xtest is basically the test set for the features. Ytrain is the train set for the target and ytest is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor and I will fit this model on top of xtrain and ytrain, or in other words, I'm fitting the model on top of the train set. Right. So now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, ytest and ypred. So ytest comprises of all of the actual values and ypred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length, and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70-30. So I'll start by loading the requisite packages, which are numpy and pandas. So import numpy as np and import pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal length, petal width, and the species column. Now out of this, the species column is our dependent variable, and these four columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first 4 columns. So I'll just extract sepal length, sepal width, petal length and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'll have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics and we'll also get the accuracy score. Right. So this is my confusion metrics and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right? So you see that all of the species of Setosa have been classified correctly. When it comes to versicolor, 16 of them have been classified correctly and 2 of them have been classified incorrectly. And when it comes to virginica, 13 of them have been classified correctly and 2 of them have been classified incorrectly. So to get the accuracy, we'll have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same and it comes out to be 91.11.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So guys, we have come to the end of the session. Hope you all enjoyed it. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.